Hello everyone, welcome to this DevOps Full Course 2024 by Intellipaat. This course has been designed considering the current industry trends. Also, the tools that we are teaching in this course are according to industry norms and versions. Not only that, the free DevOps course is being taught by our industry experts from companies like Microsoft, Google, and Amazon. The objective of this DevOps tutorial is to help developers and students from computer engineering background to learn the fundamentals of DevOps concept so that they can go towards the DevOps engineering role. We are going to begin this DevOps training with a comprehensive introduction to DevOps. Then we will cover version control with Git, containerization using Docker, configuration management using Ansible, etc. Next, we will dive into the heart of DevOps principle, CI and CD. We will cover continuous integration with Jenkins, continuous orchestration using Kubernetes, and continuous monitoring using ELK. After that, we will cover Terraform modules and workspace. And finally, we will take you to the important interview questions that are most commonly asked in DevOps interview. However, before we go ahead and start with the DevOps platform full course for beginners, let us discuss a bit about DevOps. Since the very beginning, software development had two main departments, a development team that code, design, and builds the system, and an operations team for testing and implementation of a developed software. Back in time, the operation team used to give the development team feedback on any bugs that needed to be fixed and any rework required. While the operation team used to do this task, the software team would be sitting idle, waiting for the feedback. This problem is used to extend timelines and delay the entire software development cycle. There were instances where development team used to move on to the next project while operation team used to come up with the feedback and reiterations. This was also used to create clashes between the teams, and to solve that, the term DevOps was coined. DevOps find the sweet point between development and operations and make software development a continuous process. Under a DevOps model, development and operation team work together across the entire application lifecycle from development and testing to development and operation. Everyone on the team understands both development and operation principle, making them highly efficient. In a nutshell, this is what DevOps is. And with this free DevOps full course, we are going to teach you the tool stack you need to operate in this role. But before we begin with this DevOps course, hit both the subscribe button and the bell icon for Intellipaat YouTube channel.
The word DevOps is a combination of the terms development and operations, meant to represent a collaborative or shared approach to the tasks performed by a company's application development and IT operations teams. Let's assume that Gary is a DevOps engineer working for Instagram. His job is to collaborate with different teams and make sure the DevOps pipeline is running smoothly to release frequent updates. Before Gary, Instagram used to create and release updates after every 2 months. But when Gary joined as the DevOps engineer, the plan was to release updates every 3 days to keep the users happy. Now users are more happy as they can use new features on a daily basis and get what they ask for due to the faster release cycle. DevOps teams use various tools to automate and accelerate processes, which helps to increase reliability. A DevOps toolchain helps teams tackle important DevOps fundamentals and go through its phases including continuous integration, continuous delivery, automation, and collaboration. Teams use various DevOps tools to help them facilitate a DevOps culture in their organization. Most teams rely on specific tools for their pipelines, building custom toolchains that fit their needs for each phase in the application lifecycle. DevOps cloud teams use tools like Docker, Selenium, Jenkins, and Kubernetes. These are just a few tools amidst an array of DevOps tools. DevOps influences the application lifecycle throughout its plan, develop, deliver, and operate phases. Each phase relies on the other and the phases are not role specific. Plan. In the plan phase, DevOps teams ideate, define, and describe features and capabilities of the applications and systems they are building. They track progress at low and high levels of granularity, from single product tasks to tasks that span portfolios of multiple products. Develop. The develop phase includes all aspects of coding, writing, testing, reviewing, and the integration of code by team members, as well as building that code into build artifacts that can be deployed into various environments. DevOps teams seek to innovate rapidly without sacrificing quality, stability, and productivity. Deliver. Delivery is the process of deploying applications into production environments in a consistent and reliable way. The delivery phase also includes deploying and configuring the fully governed foundational infrastructure that makes up those environments. Operate. The operating phase involves maintaining, monitoring, and troubleshooting applications in production environments. In adopting DevOps practices, teams work to ensure system reliability, high availability, and aim for zero downtime while reinforcing security and governance. Professionals can become a DevOps engineer coming from different backgrounds. A DevOps engineer should have various skills and they can't just be DevOps tools. Let's have a quick look at the other skills a DevOps engineer should have. A DevOps engineer should have one high-level programming language like Java, C++, or C#. Should also know Linux, SQL, cloud technologies like AWS, Azure, or GCP, scripting languages like Perl, Bash, or Python. On an average basis, DevOps engineer earns 5 lakhs per annum to 14 lakhs per annum in India, while in the USA, a DevOps engineer earns from $125,000 per year.
Okay. All right. So now let's start. So first we will be talking about what is software development. Okay. So software development is the process of converting the customer's requirement into a technical product or into a software product. Okay, so what is software development? It is the process of converting the customer's requirement into a software product. Okay. So let's say there is a company, let's say that there is a startup. Now this company or this business wants to develop a website. Okay, suppose this startup is an e-commerce startup. So they want to build a website. They want to build a website, okay, to showcase their services and to sell their products. Right. So this company will go to a software company which has expertise into software development. Okay. This company, the startup, will go to a software development company with their requirement for building their product. Right, the product could be a web application, it could be a mobile application. Right. So in software development, we have 5 phases. Okay. We have 5 phases in software development. First is the requirement phase. Second is the design phase. Third is the implementation phase. Fourth is the verification phase. Fifth is the deployment / maintenance phase. Okay. So in software development, we have these 5 phases. Okay. So any company or any business or any person who wants to start a business, right? So they will be having a requirement, right? That they want to build a website with this features, right? Where they can showcase their services or whatever product they are selling, right? So they will go to a software development company, right? And in software development company, they will be telling their requirement. Okay. In a software development company, we have BAs, BA guys. Who are BAs? BA are business analyst. Okay. Business analyst will talk with the customer and they will gather their requirement. So in the requirement phase, the BA guys, business analyst, gathers the requirements of the customer. Okay, so in the requirement phase, in a software company, we have BA, business analyst, and the business analyst basically gathers the information from the customer. Okay, like customer will be telling that I need this website, the website should have this features, right? So BA gathers the requirement from the customer. Then we have design phase. Once the information is gathered, once the requirement is gathered, then in companies we have technical architect. Okay, technical architect, or we can also call as solutions architect. So what this guy does? In this phase, the technical architect or the solution architect designs the architecture of the application. Okay. The technical architect or solution architect designs the architecture of the application. Architecture in the sense, let's say suppose the customer has a requirement of building a website with let's say some features, right? So the technical team, I mean the technical architect or the solution architect, based on the customer requirement, will basically design the architect of the design the architecture of the application. Architecture in the sense, what programming language to use, what database to use, right? On which infrastructure they are going to run the application on, right? So those things are basically taken care in this phase. Okay. Here the technical architect will, based on the customer requirement, will choose the programming language, database requirement, right? The architecture, the infrastructure architecture, right? And if the application requires any notification service, emailing service, right? So depending on that, in this design phase, the architecture of the technical architecture of the application will be built. Then in the third phase is the implementation phase. Here we have developers. The dev team write the code. So suppose the customer wants to build a website, right? So the BA team has gathered the requirement that the customer wants to build an e-commerce website with this features. Then the technical team, the technical architect or the solution architect will design the architecture, like this programming language to use, this database to use, these servers to use, or this server platform to use, right? Then the developers in the implementation phase, the developers will be writing the application code, right? They will be writing the code to build the website. Then we have verification phase. So in verification phase, we have testers, or we have QA guys, quality assurance guys who takes care of once the dev work is done, it is verified by the testers to check if the software developed is meeting the customer's requirement or not. Right. So in this phase, the testers or QA guy will be checking whether the application which is developed by the development team, whether it is meeting the customer's requirement or not. Plus, they will also check whether the application has any bugs, right? During, whether the application has any bugs or whether it is passing the test cases or not, which are written by the testers, right? Then we have deployment or maintenance phase. In this phase, we have operational team. Okay, the operational guys. Once the application is developed, and tested, then it is deployed to the production environment. Okay, once the application is developed and tested, then it is deployed to the production environment. What is production environment? Production environment is the environment where the application goes live. Application goes live in the sense the end users, the customers, will be able to access the application. In production environment, the application goes live, which means the end users, the consumers of the application, will be able to access the application. Okay, and it also takes care in this phase. It also, if there are any optimization / enhancements is required, that is also taken care in this phase. Okay, so in the fifth phase, the deployment maintenance phase, this is the phase where the application goes live. Okay, or this is the phase where the application is handed over to the customer. Okay, the customer who was looking for the application. So in this phase, the application either is deployed to the customer or is made live, so that customers, clients can access it. Right. And further, if the customers require any optimization or any kind of enhancement in the application, so that is also taken care in this phase. That is also taken care in this phase. So BA stands for business analyst. Okay, these are all IT roles. BA is business analyst, technical architect, solutions architect. In a software company, we have business analyst, we have technical architect, solutions architect, we have developers, software developers, right? Software development, yes, we have software developers, we have testers, okay, we have quality assurance team, right? Then we have operational team, which takes care of the production environment, right? Deployment of the application and also maintaining the production environment. Right. So we have these 5 phases in software development. So this is how basically a software is developed. Okay. Now to implement these phases, okay, to implement these phases, we have software development life cycles, SDLC. Okay, with software development life cycles, we are implementing these phases. Okay, with software development life cycle, we are implementing these phases. So let's not get into that depth into roles. What is the role of technical architect? There are a lot of roles, right? Technical consultant, and a lot of roles are there, right? Which are some, I would say, more or less, I mean, the same thing. I mean, the roles wise, mostly it is the same. Okay, so to implement these software development phases, we have software development life cycles. So these software development life cycle have the standards to implement these phases of software development. Okay, like we have waterfall model, we have agile model, we have lean model. Okay, so these are some of the software development models which are currently used in the industry. Okay, so we have the first one is waterfall model. So this model was the very first model introduced in SDLC. Okay, so this was the first model. Waterfall model was the first model which was introduced in software development lifecycle. So Raga Sandhya is asking, how can DevOps team do enhancement? Will they have technical knowledge on the software? Very good question. So Raga Sanan, if you have just joined now, so this is the agenda of the session. So we will move the session by step. Okay, so your question I will answer when we will be talking about DevOps. Okay, so those who have joined just now, please ensure to join the session first of all on time. Okay, by 7, please try to join the session, or by not 7, I mean 5 minutes before the session starts, please try to join the session. Okay. And this is the agenda of today's session. Software development life cycles, problems before DevOps, what is DevOps, DevOps tool. Okay, so we will go step by step. So Rohit is again asking the same question, what is DevOps? So Rohit, here we have 4 topics in our agenda, what is DevOps? Right now we are on the second topic of our agenda, which is SDLC. So please take care of the agenda. So we will move based on the agenda only. Very good. You have just seen the agenda. That is good. Okay. So coming back to SDLC. Yeah. So we discussed that to implement the software development phases, we have these software development models. We have waterfall model, agile model, and lean model. Out of which waterfall was the first model introduced in the software development lifecycle. So when this concept was introduced of software development lifecycle, which is nothing, which is basically about, which is all about implementing the 5 phases of software development lifecycle, which are these phases. So with the help of software development lifecycle, we are implementing these phases. Okay, and to implement these phases, we have software development models. Okay, we have waterfall model, we have agile model, lean model. There are a lot of other models also available in the industry. Okay, but these are, I would say, the standard models which are currently used in the industry. Out of which waterfall model was the very first model introduced in software development lifecycle. Okay, so each of these models have, I would say, almost the same phases which we just discussed in software development. Okay, end of the day, software development lifecycle is basically implementing these phases only, right? So in each of these models, we have I would say almost the same phases, right? So in waterfall model, we have the requirement phase, then the design phase, then implementation phase, verification phase, and the deployment phase. So in each of these software development lifecycle, we almost have the same phases. Okay, we have the same phases. Right now in waterfall model, so almost in, I would say, on all the models, we have the same phases, but there is basically a difference of approach. Okay, there is a slight difference of approach of implementing these phases. Okay, so in waterfall model, let's understand this with an example. So let's say there is a customer, and the customer wants to build a website, and the customer has a requirement that the website should have 3 pages. One should be the home page, service page, services page, and contact us page. Okay, let us take one more. Let's say about us page. Okay. So let's say there is a customer, and the customer has a requirement to build a website, and he wants these 4 pages. One home page, one services page, one contact us page, and about us page. Now let's say the company is building the software with waterfall model. Okay, so in that case, there will be the requirement phase where the BA guys will be gathering the information from the customer. Then the design phase. In the design phase, depending on the customer's requirement, the technical architect will be designing the architecture. Okay, the technical architecture, like which programming language to use, which web server to use, which database to use, depending on the customer requirement, right? Then in the implementation phase, the developers are going to write the application code for the website. Then the verification, in the verification phase, the application will be verified by the testers, whether it is meeting the customer's requirement or not, or whether it has any bugs, or whether the application is faulty, right? So that will be verified in this phase. Then in the deployment phase, once the application is developed and tested, it will be deployed to the customer, or it will be deployed to the production environment where it will go live. Right. So in waterfall model, whatever the customer's requirement is, everything is taken care in a single phase. Okay. First, the requirement will be gathered. Let's say the customer has this requirement. Then in the design phase, depending on the customer requirement, the architecture will be designed for the whole application. Okay. the architecture will be designed for the whole application. Then it will go to the implementation phase. Then in the implementation phase, the developer will write the code for the whole application. Then in the verification phase, the whole application will be tested. Then it will be deployed to the, it will be delivered to the customer, or it will be deployed to the production environment. Right. So in waterfall model, we have to follow a sequence. Okay, we have to follow a sequence, and the whole application is developed at once. Okay, the whole application is developed at once. And one more thing we have in software development lifecycle, which is customer feedback. Okay, so in waterfall model, we have the customer feedback once the application is delivered. At that time, we have the customer feedback. Now, suppose if the application is developed and the customer wants to make some changes. Now, let's say the customer plans, let's say in services page, I want some other design, or I want to make some changes in the application. Okay, I want to add new pages, or I want to customize the application, or I'm not happy with the application, or the customer wants to make changes. Let's say the customer mind changed and he wants to make some new changes in the application. Right. So in case of waterfall model, the application will be again, it will be designed. Designed in the sense, again, the technical team, the technical architects will be making changes in the architecture depending on the new requirement of the customer. Then again, it will go through the implementation phase where the application will be developed with the new changes. Then again, it will be verified. Then again, it will be deployed. Okay, deployed or delivered to the customer, and then customer will give a feedback. So overall, the procedure used to take a lot of time. Okay, this procedure in waterfall model used to be very time consuming. Plus, in waterfall model, we have a sequential approach. Which means until the application is fully developed in the sense, until whatever the application requirement is, let's say the customer requires a website with 4 pages. So until the full application is developed, until then it will not go to the next phase. Okay, until it will not go to the next phase. So this is, I would say, a biggest drawback in software in waterfall model, because it has a sequential approach. So suppose if it is a very big application, right now we are taking a very small example of 4 page. Suppose it is a very big e-commerce site where the customer wants a dedicated product page where, let's say, product page for TV, for electronics, let's say for footwears, right? So suppose, let's say the customers require multiple pages, or suppose the customer wants to build a website similar to Amazon or Flipkart, which is a very big application which has multiple pages, right? So if the company is going to follow the waterfall model, so it is going to take a lot of time to develop the application. Because in waterfall model, there is the sequential approach. Sequential approach in the sense, until the design is not completed, it will not move to the implementation phase. And until the full code is not developed, until then it will not go to the verification phase. Which means, let's say the developers have created these 2 pages. They are done with 2-page development. They are not done with all the 4 pages. So they cannot move the code to the verification phase. In waterfall model, we do not, until a particular phase is completed, until that we do not move to the next phase. Right. So it used to be very time consuming, right? And as the application used to take a lot of time to be developed, so that used to result in bad customer experience. Okay, because suppose let's say the application is taking 1-2 months to be delivered, and let's say after 2 months the customer mind changed, or depending on the business requirements, let's say the customer mind changed. Okay, so that will lead to customer dissatisfaction, right? Because if the requirement is not fulfilled, or it is not as expected by the customer, then the customer will be unhappy. Right. So in waterfall model, we used to have a sequential approach. Okay, until a specific phase is not completed, then it will, the project doesn't move to the next phase. Right. So overall, it used to be very time consuming. Okay, and it basically used to take, let's say, depending on the application, it used to take months or years to develop the application. If it is a very big application, it will take a lot of time. Right. And if it is going to take a lot of time, and in between, let's say the customer's requirement wants to make some changes in the application. Okay, so that was actually not supported in waterfall model. So initially, let's say the customer has given this requirement of building a website with 4 pages. So that was all which was taken care of. Suppose in the middle phase, if the customer wants to make any changes in the requirement, suppose now let's say the customer wants few more pages. So that was not entertained or was not supported in the waterfall model approach. Right. To solve this problem, we have agile model. Okay, we have agile model. So this was basically the drawback of this model was it was very time consuming and it had a sequential approach. Right? It used to take a lot of time to get the application delivered to the customer. And if the customer wants to make any changes, so that was not supported. So whatever requirement the customer has given initially, the application will be developed based on that requirement. If the customer wants to change in between, so that was not supported in waterfall model. Okay, so if the customer has a small requirement, or I would say waterfall model is good for small projects. Small projects like a small website which can be delivered in few weeks. Okay. For such projects or for such software development requirement, we can use waterfall model. Now let us talk about agile model. Exactly, Hindu is completely right. If customer asks for rework, let's say if the customer wants to make any changes in the existing requirement, then it will start from the starting phase. Again, the customer's requirement will be gathered. Then the technical architect will be making changes in the architecture based on the use case. Based on the new requirement. Again, the code will be developed. Again, it will be verified. Again, it will be deployed. And again, customer feedback will be given. So overall, in waterfall model, we used to have a sequential approach. And no customization was supported in waterfall model. Okay, so if it is a small project, then companies basically use waterfall model. But if it is a very big project, which may take months or years to be developed, so in that case, companies do not prefer using waterfall model. Okay. Okay, so the next model we have is agile model, which is solving the problems which we used to have in waterfall model. So in agile model, here also we have those 5 phases. which is the requirement phase. So in Agile model, also we have the same phases, but there is a slight change in the approach. Okay. See, overall, in all of these software development life cycles, we have the same phases. Okay. Majorly, the phases are same. The only difference is of the approach. So in Agile model, here also we have the requirement phase where the customer's requirement is gathered. Suppose the customer has this requirement. Okay, initially, let's say for developing 4 pages. Okay. So in the requirement phase, the requirement will be gathered. Whatever the customer has the requirement, let's say building website or application, that requirement will be gathered. Then it will go to the design phase. Now, if you see here, we have multiple design phases. Okay. So in case of Agile model, the work is done parallelly, or I would say the work is split in different chunks, in small chunks, or I would say in smaller parts. For example, let's say the customer has a requirement of building a website with 6 pages. So in Agile model, let's say the customer wants to build these pages. Okay. So in Agile model, the work will be divided into small parts. Okay. So let's say these 2 pages will be taken care by one team. These 2 pages will be developed by another team. These two pages will be developed by another team. And the whole work will be done parallelly. Okay. The whole work will be done parallelly. Whereas in case of waterfall model, all the pages will be developed at once. There will be only one team who will be working on all the whole application. Whereas in case of Agile model, we have different teams. Okay, we have different teams who will be, the big project, the whole big project will be split into smaller parts. Okay, so let's say in this case, 2 pages will be taken care by team A, 2 pages will be taken care by team B, or 2 pages will be taken care by another team. And all the teams will be working parallel. Okay, so as multiple teams are going to work, and as the software development will be parallel. Okay, so the software development delivery, the delivery to the customer will be faster. Suppose if the same application is developed through waterfall model, so let's say it is taking 1 month. So with Agile model, we will be able to deliver the same project within few weeks. Okay, we will be able to deliver the same project within few weeks, because here multiple teams are working and the development is parallel. Whereas in waterfall model, everything will be developed at once. Okay. So let's say the customer has requirement of developing these 6 pages. So the work will be divided into smaller parts. Okay, work is divided in smaller parts. So first, depending on these 2 pages, the technical architect will be designing the, or I would say the design phase will be, yes, the technical architect will be designing the architecture based on the requirement of the customer. Let's say for these 2 pages, then it will go to the implementation phase, then it will go to the verification phase, then to the deployment phase, and then customer feedback will be taken. Customer feedback will be taken for these 2 pages. In waterfall model, everything is done at once. The customer will only get the application or the software developed once the whole application is developed. But in agile model, the work is delivered in smaller chunks, smaller parts. So once, let's say, this part is completed, so that will be delivered to the customer. And then customer can give the feedback. Okay, let's suppose the customer is wants new changes. Okay, so here in this in agile model also we have the same approach. Like again, it will be go to the requirement phase, then to the design phase. But here rework is supported. Rework, or I would say if the customer wants to make any changes in the requirement, so that is supported. Okay, let's say the customer wants some changes in the home page. So the team who is working on this particular part, that team will be making those changes. The whole application will not be impacted with that particular change. But here in waterfall model, the whole process needs to be restarted. The whole application needs to be developed again. Right. So once small parts of the application is developed, the customer feedback is taken, and based on the customer feedback, the application, the team then again makes changes in the application. So by this methodology, by this agile model, we are able to deliver, or I would say the software companies are able to deliver the application faster. Okay, the companies are able to deliver the application faster, as there are multiple teams working here. Multiple teams working, and the whole, I would say, big application is split into small parts. Okay, and each part of the application is delivered, is taken care by individual teams. Right, so the development is faster. Plus, after completion of, I would say, each module, customer feedback is taken. Okay, after development of each module, customer feedback is taken. And if the customer wants any changes, so that the changes in the application, so that is also supported in agile model, or that is also taken care in the agile model. We are not splitting the work in different chunks. See, these are all standards of implementing software development the software development phases. So in waterfall model, we follow a sequential approach. Okay, there is nothing wrong with waterfall model in case if we have a small product, small application. Okay, if there is a small application which needs to be developed, then in that case the company can go with waterfall model. No need to split the application into small parts if it is a very small application. But if it is a very big application, so in that case companies prefer agile model, where the big application, big requirement of the customer is split into smaller chunks, smaller parts, where multiple teams are working. Okay, depending on the customer requirement, let's say it is going to take months or years to develop the application. So in that case, basically we follow agile model. Okay, and right now in the industry, most of the IT companies follow this agile methodology. Okay, see, these things which we are learning are, I would say, just for our knowledge purpose. Okay, just we are building a base. Okay, no one will see whatever we are currently learning is more, I would say, this particular module is more for a project manager. Okay. The project manager basically takes care of the whether to which model to use for implementing the software development. Okay, so we don't have to go that much in depth about these models. Okay, we just need to learn high level about these models, fundamentals, the base thing. And this thing we are learning to prepare a base to learn other things, which we are going to learn as part of DevOps. As a DevOps engineer, we will not be choosing what model to use, whether waterfall model, agile model, lean model. We don't have any relationship with this thing. The project manager will take care of that. Okay, this is the job of the project manager, engineering manager. Okay, they basically take care of these things. Director, okay, they basically take care of these things. Okay, so the problems which we had in waterfall model are solved through agile model. Okay. Now we have one more model, lean model, which is completely similar to agile model. Okay, whatever features we have in agile model, the same features we have in the lean model. Okay, the same features we have in the lean model. Just in the lean model, there is one difference. There is one new thing added, which is in lean model also takes care of enhancing the development team or enhancing the process. Okay, so let's say in agile model, suppose this is lean model. In lean model also we have the same phases. Okay, in lean model also we have the same phases. Lean model is completely similar to agile model, but there is only one difference, which is lean model also takes care of enhancing the process. Okay, it also takes care of enhancing the developer knowledge. It also takes care of enhancing the overall process. Okay, which leads to faster development, which leads to customer satisfaction. Okay, so that is the only thing which we have additional in lean model, which is taking care of the, I would say, going through the, enhancing the approach or enhancing the process. Okay, suppose let's say to develop these 2 pages initially, let's say the developer took 5 days. Okay, so in lean model we will also be taking care how how this can be optimized, how it could be delivered just in 2 days, or how it can be delivered earliest, so that the the development can be made faster, plus the as the application will be delivered faster to the customer. That will also lead to customer satisfaction. Right, so lean model only takes care of additional thing which we have in lean model is it also takes care of enhancing the process. So Ramesh, I just explained that the difference between lean and agile model. See, lean model and agile model are completely same. Okay, the phases which we have in agile model, the same phases we have in a lean model. The only difference is that in lean model, I would say we also take care of enhancing the approach, enhancing the process. Okay, it also takes care of enhancing the process. Okay, like what automation can be involved to make the development faster. Okay, so those things are basically taken care in lean model. That's the only difference between lean. Okay, now in software development we have 2 teams. Right, in software development we have 2 teams. One is the dev team and one is the ops team. Okay, one is the dev team and one is the ops team. Okay, Amar, here we are learning DevOps. We are not learning project management. Okay, if you want to learn project, want to learn more about, if you want to become a project manager, in that case, basically we have to learn in detail about these models. Okay, in our course, we just have the introduction to these models. Okay, we don't have in depth. We are not learning in depth because that is not part of DevOps. Okay, so in software development, we have these two teams. One is dev team and one is the operational team. So dev team takes care of developing the application code. Okay, we have dev team. The dev team takes care of developing the application code. The operational team takes care of building and deploying the application to the servers. Right. So in software development, basically we have these two main teams. One team takes care of developing the application code. Another team takes care of building and deploying the application code to the servers. Now, before DevOps, we used to have this kind of approach. Let's say there is a dev team. Okay. Let's say these are the developers, and the developers are writing the code and they are pushing it to a code repository. Okay. So once they are done, so this is basically a code repository. Okay, code repository just is a kind of storage where the code is kept. Okay. So yeah, we have a code repository where the developers are keeping the code. Now, once they are done writing the code, okay, once the development is done, they will notify they will send an email to ops team that the development is done. Development is done, and now you can go ahead with the deployment. Okay. So once this is done, they used to send an email. They used to notify the operational team that the application development is done. Now you can do the deployment. So then the operational team used to manually pull the code. Okay, they used, let's say this is a build server. So they used to manually copy the code to a build server where they used to build the code. Okay, where they used to perform, they used to build the code. Okay, build the code in the sense, suppose it is a Java application or Python application. So we cannot directly deploy the application to the server. Okay, before deploying a Java or Python application, first we need to build the code. Build the code in the sense like we have to compile it. Plus, if there are any project dependencies, so that will be added to the project, right, to the application, right? So that is basically taken care in the build server. Okay. If you are not aware about any programming language like Java or Python or what is building the code, don't worry about that. Later in the course, we will learn in detail about what is building the code. Okay. For now, just understand building the code means adding dependencies related to the project. If you are familiar with Python, so in Python code, we add like in the Python code, we write the code this way, right? Like we import some modules, like import OS, import sys module, import MySQL module, right? And let's say suppose I'm handing over this code to someone, let's say to another developer. So first, another developer before running the code needs to add the project dependency, right? Like we run this command pip install, right? We run the command pip install and then the module name first to download the project dependency, and then we will be able to execute it, right? So the same thing is done by the operational team. So whatever code is written by the developer, let's say this is the code which is written by the developer. So before deploying it, they used to add dependencies to related to the project. That is what is called building the. Okay. Then once the code is built, then it will be tested. Or suppose, let's say during building the code, there is a failure. Okay, failure related to any dependence. Okay. Then the operational team used to send email to dev team of the failure. Okay. The operational team used to send email to the dev team of the failure. Okay. They will send an email that the application execution failed because of so and so reason. Okay. The application is failed because of so and so reason. Then again, they used to make changes in the code. Then again, they used to send the dev team used to send an email to the ops team that the code is now developed. You can now proceed with the deployment. Then the operational team again used to clone the code. Then they used to build the code. And if again there is a build failure, then again they used to send an email to the dev team that the code failed because of so and so reason. Then again, the dev team used to make changes in the code. And again, they used to notify the operational team that the code is now fixed. Then operational team again used to build the code. Now, if the code is built successfully, then it is moved to a testing server. Okay, if the code is built successfully, then it is moved to the testing server. Okay, so in testing server, we have testers or the QA guys who write manual test cases or used to perform manual testing. Used to perform manual testing. And suppose performing the manual testing, if the application is failing any test case. Okay, suppose for example, let's say the developers have written a code of a website. Now in the website, let's say they have created a sign up button. Okay. Now when the testing team is clicking on the sign up button, the application is not responding or is not behaving as expected. Okay. So then the testing team will notify the dev team that the test case failed. Okay, let's say whatever the test case was, that the test case failed. Then again, the dev team will make changes in the code. Then again, they will notify the ops team. Ops team will pull the code. Then they will build the code. If there is build failure, then again, they will notify the dev team. And again, the dev team will make changes in the code. Then again, the ops team will build the code. And if the build is successful, then it will go to the testing team. And now if it passes the test case, then it will be moved to another stage. Okay, then it will move to the another stage. So that stage will be staging environment. Okay, test cases will be written by the QA guys. Okay, QA guys or the testers will be writing the test cases. Okay, depending on whatever application is, suppose it is a web application, so they will be writing test cases related to the functionality of the application. And there are different types of testing frameworks as well, like we have or different types of testing as well, like smoke testing. We have unit testing. Unit testing actually is taken care by the developers itself. We have sanity testing, which is functional testing of the application. So that is taken care by the testers. Okay. So if the application is now working fine, I mean, it is tested, then the application will be deployed to the staging environment. Now, what is staging environment? So staging environment is also called the pre-prod environment. Okay, let's move to the stage production environment as well. Then we will come again on staging environment. Okay, so as we discussed, production environment is the environment where the application goes live. Application goes live in the sense the end users will be connecting to the application, right? So production environment will be having the servers, the database servers, which will be used by the application. And this is the environment where application goes live to the customers. Okay, application goes live to the customer. Okay, in this phase, the application goes live to the, in this production environment, the application goes live to the customer. In staging environment or in the pre-production environment, we perform testing. Okay, or before deploying the application to the production environment, the application is first deployed to the staging environment. And the staging environment is completely replica of the production environment. Suppose in the production environment, you have 2 servers, 1 load balancer, 1 database. So the same kind of environment you will be having in the staging environment or pre-production environment. Okay, the same kind of environment we have in the staging environment or the pre-production environment. So whatever server configuration we have, the same configuration we'll be having in this environment. Overall, it is a replica of production environment. So before releasing the application to the production environment, first we deploy the application to the staging environment. And if it is working fine in the staging environment, then definitely it will work fine in the production environment. Why? Because the server configuration of the environment configuration is completely same. Right? So before DevOps, we used to have these phases. Right? So the dev team used to write the code, then ops team used to build the code. If there is any failure, then they, so overall there used to be a lot of back and forth between the ops team and the development. Right? There used to be a lot of back and forth between the dev team and the operational team. So if the code is failing, then let's say if the code is not built in the production environment, I mean in the build server, the development team used to blame the operational team that you don't know how to build the application, or you're not adding that particular project dependency. That's the reason that the code is not building. And then operational team used to blame the development team. Okay, most of you would be able to relate if you are working in already in a organization. So this happens, right? There is a lot of back and forth between the dev and operational team. Right? So now this problem is solved with DevOps. Okay, this problem is solved through DevOps. Yeah. So we have this staging environment just to ensure, or I would say just to test the application, we can say. Before releasing the application to the production environment, in the staging environment, we are checking whether the application is working fine or not. If it is not working fine, then we will not release to the production environment. Suppose if we don't have the staging environment and if we are directly deploying to the production environment, and then in the production environment, we came to know that the application is not responding or has some other issues. So that will lead to business loss. That will lead to business loss. Right? So to prevent such scenarios, we first deploy to the staging environment, which is completely equivalent to the production environment. So here in the staging environment, we check whether the application is functioning fine or not, is working fine or not. If it is going to work fine in the staging environment, then it will work fine in the production environment as well, because we have the same infrastructure, same configuration. So if it works fine in staging, then it will work fine in production as well. If it is not working fine in staging, then we will not deploy it to the production environment. And that's the overall purpose of having pre-production and production environment. And right now we are only talking about two phases or two environments. In companies, we have like multiple environments, like we have dev environment, then we have testing environment. Some companies have UAT environment, UAT or SIT environment. Then they have a staging environment, which is the pre-prod and prod environment. Right. So depending on how critical the application is, so depending on that, companies have different environments. Okay, to ensure when the application goes live in production, there is no fault. Okay, there is no bugs, or there is, overall, it should not impact the business. Okay, in stage environment, can we have load testing? Because in production environment, very good point. So Nathan Kumar is asking, in staging environment, can we perform load testing? Because in production environment, we will get, in production environment, the end customers are going to access the application, right? Suppose, let's say the application has 100 customers, just an example. So 100 people are going to access the application in production environment. But in the staging environment, the internal team is only going to access it, maybe 5-10 people. So we will not be able to perform load testing. We will not be able to check whether the application, how much traffic the application can handle, right? So yes, we can also perform benchmark testing or load testing in the staging environment to check how much traffic the application can handle. Okay, so that is also part of testing only, which is the load testing. So where we can use different tools like JMeter to perform the load testing of the application to check whether the application or the infrastructure is able to handle the traffic or not. Yeah. Okay, so before DevOps, there used to be a lot of back and forth between the dev team and the operational team, and everything used to be manual. The very big problem was everything used to be manual. So manually, the operational team used to pull the code. Then if the code is tested, built successfully, then manually they used to push it to the testing server. Then manually, the testing team used to perform manual testing. Then again, it used to be manually deployed to the staging server. Again, manually, it used to be deployed to the production environment. So as it was manual, so it used to be little time consuming. Okay. Plus, there used to be a lot of back and forth between the dev and operational team, which used to take a lot of time in delivering the application. Okay, which used to take a lot of time in delivering the application. Okay, so now let us talk about what is DevOps and how DevOps solved this problem. So what is DevOps? DevOps is a methodology with which software development lifecycle is automated. Or in simpler terms, DevOps is all about automating the software development lifecycle. See, these phases which we discussed, or these, these different, I would say, environments which we discussed. So these are all the phases. Okay, or sorry, this is what? This is overall the software development lifecycle. Right? Overall, what is this? This is software development lifecycle. So with DevOps, we are automating the software development lifecycle. Okay, in simpler terms, it is all about automating the SDLC. It is all about automating the automating the software development lifecycle. And how we automate the software development lifecycle? So in DevOps, we use different tools. Okay, in DevOps, we use different DevOps tools, or we can also call them as automation tools. Okay, so to perform the automation in the software development lifecycle, in DevOps, we have automation tools. Okay, we have automation tools with which we automate the software development lifecycle. So before DevOps, we just discussed here that there used to be a lot of back and forth between Dev and Ops team, plus everything used to be manual. Now with DevOps, now here also we are going to have a code repository. Okay, now in DevOps, once the developer pushes the code to the code repository, the code will be automatically pulled by the build server. Okay, the code will be automatically pulled by the build server. So for this, in DevOps, we have an automation tool, Jenkins. Okay, Jenkins is basically an automation tool with which we implement building and testing phases in the software development lifecycle. Okay, so we have Jenkins. What Jenkins will be doing? Once the developer pushes the code, suppose the developer has pushed the code to the code repository, Jenkins will pull the code immediately. This tool Jenkins will immediately pull the code. Earlier, before DevOps, the dev team used to send an email to the ops team. Okay, once they have pushed the code to the code repository, they used to send an email to the ops team that the development is done. Then operational team used to manually pull the code to the build server. But here in DevOps, we are using the automation tool, Jenkins. What Jenkins is going to do, once the developer has pushed the code, immediately it will pull the code. It will pull the code. It will build the code. And while building the code, if there is any code failure, okay, suppose at the building phase there is any failure, so it will immediately notify the developers by an email or by Slack notification that the application failed, the application build failed immediately. Okay, once the developer is done pushing the code to the code repository, immediately Jenkins will pull the code. It will build the code. If there is build failure, immediately it will send the email to the developers. Then the developers are going to make the changes in the code. Again, they are going to push it. And immediately, once they have pushed the code, Jenkins will pull the code. Jenkins will pull the code. It will build the code. If the code is built successfully, then it will push it to the testing server. Okay, it will push it to the testing server. And here, instead of manual testing, we will be having automated testing. Okay, instead of manual testing, we will be using automated testing. Okay, so for automation testing, we are going to use automation testing tools like Selenium. Okay, so we are going to use here automated testing tool. We have Selenium. We also have SonarQube. Okay, so this automated testing tool will test the code. once the code is built and tested, then it will be deployed automatically to the staging environment. Okay, it will be deployed automatically to the staging environment. And if it is deployed, once it is deployed to the staging environment, then it will be automatically deployed to the production environment. So in DevOps, we have end-to-end automation. End-to-end automation of SDLC, software development lifecycle. We have end-to-end automation. Whereas before DevOps, before this automation came in picture, there used to be a lot of back and forth between the development team and operational team. They used to send each other a lot of emails that try adding this module or try adding this particular dependency in the project, then try to build it. So there used to be a lot of back and forth. But with these automation tools, the developer gets immediate feedback. Okay. Earlier, before DevOps, it used to take days for getting a feedback from the operational team. So that used to impact the release time for the application. But here, once the developer pushes the code, immediately Jenkins will pull the code, immediately it will test it, build it. And if there are any build failures, it will send a notification to the developers that the build failed. Then developer will make the code changes. Then they will, once they have again pushed to the code repository, then again Jenkins will pull it, it will build it, and then it will move to the testing server. And let's say if there is any test failures. So again, the testing tools like SonarQube or Selenium, we can also configure mailing on them. So the testing tool, automated testing tool, will send an email to the developers that the application testing failed. So in that, the testing server will be sending a notification. If the test cases fail, it will notify the developers that that particular test case failed. And again, the developers will make the changes. Once the developer is done making the changes, the build server will automatically clone the code, build it, then move to the testing. Then if the testing is also passed, it will be deployed to staging and then to the production environment. So overall in DevOps, we have end-to-end automation, and this automation we are performing with automation tools. In every stage, we have an automation tool involved. Okay, like for staging production environment, here also we have a couple of tools involved. Like we have Terraform, which is used for deploying the infrastructure, deploying and managing the infrastructure. Then for application deployment, we have one tool which is Ansible, okay, with which we can push application code changes to the let's say staging server, to the production server, right? Or if we want to make any server related configuration changes, so we can use these tools. We can use Ansible, right? So overall with DevOps, we are automating end-to-end the software development lifecycle. And how we are automating it? We are automating it with the help of automation tools. Okay, we are automating it with the help of automation tools. How is the terminology Jenkins came? Very good. So how it is connected to AWS? So he's talking, Rohit, here about AWS. We are not talking about here AWS, right? We will talk about AWS, how it is linked. We will talk about that later. Yeah, Jenkins is used for CI/CD purpose. That is fine. So I hope, Ketan, it is clear to you what we are talking about Jenkins here. Okay, so right now we are just understanding these tools at the high level. I mean, even I'm not talking in detail about these tools. Okay, each of these tools we are going to learn in detail. Okay, these all tools we have in our course. So each of these tools we are going to learn in detail. So right now we are just understanding high level. Later in the course, we will learn about each of these tools in detail. Every tool which right now we are discussing, we have in the course. Okay, and once the agenda of the session is done, after that I'll I'll walk you through what tools we have in our course and the learning part. Yes, means the coding team will only, the dev team will only share the code and everything will be automated. Okay, everything will be automated. So this automation, the automation of the software development cycle is taken care by DevOps engineer. All right, so the job of a DevOps engineer is to build automation in software development lifecycle. Right? So DevOps is all about automating the software development lifecycle with DevOps automation tools. Okay. So we have Jenkins, we have Selenium. Jenkins is basically used for build and testing. Okay. Then we have Selenium, SonarQube. These tools are for automated testing. Then we have Terraform. It is a infra automation tool. Okay. With Terraform, we can automate the infrastructure. I hope you guys are familiar with AWS. Please confirm on the chat if you are familiar with AWS. I think you guys are coming from the cloud one, right? Cloud batch, I believe so. Very good. Okay, so with Terraform, or so far in the AWS course, you would have learned about creating the EC2 instance RDS database VPC from the AWS console manually. Right? Now to automate the infrastructure resource creation, we have a tool Terraform, which is similar to CloudFormation. Okay, which is similar to CloudFormation, with which we can automate the creation of EC2 instances, RDS database, or any AWS resource. Then we have Ansible. Okay, Ansible is a configuration management. Okay, so suppose let's say you have group of servers. Okay, for example, you have learned in AWS about high availability, right? For high availability for the EC2 instance, we deploy multiple servers. Right? For high availability, we deploy multiple servers. Now let's say on those multiple servers, now let's say you want to perform any configuration changes, server related configuration changes, or you want to deploy the application changes across multiple servers. Okay, so to automate that, we use Ansible. But Ansible can also be used for infrastructure automation also. But that is not it. It was initially designed for. Okay, so I would say primarily in the industry, Ansible is only used for configuration management, which is suppose if you want to deploy application code or if you want to perform any changes in the server configuration. Okay, suppose you are running Apache server in the instance, or if you want to perform any sort of automation, operating system level automation, in that case, basically we use Ansible. Then for the version control, we have Git. Okay, Git is basically a version control tool. Okay, with which we can perform code versioning. Okay, with which we can perform code versioning. Okay, so here code repository will be basically a Git repo. Okay. Then in your staging environment, production environment, depending on your application architecture, you can have your application running in EC2 instance, or you can have your application running on containers. Okay. So for containers, we have Docker. It is a containerization tool. Then we have Kubernetes. Okay, Kubernetes is basically a container orchestration tool or container management tool. Okay, so in DevOps, you may have heard about CI/CD. Okay, curiosity is good that you want to know what is Ansible, what is Terraform, what is Kubernetes, what is container. But when time will come, when we will be learning this tool, at that time I will explain you in detail about that tool. Okay, so right now don't ask what is container, what is Kubernetes, what is Ansible. As time comes, as we move forward, we will discuss, we'll learn about these tools in depth. We will talk about theory also, we will do the hands-on as well. Okay, so in DevOps, you may have heard about this term CI/CD. Okay, so CI/CD basically have two meanings. One is continuous integration, continuous delivery, and continuous integration, continuous deployment. First, let us understand CI part, this part, continuous integration. Okay, so in the software development life cycle, we have this part where we are building and testing the code. So this part is called the CI part, continuous integration. Okay, this part is called the continuous integration part, where the developers are pushing code to the code repository, the code is built and code is tested. So this part of the software development lifecycle is called the continuous integration part, continuous integration phase. And the next phase, this phase is called the continuous delivery or continuous deployment phase, depending on what we are implementing. So suppose if we are implementing continuous deployment, first let us talk about continuous deployment. If we are implementing a continuous deployment, so in that case, there is end-to-end automation. End-to-end automation in the sense, once the developer pushes the code to the code repository, Jenkins will pull it, build the code, test it, then push to the staging environment, and then push to the production environment. So in continuous deployment, we have end-to-end automation. Or let me put it this way, we have automation till the prod environment. Okay, and if we are implementing continuous integration, continuous deployment, so once the code is pushed by the developer to the code repository, it will be automatically deployed to the staging environment, then to the production environment. Everything will be automated in case of continuous integration, continuous deployment. Now we have one more thing, which is continuous delivery. In continuous delivery, we have automation till the staging environment. Okay, in continuous delivery, we have automation till the staging environment. Okay, then to deploy the changes to the production environment, there is manual approval required. Okay, there is a manual approval required, and after that, the code is pushed to the production environment. So in continuous delivery, we have automation till the staging environment, In the production environment, the code is deployed after a manual approval. But in continuous deployment, the code is deployed automatically to the production environment. There is no manual approval required. So overall, in continuous deployment, we have end-to-end automation. Okay, we have end-to-end automation in continuous deployment. In continuous delivery also we have automation, but we have automation till the staging environment. After the staging environment, there is a manual approval required. And after that manual approval, the code is then published to the production environment. Okay, the code will be then pushed to the production environment. So many companies prefer implementing continuous integration, continuous delivery. Okay, or also it depends upon the application also, what kind of application it is. What 4 steps, Rajiv, we want to be repeated? Okay, manual approval basically means that once the code is deployed to the staging environment, there will be, we need to manually trigger the deployment to the production environment. Okay, there will be no automation involved in the deployment of the code to the production environment. We have to manually trigger deployment to the prod environment. Overall, this is called CI/CD pipeline. Okay. Overall, this is called CI/CD pipeline. Continuous integration, continuous deployment pipeline, or continuous integration, continuous delivery pipeline, depending on how you are implementing it. So most of the companies prefer continuous integration, continuous delivery, where the automation is till the staging environment, and then they manually approve or manually trigger the application deployment to the production environment. Okay. For example, if we take an example of continuous integration, continuous delivery, suppose your organization or the company is going to have a sale. Suppose they are building an e-commerce application, or sorry, they have an e-commerce application, and that e-commerce application is going to have a sale, let's say on Sunday. Okay, let's say there will be a sale on Sunday for that particular application. So they don't want their application changes to be deployed until Sunday. For example, if we take an example of Amazon or Flipkart, so when they have a sale, so the sale starts on that particular day at 12 a.m. Right? So let's say let's say your company is developing the application for the sale, right? But they don't want to release the application in the production environment until it is the sale day. Until it is the sale day, they don't want to release the application to the production environment. So in that case, we can implement continuous integration, continuous delivery, where we have automation till the staging environment. And once, let's say on the sale day, let's say on Sunday, you can trigger the deployment to the production environment. Okay, so this is one use case. Apart from that, there is one more use case of continuous integration, continuous delivery, which is many companies prefer performing manual testing in the staging environment before releasing it to the production environment. Okay, many companies prefer performing manual testing in the staging environment before releasing it to the production environment. Okay, so the companies which prefer performing manual testing in the staging environment, so they usually implement continuous integration, continuous delivery. And I would say in most of the organization, companies prefer using continuous integration, continuous delivery. Okay. And in continuous deployment, we have end-to-end automation, which means once the developer has pushed the code, if it is once it is built and if it is tested successfully, then it will be pushed to the staging and then it will be pushed to the production environment. So in continuous deployment, we have end-to-end automation. And we, as a DevOps engineer, we build this CI/CD pipeline. That is our job. Okay, this is our job. That code writing job is part of the developer. The developer will write the code. That is not our job. Automation of this infrastructure, software development life.
Let us have a quick quiz, guys. What is the main goal of DevOps and how does it contribute to the software development lifecycle? Option A, to eliminate the need for software testing. Option B, to automate all aspects of software development. Option C, to improve collaboration and communication between development and operation teams. Or option D, to increase the time and effort required for software deployment. Comment down your answer below in the comment section. Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Lifecycle, that is our job. And to automate this software development lifecycle, we use automation tools. In each of the phase, we are using a tool, right? For building the code, we are using one tool, Jenkins. For testing the code, we are using one testing tool. For managing the infrastructure, we are using one tool. For deploying application changes, we are using one tool, right? So our job is to deploy the application. Our job is to deploy the, our job is to build a CI/CD pipeline. And how we will build it? We will build it with the automation tools. Okay. So yeah, so we have a developer and developer is working on building a web application. So in his laptop, he has created one folder by the name project. And inside this folder, he has created some application files. Okay. Let's say index.html, style.css, script.css, script.js. Okay. So developer has created some application files, okay, in the project directory for the web application. Now, so initially there was one developer who was working in the project. Now let's say the project is expanding. Okay, now the company plans to hire more developers. Now let's say there is another developer. Dev2. Okay. Now developer 2 wants to work on, let's say, contact.html. Okay, let's say he wants to make some changes in the code base of the web application. He wants to make some changes in index.html. And he wants to make some changes in contact.html. Okay, I mean, he wants to add one page in the application, contact.html. Right. So what developer 1 will do? Developer 1 will share the code base, this code, with developer 2. Okay, the code which developer 1 had in his machine, the developer 1 will share that code with developer 2. Then developer 2 will make the changes in, let's say, an index.html file. and he will add one page, contact.html. Okay, so let's say developer 2 was asked to work on contact us page. Okay, so the developer 2 created contact us page, and he also made some changes were required in index.html. So he also made those changes. Okay, developer 1 is asked to create the, or I would say work on the base project. Okay, or base application files. Okay, like the index.html, style.css, script.js. So the base application is handed over to developer 1, and developer 2 is asked to work on, or is asked to add a new feature in the application, which is contact us, so that when the users will be accessing the web application, they should be able to send an email, okay, with the contact us page. So developer 2 has made some changes in index1.html and has also added code for contact.html. Okay. Now let's say there is one more developer, developer 3. And developer 3 is asked to work on services page. Okay, developer 3 is asked to work on the services page. Now developer 2 will share the code base with developer 3, or let's say developer 2 and developer 3 are working together in the sense, when developer 1 created the code base, then developer 1 handed over the code base to developer 2 and also handed over the code base to developer 3. So in that case, the developer developer 3 will have this as the code base. Okay, and then he will add his own code changes like services.html. Okay, now let's say we want to, so end of the day, overall this is only one application, right? End of the day, this is only one application, right? But there are, I would say, let's say whatever changes are made by developer 2 are not available in the code base of developer 3. Okay, whatever changes were in developers 2 code base are not available in developer 3 code base, and whatever changes are made in developer 2 and developer 3 code base are not available in developer 1 code base. Right, and yeah, so this is one challenge, right? Because the code base are not in sync, and even if they want to make the code base in sync, there could be conflicts. Conflict in the sense, suppose developer 2 has made some changes in index.html, and this developer also has made some changes in some other files, right? So that may cause code conflicts. Right, that may cause code conflicts. Right, so before version control system, the code management by the developers used to be very complicated, was a very hectic task. Right, it was not easy to manage the code. Plus there was no tracking in the sense, like who made the changes. Okay, it was difficult to track these things. One is who made the changes, what changes were made, and when changes were made. Okay, so before version control system, developers used to face this challenge. Okay, right now we are taking a very small example of 3 developers, usually in a project, depending on how big the project is. there would be multiple developers working on it, 5, 10, 20 developers working on it. So without version control system, it was very difficult to track who made the changes, what changes were made, and when those changes were made. Right? And there used to be a lot of code conflicts. Okay, there used to be a lot of code conflicts. So suppose this developer has made some changes in index.html, and this developer also had made some changes in index.html. So then there used to be a code conflict. Right? And there used to be code conflict. So before version control system, there used to be a lot of challenges, and there were no way to track the changes. Okay, there was no way to track what changes were made, who made the changes, and when the changes were made. Right? So these problems were solved through version control system. Okay, these problems were solved through version control system. With version control system, we will be able to know who made the changes in the code, what changes were made, and when changes were made. Okay, and one more problem before version control system we had was of collaboration. Collaboration in the sense, if multiple developers want to work together on a single code base, so that used to be very challenging. Okay, that used to be very challenging. So all these problems were solved through version control system. With version control system, we will be able to track changes in the code base, right? We will be able to see who made the changes, when the changes were made, and what changes were made. Okay, for example, let's say developer one wrote some code in index.html. For example, let's say developer one wrote this content. Now developer two, when the code was handed to developer two, and developer two was asked to add a new feature in the code in contact us, plus developer two was also asked to make some changes in index.html. So when the code was handed over from developer one to developer two, so let's say developer two made some changes. Okay. Let's say developer two was asked to change the color of the font from red to blue. Okay. Developer two was asked to add this contact us page, and was also asked to make some changes in the index.html page. He was asked to change the application code, the font color. Okay. Now let's say this code was handed over to developer 3 or some other developer. Right. Now this developer wants to know who has added this change, who has made this code changes, and when was this code change made. Okay, when was the code change made, who made the code change, and what code changes are made by some other developer, let's say developer 2. Right. So this was, I would say, before version control system, this was not tracked. This was very difficult to track. Okay. So without version control system, collaboration used to be a very hectic task. Okay, collaboration between multiple developers used to be a very hectic task, and the biggest problems which developers used to face was code conflict. Okay, the biggest problem that developers used to face was code conflict. So all these problems were solved through version control system. So with the version control system, we will be able to track who made the changes, what changes were made, and when changes were made. And version control also makes collaboration easy. Collaboration easy in the sense multiple developers can collaborate in a single code base, in a single project. Okay, and with the help of tracking, they will be able to easily collaborate in the code. They will be able to know who has made what changes, right? And what was the purpose of that change, right? So collaboration will also, with version control system, the problem of collaboration is also solved. Okay, so Rohit is asking, will we learn any language? So we are not going to learn any programming language. Okay. See why we are learning version control system as a DevOps engineer? Because in DevOps, as a DevOps engineer also we have to do coding. Okay, like as a DevOps engineer, we should know Python or shell scripting. Plus, apart from these programming languages or scripting languages, in DevOps, we write playbooks, Ansible playbooks. We write Terraform templates. We write Kubernetes manifest files. Okay, so all these scripts we keep in a code base, in a code repository, right? In a version control system, basically. Okay, so that is why it is necessary for us to know about version control system, and that's the reason we are learning version control system. So version control system is not only for developers. Okay, here we are talking in terms of example. We are taking an example of a web application because right now we are not familiar with the scripting. Okay, so that's why I'm just taking an example of a web application. But as a DevOps engineer, we will also be working with version control system. For example, Git. Okay, when we will be writing the playbooks, the templates, the Kubernetes manifest file, everything we will be keeping it in the code base. So Python we are not going to learn in DevOps. Okay, Python we are not going to learn in DevOps. I'm not sure which course you are enrolled in with. So if it is in your course, then definitely Intellipaat will conduct your Python training. Okay, but in our DevOps course, we don't have shell scripting, we don't have Python. I think I made this very clear in the last session itself what we are going to learn. Right, so Python we are not going to learn, nor we are going to learn shell script. Okay, thank you for your understanding. Okay, so with version control system, we will be able to solve these three problems. Okay, so overall with version control system, we will be able to track changes in the code. Okay, with version control system, we will be able to track changes in the code. And primarily, we will be able to track these three things. One is who made the changes, what changes were made, and when the changes were made. Okay, so with version control system, primarily we'll be able to track these three things. Now there are two types of version control systems. One is centralized and one is distributed version control system. Okay, one is centralized version control system and one is distributed version control system. In centralized version control system, we have a remote repository. Okay, we have a remote repository Now, when I am saying repository, it means a remote server where the code will be stored. Okay, a repository means a remote server where the code will be stored, a remote repository. Okay, so here remote repository means a remote server where the code will be stored. So in distributed version control system, also we have a remote repository. Okay. Then we have developers. Okay. In centralized version control system, if the developers have to make any changes in the code, they need a connection with the remote repository. Okay, if the developers have to make any changes in the code, they need a consistent connection with the remote repository. Which means, suppose initially, let's say this developer one had these files. Okay, now let's say developer one is making some changes in this file. Okay, let's say once he's done making changes in this code in this file, so the in order to push the changes to the remote repository, developer one requires a connection with the remote repository. Now this remote repository can be on the internet, or it could be on a private network. Okay, so overall, whatever changes which the developers are going to make in the code base, they will require a consistent connection with the remote repository. Okay, suppose this developer is making some changes in the code. So this developer, in order to reflect the changes in the remote repository, they need a consistent connection. And what is this remote repository for? This remote repository is for collaboration. It's for collaboration, or I would say it is a single code base. Okay, it is a single code base. Earlier, before version control system, each developer has to had the code base in their local machine, right? Each developers had the code base in their local machine, in their laptop. But in version control system, we have a remote repository where all the code is present. Where the code base is maintained, or where the I would say final code is present. Yeah, we can also call it a centralized repository. Okay, where multiple developers can collaborate. Okay, so in centralized version control system, in order to make any changes in the code base, the developer needs a consistent connection with the remote repository. Whereas in distributed version control system, each developer has a local repository. Okay, there is a remote repository, and in the developer's local machine, means in their laptop or desktop, they have a local repo. Yes, we can call remote repository as a centralized repo also. But the actual term which we use is a remote repository. Okay, so in distributed version control system also we have a remote repository, and we have in the developers will be having a local repository. Now, whatever changes the developer are going to make in the code, or let's say in the or whatever operation they are performing related to the code, so for that they do not require internet connection, or they do not require connection with the remote repository. Just when they want to push any changes, or when they want to pull any changes from the remote repository, only then they require internet access. Okay, when they want to push or pull the code, only then they require internet access or connection with the remote repository. But here in central repository, for every operation, developers need connection with the remote repo. Okay, in this case, in centralized version control system, for every operation, apart from push and pull, okay, I mean for push and pull also they require consistent access with the remote repository. Apart from other action, let's say if they were making any code changes, or if they are creating a version in the code, right, or if they are creating a branch, okay, in the version control system, so for that they require consistent access or consistent connection with the remote repository. Whereas in this case, in distributed version control system, the developer has its own local repository. Okay, the developer has its own local repository, and the developer only requires connection with the remote repository in case for pull or push operation. Sorry, push and pull operation. When the developer wants to push the changes, then only the developer requires connection with the remote repository, and when the developer wants to pull the changes, then only the developer requires connection with the remote repository. But here, for every operation, the developer requires connection with the remote repository. Okay, this is one difference. Okay, apart from that, versioning. Okay, apart from that, versioning, code versioning. So suppose, let's say that the developers have created a version for the application, let's say V1, V2, let's say multiple versions for the application, version 1, version 2, version 3, version 4, version 5. Now, when a developer is going to download the code from the centralized repository, from the remote repository, in case of centralized version control system. Okay, and let's say version 5 is the latest code or latest version. Okay, let's say this is the current version of the application. So when the developers are going to clone the code, okay, clone the code or download the code from the remote repository, suppose there is a new developer and this developer wants to work on the code base. So when the developer is going to download the code from the remote repository, so the latest version, the current version of the code will be downloaded in his machine, which means version 5 of the code will be downloaded in this developer's machine. Whereas in case of distributed version control system, suppose here also, let's say we have 5 versions. Okay, so let's say here also, let's say we have 5 versions. So when a new developer is going to clone the code, or when that new developer is going to download the code, all the versions of the code will be downloaded in the developer's machine. Okay, all the versions of the code will be downloaded in the developer's machine. Because here in distributed version control system, the developer will have a local repository also. And local repository is completely, or I would say exact replica of the remote repository. Okay, local repository is exact replica of the remote repository. So let's say in the remote repository there are 5 versions. So when the developer is going to clone the code, download the code, so the developer will get all the 5 versions. But in case of centralized version control system, the developer will get the latest version of the code. Okay, so when the developer will be downloading code, he will get the latest version. Other older versions will not be downloaded. Okay, older versions of the code will not be downloaded. Okay. Now, when to use what? Because both are version control system and both are solving these problems. Okay, both are solving this problem and one more problem both these solutions are solving, which is of collaboration. And how collaboration is happening here? Here we have a remote repository. Okay, we have a remote repository, a single code base. Okay, so let's say a new developer wants to work in the code. So the new developer can download the code, and when the new developer will be downloading the code, so whatever new changes are there in the code base, that will be downloaded in the developer's machine. Whatever latest changes are there in the code base, that will be downloaded in the developer's machine. Earlier, before version control system, the developer has to check with other developers for the latest code. Developer 3 will check with developer 1 whether he has the latest code, or with developer 2 whether he has the latest code, right? Because before version control system, we didn't had a remote repository, right? The code base used to be only in the developer's machine. But with version control system, we have a centralized repository, which is also called a which is also called the remote repository, where the code base will be present. And all the developers will be making changes in the code base, in the remote repository. Okay, once they are done making change in distributed version control system, once they are done making the changes in their local machine, they will push the changes to the remote repository. So remote repository, whatever code we will be having in the remote repository, that will be the final application code. Okay, that will be the final application code. Okay, let's take some question in the chat. No, integration is a different thing, Ramesh. Collaboration means multiple developers are working together on the same code base. Okay, same code base. One developer is working on some X feature of the code. Some other developer is working on some other feature of the code. So that is collaboration. Exactly. Raga Sandhya is saying that if developer 1 is using index.html, then others cannot make changes to same index.html till developer 1 completes the change. So before version control system, this used to be the scenario. Okay, because suppose if multiple developers are working on the same code, then there will be code conflicts. There will be code conflicts. And without version control system, it will be very difficult to understand who made the changes and why those changes were made. But with version control system, with version control system, multiple developers can work on the same code base, on the same file. Let's say index.html. Multiple developers can work on the same code base. Okay, but yes, there will be code conflicts. But now with version control system, it is easy to track who has made the changes, when the changes were made, and it is easy to fix the code conflicts as compared to what challenges we used to have before version control system. Yeah, Rohit, I will check with the support team. Actually, the Google Drive I shared, I didn't had access to upload files, so I'll check that with Intellipaat support team, and I will upload all the files there. Yes, local repository means code base complete set of files. Or local repository, you can also say a replica of the remote repository. In distributed version control system, when the developer clones the code, when the developer will be cloning the code, cloning in the sense when the developer will be downloading the code. Okay, when the developer is going to download the code from the remote repository, he will get the exact replica, exact state, whatever state is there in the remote repository, the same state the developer will get in his local machine. So let's say in the remote repository, there are 5 versions of the code available. So in the local repository also, there will be 5 versions, exact replica. Whereas in case of centralized repository, when the developer will be downloading the code, the developer will only get the latest version. Okay, Nathan Kumar is asking, in centralized version control system, in remote repository, parallelly both dev1 and dev2 are performing changes. For syncing changes, any order will be maintained or what mechanism will be used? Okay, so let's say developer 1 is making changes in this file and developer 2 is also making changes in this file, index.html. Okay, now let's say developer 1 has pushed his changes to the remote repository. He has made the code changes in index.html and he has pushed the code changes to the remote repository. Now developer 2 also has made the changes in the code in index.html file. But in order to push the changes, when the developer will try to push the changes to the remote repository, developer 2 will get an error. The error will be that your code base is behind or your code base is outdated with the remote repository. Okay, the developer will not be able to push his changes. He will get an error that your current code base is not up to date. So first, this developer has to sync the code. Okay, first this developer has to sync the code from the remote repository with his local code base. Okay, which means pulling the code. So first, this developer has to pull the code. Now, when the developer will be pulling the code, so whatever changes were done by developer 1 in index.html file, those changes will be added in his existing code base. Those changes will be added and his existing changes, whatever changes he made, that will be also there in this file. And after that, this developer can then push the changes to the remote repository. Yes, so Ramesh is asking if we want to download an older version, so can we download? So yes, we can download older version also in case of version control system. But by default, it only downloads the latest version of the current version of the code. In Centralized, 2 developer will be able to work in the same code base at the same time. So yes, as we discussed here, multiple developers will be able to work on the same code base. Okay, so we have 2 solutions available. One is centralized version control system and we have distributed version control system. Now, when to use what? When should we use centralized version control system and when should we use distributed version control system? So we can use distributed version control system in case if the code base is small. If the code base is small. Okay, suppose the code files are, let's say, in few MBs. Okay, few MBs in the sense 10, 20, 30, 40 MBs. In that case, we can go with distributed version control system. Okay, even the code size, I mean, if we talk about any application, usually the code base size is not more than few MBs, which means 5 or 10 MBs max to max. Okay, so if we have a code base which is in MBs, in that case we should use distributed version control system. But in case if our code base is large in the sense, if you have files which are big in size, in GBs, okay, suppose in your code base you have files in GBs, like you have binary files. Suppose you are storing videos or images or large documents which are in GBs or which are large in size, like 200, 300 MBs. So in that case, we should use centralized version control system. Why? Because in centralized version control system, at a time, only one version of the code is downloaded. Okay. In centralized version control system, at a time, only the latest version of code is downloaded. But here in this case, all the versions are downloaded. So let's say version 1 of the application, the size of the version 1 application, let's say was 1 GB. Then version 2 was 1.5 GB. Then version 3, let's say was 2 GB. Then version 4, let's say again 2.5 GB. Then version 5, 3 GB. Okay, let's say there is a code base, and the code base for the version 1 of the code, it was 1 GB. Version 2, this is the size. Version 3, this is the size. Version 4, this is the size. Version 5, this is the size. Now, let's say this code base, if we are storing it in centralized version control system. Now, when the developer is going to download the code, so the developer will get the latest version, which means 3 GB of code will be downloaded in this developer's machine. Okay, the size of the file will be just 3 GB. But in distributed version control system, if the code base is in GBs, and as we just discussed that in distributed version control system, all the versions of the code are downloaded in the developer's machine. Which means in this case, when the developer will download the code, so the size of the code will be combination of all these sizes. Okay, which will be somewhere around 10 GB. Okay, in this case, when the developer is going to download the code, the developer code base will be of around 10 GB. The size of the code will be, of the whole local repository will be 10 GB. But in this case, it will be only 3 GB. Why? Because in this case, the latest version will be downloaded. But in case of distributed version control system, all the versions are downloaded. So in total, the size will be big. Okay, in total, the size will be very big. Okay, right now we are taking a very small example of 5 versions. Suppose there are 100 versions, 100, 200 commits, 100, 200 versions. Right? So when the developer is going to download the code from distributed version control system, so it will take a lot of time for the developer to download the code. Plus, the developer will also require additional space. In his laptop or desktop, he should have additional space depending on the code base. So suppose the code base is of 100 GB in addition to all the versions. So in that case, the developer will require at least 100 GB free disk space. But with centralized version control system, when the developer will be downloading the code, the developer will only get the latest version. All the older versions will not be downloaded in the developer's machine. But if the developer wants the older version, the developer can also download the older version as well. Okay, so we should use distributed version control system if the code base is small. If it is in few MBs, in that case, we should go with distributed version control system. And usually we have the code base very small for applications. Okay, rarely I would say it will go in GBs. Okay, even it will not cross 50 or 100 MB if we are talking about code, just in general application code. But if we talk about, suppose if it is, let's say in the code base, we are storing some kind of binary files, okay, which are required by the application, or some project dependencies which are in GBs, then in that case, the size of the code will increase, right? The overall size of the code base will increase. If the code base size is big, if it is in GBs, in that case, we should prefer using centralized version control system. Okay, in that case, we should prefer using centralized version control system. Apart from that, in centralized version control system, for every operation the developer make, let's say cloning the code, making any code changes, or creating any, or making any, performing any operation related to version control, if the developer is performing any operation, so the developer needs consistent access to the remote repository. Okay, so the developer in this case require consistent access to the remote repository. But in case of distributed version control system, as the developers have local repositories, so the developer doesn't require consistent access to the distributed version control system. In this case, first they can make changes in their local machine. Once they are done making changes in the local machine, they can push the changes to the remote repository. Okay, syncing the code means pulling the code. Okay, as we will move forward, when we'll be talking about operations, I mean the operations which we have in version control system. So two basic operations we have in a version control system. One is push and one is pull. Push is used to add new changes in the code. Suppose the developer has made changes in his local machine. Now he wants to, I would say, add those changes to the remote repository. So the developer needs to push those changes. Okay, the developer needs to push those changes. And let's say when the developer wants to sync the repository, sync his local machine, local code base, in that case, the developer needs to perform a pull operation. So when the developer is going to perform pull operation, so whatever changes which are available in the remote repository, those changes will be added in his local code base. Okay, so we will be using distributed version control system if we have a small code base, and we will be using centralized version control system if we have a large code base. Okay, if we have a large code base. Now to implement centralized version control system, we have some tools available in the industry. So the most popular tool available in the industry to implement centralized version control system we have is Apache SVN. Okay, it is also called Apache Subversion. Okay, this is one of the most popular tool used in the industry to perform centralized version control system. If the company is planning to use centralized version control system, so this is one of the tools with which we can set up a centralized version control system. For distributed version control system, we have Git. Okay, we have Git. So if you want to use distributed version control system where a local repository is also created in the developer's machine. So in that case, we use Git as the tool to implement distributed version control system. So pull is to get is used to sync or to get latest code changes in the remote repo. Okay, clone right now we are not talking about, so don't use that term clone for now. Clone, when we will be learning Git, at that time we will talk about clone. So pull is used to sync latest code changes from the remote repository. Okay, when we will be doing the hands-on, you will get a better picture what is pull, what is clone, and what operations we perform. Right now we are talking theoretically, right? When we will be performing, when we will be setting up the remote repository, local repository, and doing push-pull, you will get a better picture. Amar, how much font size you need? I think this font size is, if I will increase it, then I think it will, yeah, then it will be, I hope the font size is okay for everyone. This one. Is everyone okay with the font size? Okay. So Amar, if I will increase it to 120 or 110, then it will be little blur. Okay, it will be little blur. So Ketan, when we will be doing the hands-on, we'll talk about that, how we will identify, and we'll talk about those things. Okay, so I hope till here we are good. We know what is version control system, what are the types of version control system, and when to use what, right? So if we have a small code base where we have the code base in few MBs, in that case, we will use distributed version control system. And if we have a code base which is larger in size, in that case, we will use centralized version control system. Plus, in centralized version control system, we need consistent network access to the remote repository. Whereas in distributed version control system, the developer can work independently first in their local machine, and then they can push their changes to the remote repository. Okay, the developer can choose which version of the code he wants to download. By default, it will be the current version. But while downloading the code from the remote repository, the developer can choose, let's say he wants to, let's say, download the version 2 of the application. So he can choose the version at the time of downloading the code. But by default, it will only download the latest version. If we explicitly specify that, let's say we want to download version 2 or version 3, so we can download that particular version also from centralized version control system. Okay. So as we discussed about distributed version control system, so in distributed control system, we have a remote repository. And a local repository. Okay, local repository will be in the developer's local machine, whereas the remote repository will be hosted on a on the internet or on a private network. Right. So in this course for remote repository, we are going to use GitHub. Okay. What is GitHub? In GitHub, basically, we will get a remote code repository. Okay. Where we can keep our code base. Okay. Apart from GitHub, we have a lot of solutions available on the, I would say, on the internet. We have multiple solutions available for setting up a remote repository. Like we have GitHub, we have GitLab, we have Bitbucket. Okay, these are some of the popular solutions which are available to set up a remote repository. So in our course, we are going to use GitHub as our remote repository. Okay. And in our local machine, we will be installing Git to set up a local repository. Okay. In our local machine, we will be installing Git to set up a local repository. Yes, so Ganesh, there are multiple solutions available. I was just talking about I would say, the tool which is used in the industry, okay, for centralized version control system, which is Apache Subversion. Apart from that, there are a lot of other tools also available, out of which Apache Subversion is the mostly used tool in the industry. Apart from Apache Subversion, we have Perseforce. We have Microsoft also have their own solution, which is Microsoft Team Server. Microsoft Team Foundation Server. Okay. So these are all the tools or solutions with which we can set up a centralized version control system. For distributed, we have Git, we have Mercury, not Mercury, Mercial. Then we have BitKeeper. These are all tools available to implement distributed version control system. Okay. And based on my experience, I have not seen any company using these tools, nor these tools. Okay. The tools which are used in the industry are Apache Subversion for centralized version control system and Git for distributed version control system. Okay. And that is the reason we are learning Git. In our course, we have Git because it is one of the tool which is used by organizations for the code management. Yeah, remote repository will also be available in the private network. Okay, so this remote repository can be on the internet, or it can be in a private network. When I am saying private network, it means corporate network. Corporate network in the sense, let's say when you will be joining an organization, so the company basically has their own internal network, which is over a VPN, right? Which is over a VPN. So that is what I mean by private network. So we can also set up remote repository in a, I would say, private network or in a server. In general, in a server, we can also set up a remote repository. On the internet, we have these solutions available. Okay, actually there are two concepts if you want to know, but this is not part of our course. One is hosted repo and one is self-managed. Hosted, for example of hosted is GitHub, GitLab, Bitbucket. Okay, these are all types of hosted repository, which means which are managed by some third party. Okay, which are managed by third party. As you guys are familiar with AWS, so I'm just giving you one example. RDS. In case of AWS RDS, we don't have to manage the server, right? The server is managed by the cloud provider. Similarly, here also in hosted repository, we don't have to manage any server. Okay, the hosted repository provider will be providing us space to keep our code files, our code base. Then we have one more solution, which is self-managed. In self-managed, you have to set up your own server, and in that server, you need to install the software. Like Git, you need to install the Git daemon. Then we have Atlassian. Actually, one second. Yeah. Okay. We have Atlassian. Atlassian is basically a company which provides Bitbucket. Okay, so we can set up our own remote repository also, like on a EC2 instance or in a server in our network, in the company network, where we can install Git daemon, or we can use Atlassian products to set up the remote repository. Yeah, so Linux Torvald has developed Linux kernel. Linux kernel was developed by Linux Torvalds. Okay, so this guy Linux Torvald developed Linux kernel, and later he was finding some challenges in collaboration in the Linux kernel. Okay, let me tell you this case. So there was, Linux Torvald developed Linux kernel. Okay, and Linux kernel is open source. Open source means anyone can collaborate in it. Okay, the code is available and anyone can make changes in it. Anyone can contribute it. So when Linux Torvald developed Linux kernel, so he was facing this challenge of collaboration. Okay, so he developed Git. And with Git, he basically made the Linux kernel. He made it open. Open for the developers to collaborate. So this is how basically Linux Torvald developed Git. He basically developed it for his own project, Linux kernel. Okay, and later he also made it open source. And Atlassian is basically a company. Those who are not familiar with Atlassian, Atlassian is a company, and they provide lot of products. Okay, they provide Jira. Jira is a very popular tool which is used for project management. Confluence is used for documentation. Bitbucket. And for CI/CD also they have a tool, Bamboo. Git bash is the client, Ramesh. Git bash is the client. It is a client tool through which we can interact with the remote repository. Sorry, through which we can interact with the local repository as well as with the remote repository. Okay, now for the hands-on, we will be setting up one EC2 instance. Okay, so I have already launched one EC2 instance. So you have to log into your AWS account. And those who are not aware, I'm repeating it again. All the labs, part of this course, we will be doing it on AWS. Okay, so all the tool installation, all the hands-on part, we will be doing in a EC2 instance. So we will be launching one instance. Yes, it will be under the free tier plan. For most of that, for most of our hands-on, we will be under T2.micro. And for few of our labs, like when we will be learning Kubernetes, ELK stack, at that time we will require T2.medium. Apart from that, for other tools, we will use T2.micro as the instance type. Okay. So here, operating system, we will go choose Ubuntu. Instance type, we will go with T2.micro. Then we'll create one key pair and then launch instance. Yes, we will have break. Don't worry about the breaks. At 9:30, we will have the break. Okay. Okay, so we will be launching one EC2 instance with Ubuntu as the operating system, T2.micro as the instance type, and we'll create one key pair. Then launch instance. So you have to keep the operating system as Ubuntu and instance type as T2.micro. That's all. Okay, so after launching the EC2 instance, we will connect to it. Okay, in my case, my instance doesn't have a public IP. Okay, I'm again launching an instance. In my case, for some reason, my instance didn't got a public IP. So I'm keeping this as the name for the instance, this as the operating system, Ubuntu. Then this as the instance type, T2.micro. Then I have already created one key pair, so I'm using that key. Then in network setting, you don't have to do anything. In my case, actually, my VPC has some different configuration, so I just need to make one change. Apart from that, you don't have to make any changes. Once you are done with the key pair, you just need to click on launch instance. Okay, now we'll connect to the instance. So to install Git, we will run this command sudo apt update -y. So we need to run these commands sudo apt update -y and sudo apt install Git. Can anyone tell what does this command do? Apt update -y. What this command does? So this command doesn't update the operating system nor any packages. So then what this command does? This command will update the package indexes and will create a cache of the packages available in the remote server. Remote server. Or remote package repository, you can say. So this is what the command does. What this command will do, this command will update the package indexes and will create a cache of packages available in the remote package repository. Now, what is a remote package repository? What is package indexes? So when we run this command, apt install and then the package name. What is a package? Can anyone tell what is a package? Everyone has used this term package. What is package? What is a package? Right. So package means software. Most of you, I think, don't know what is a package. So package means a software. So when we run this command apt install and the package name, the software name, right? Let's say Git. I want to install Git. So Git is the package name here. So this package will be downloaded from a remote server. Okay, this package will be downloaded from the remote server. And the information of that particular package which is available in remote server, that we will be getting using this command apt update -y. Without running this command, you will not be able to download this package. It will give you an error that the package is not available. But once you run this command, what it will do, it will connect to a remote repository, and from the remote, and in the remote repository, basically their packages are present. For example, yeah, so this is a package repository. Okay, this is a package repository. So when we run that command apt install and the package name, so that package is downloaded from this repository. Okay, for example, if I search here Git, okay, this I am taking an example of CentOS as the operating system, but this is same for that also. I mean for Ubuntu as well. So yeah, here you can see there is a package available for Git. So when we run apt install and the package name, so that package is downloaded from this repository. Okay, and the information of package, that the package is available in this repository, that information is gathered by the operating system or by the package manager through apt update -y. Okay, so apt update will not update any operating system packages, it will not update the operating system. It will just create a index or cache of the packages which are available in the remote package repository. This is basically called a remote repository, remote package repository. Okay, So once you are done with the setup, you will be redirected to this page. And at the right top, you will be able to see your username. Okay, whatever username you have chosen at the time of creation of the account, you will be able to see that username here. Okay, so it is very simple to set up the GitHub account. Okay, just we need to provide email address, username, and we just need to choose one plan and verify our email address. That's all. So after creating the GitHub account, we will create a repository here. And that repository will be our remote repository. Okay, that repository will be our remote repository. So here we will click on new. Then we have to give a repository name. Let's say my repo. Okay, the repository name can be anything. Okay. Let's say my repo. Then you have to give a description, which is optional. In description, you can tell about your repository, why you are creating this repository for. So let's say learning Git. Okay, but it is optional. If you want to keep it blank, you can keep it blank. Then it is asking what type of repository you want to create. Okay, now it is asking what type of repository you want to create. Whether you want to create a public repository or you want to create a private repository. If we choose it public, then anyone on the internet will be able to access our GitHub repository. The repository right now, which we are creating, if we set it to public, then anyone on the internet will be able to access our GitHub repository, remote repository. If we make it private, then it will be only accessible in our GitHub account, and it will be only accessible to the users who we allow. Okay, it will be only accessible to us, plus it will only be accessible to the users whom we allow to access our repository. Okay, so depending on what kind of project you have, depending on that, basically we will be choosing whether to create a public or private. So when you will be working in an organization, so we will be creating a private repository. Okay, and suppose if your company is building any open source application, right, or you just need to build a open source, or if you are working in an open source project, for your own development, so in that case you can create it as a public repository, right? If it is a private project, if it is a client project, in that case we will be creating it as a private repository. Okay, so for now we will go with public. Later we will see one example of private as well. Then rest settings, we'll keep it as default, and then we'll click on create repository. Okay, our remote repository is now created. Okay, so let's say initially we have created the repository as public, and later let's say I want to make it private. So we can do that. To do that, you can go to settings. In settings here, if you scroll all over down, you will find one option to change repository visibility. From here, basically you can make it to, if it is public, you can convert it to private. If it is private, you can convert it to public. Okay, so we have successfully set up the remote repository. Now let us set up the local repository, right? In distributed version control system, as we discussed, we have two repositories, right? One is the remote repository. So in our case, remote repository is GitHub, and one is the local repository. Local repository sits in the developer's machine, right? So in our case, our local machine will be EC2. So in our EC2 instance, we will create a local repository. And then we will connect this local repository with the remote repository. So we will log into our EC2. in the EC2 instance, we will create one project directory. Okay, so overall, to get started, we need to create one directory, one empty directory. The directory name can be anything. I'm keeping the directory name as project. Then we will go to this directory. Okay, I hope you are familiar with these Linux commands. Okay, ls command is used to see the files and directories which are present in the present working directory. mkdir command is used to create a directory in Linux. cd command is used to switch directory. Okay, so let's say here we created one directory by the name project. Directory is nothing. I mean, in Windows we have folders, right? In Windows we create folders. So in Linux, the same thing, we call it as directory. Okay, this the terminology is different. In Linux, we just call the folder as directory. So with this mkdir command, we create a folder by the name project. Then with this cd command, we are going inside that project folder. And then here we run ls command to see the files and directories which are present in project directory. So right now we don't have any files or folder. So that's why the output is blank. Okay. Okay, so we have created one project directory where we will be keeping our application files. Okay, now here we will create some application files. Let's say index.html, style.css, script.js. Okay, so I've created here 3 files. Touch command in Linux is used to create an empty file. So with this command, we are creating 3 files: index.html, style.css, and script.js. Right, so here we have created these files. Now I want these files to be managed through Git. Okay, I want these files to be managed through Git, or I want this project directory to be managed by Git, or I want to convert this project directory as a local repository. So to do that, we have to go to the project directory where we have the application files. And in that directory, we need to run this command, git init. Okay, and in this directory, in the project directory where we have the application files, we will run git init command. Once we run git init command, now this directory, this project directory, is managed by Git. Now this directory is acting as a local repository. Okay, so in order to create a local repository, we need to run git init command. And where we need to run this git init command, we need to create in the project directory where we are keeping our application files or our code base. Right, the folder where we are keeping our code base, there we need to run this git init command. And once we run this git init command, we have created a local repository. Okay, after that, we will run this command git status. Okay, this command, this command git status will only work in a local repository, in a git initialized repository, which we have initialized in project directory. Right, if you see here git init command, where we ran this command git init, we ran this command in the project directory which we created. Okay, now whatever git commands we are going to learn, those commands we have to execute inside this directory, in the project directory where we have executed git init command. And one more thing, git init command we have to run only once. When we are setting up the local repository for the very first time, at that time we need to run git init command. Okay, after that we don't have to run this git init command. Okay, and one more thing, when we run this git init command in your project directory, you will see one directory created by the name .git. Okay, once you run this git init command in the project directory, you will see one directory created by the name .git. Okay. So this directory is internally used by Git for performing all the operations, like later when, Git related operations like creating branch, creating, I would say, pulling changes. For those operations, basically, Git uses internally this directory .git. And also it stores the commit history. The versioning part also is stored inside this .git directory. And this directory is created when we run the git init command. And git init command we have to run only once. When we are setting the project for the very first time, then only we need to run git init command. And where we have to run git init command? We have to run git init command where we have the application files. Right? So in our case, we created one project directory, and in the project directory, we kept some application files. And in that project directory, we ran git init. And in this project directory where we have executed git init command, in that directory, then we can run other git commands. Let's say git status. What git status will do? It will show you the current status of your local repository. Okay, it will show you the current status of your local repository. Now let us understand Git lifecycle. Okay, how we record changes with Git, and how we, basically how we will be recording changes with Git. Okay, so Git has 3 stages. One is the working stage, or working stage, or we also call it as working directory. Then we have staging area. And then we have commit. Okay, so initially in your project directory, so let's say we created one project directory, and in this project directory we created some files. Now I want Git to manage these files. Okay, or I want Git to track these files. Track in the sense, like whatever changes I'm making in these files, I want Git to track it. So in order to do that, we have to run, or I would say initially these files will be in the working stage or working directory. Okay, where the files currently are untracked. Okay, currently files are untracked. Untracked by whom? Untracked by Git. So initially when we create any files in our project directory, those files will be untracked. Means if we are going to make any changes in those files, Git is not going to track it. Okay, now let's say we want these changes to be tracked. Okay, suppose let's say in my project directory I've added these files and I want to record a change. Okay, I want to create a version of this change. Version of the files I have added in my project. So we have to add these files, or add this, we have to move these files, the code base, to staging area. And to add it to the staging area, we have one command, which is git add. With git add, we can add the files which we want to be tracked through Git. So suppose I want these files to be tracked through Git. So I can run this command, git add index.html, git add style.css, and git add script.js. Okay, so initially in your project directory, in your working directory, the files will be untracked, which means Git will not be tracking any changes which are made in your files, in your code. Now, if you want the changes to be tracked, so you have to first add it to the staging area. Once you add it to the staging area, once you are done making the code changes, then we have to commit it. To commit it, we have to run this command git commit. Okay, and once we commit changes, a track of the changes is created. A track of changes made is created. And what this track of changes will have? It will have who made the changes, when the changes were made, and what changes were made. Okay, so commit is like creating a track of changes which we are making in the code base. So suppose whatever changes you have made in your code base, let's say you have added it to the staging area. Once you have added it to the staging area, once you commit it, then you will be getting this information. You'll be able, you have created a track of the changes you have made. Okay. So right now we are performing these all operations in the local repository. Okay, we are performing all these operations in the local repository. So once we are done making the changes, once we are done making a commit, once we have recorded the change in our local repository, then we can push it to the remote repository. Okay, after that we can push the changes to the remote repository, which is in our case GitHub. In our project, we added 3 files, and these 3 files here you can see we are able to see one message, untracked files. Okay, there is a command git status. With git status, basically we will be able to check the status of our local repository. What is the current state of our local repository? We will be able to see by this command git status. So with git status, we are able to see that currently these files are untracked. Okay, these files are untracked by Git. Now, in order for Git to track these files, we need to add these files to the staging area. Okay, we need to add these files to the staging area. And how to add them to the staging area? To add them to the staging area, we need to run this command git add and the file name. So git add and then the file name. Git add, then the file name. Git add and then the file name. Now, after you run the git add command, if you do git status, you will see that earlier it was untracked. Now it sees changes to be committed. Okay, so once you are done making changes in your code, and once you are done adding it to the staging area, the next step is to record those. If you want, next step is to record those changes or to create a track of those changes. So to create a track of those changes, we need to run git commit command. Git commit. Then we have to give a message. In message, we will be giving a description of what changes we have made. Okay, in message, we will be giving a description of what changes we have made. So let's say adding index.html, script.js, style.css to the project. Okay, commit message, you can add anything which makes sense. Okay, now we have recorded a change in our local repository. Now to check the track of that, to check the record of changes which we have made, so we can run git log command. Now git log is telling us who made the changes, when the changes were made, and two information right now it is telling. I'll also show you what changes, how we can see what changes are made. But right now, if you run git log command, it will show you who made the changes. Currently on the server, we are logged in with this Ubuntu user. Okay, if I run whoami command, with whoami command, basically we can see with which Linux user we are logged into the server. So currently on the server, I am logged in with Ubuntu user. So it is telling that with Ubuntu user, the change was recorded. And when the change was recorded? The change was recorded at this time. Okay, which is actually the server time. Yeah, which is basically the server time. Just a minute ago, we recorded this change, right? And we are able to see description about what changes were made. Okay, which basically the developer will be adding manually, like when we run the git commit command. Okay, so we are able to see who made the changes, when the changes were made, right? And let's say we want to see what changes were made. So if you run git show command, it will show you what changes are introduced. So here you can see it has, here you can see we have added new files, index.html, script.js, and style.css. Currently, we didn't added any content. That's why it's not showing any data which is inside the file. So right now it's just showing that in this commit, or in this, the change which we have recorded in this chain, in this record, in this record, 3 files are added: index.html, script.js, and style.css. And who has done this change? This user has done the change. And when the changes were done? At this time the changes were done. And what changes were done? These changes were done. And additionally, we have a description also, which will be added by the developer. So I'll start from 0. So here initially we created one project directory. Then we went inside this project directory. Then we ran touch command to create 3 files. Okay. Then we ran the git init command. Git init command is to set up a local repository, right? And after setting up the local repository, we ran git status command. Git status command to check what is the current state of our local repository. So we saw that there were 3 files which we created in our project directory. So these files were untracked by Git. Now, in order for Git to track these files, we need to add these files to the staging area. Okay. Initially, the files will be in working area, and when the files are in working area, they will be untracked. The color of these, the output of Git status will be in red. Okay, it will be in red. Okay, then when we now let's say I want these files to be tracked by Git. So for that we have to add the files to the staging area. Okay, and to add the files to the staging area, we need to run git add command. Git add and the file name, whatever files we want to add. After you run these command, then you will see when you will run git status command, you will see the file names in green. You will see the file name in green, which means the files are now in staging area, which means they are ready to be recorded or they are ready to be committed. Okay, in Git terminology, we use this term commit. Committing the change means creating a record. Okay, creating a record or creating a version. Okay, versioning is, I would say, we will talk about that later, like version 1, version 2, how we create, we'll talk about that later. But commit means creating a track of changes which we have made in our project directory, in our project. Okay, and with commit, we will be able to get this information. Okay, so after working area, we ran this command git add, and with that, our files were added to the staging area. Then after that, we ran this git commit command, git commit -m, and then a message. Message could be anything, whatever changes which you are introducing in this particular commit, you can add that particular, add a description related to that. And then, then if you run git log command, with git log command, you will be able to see all the commits which are made in this local repository. So when we ran git log command, so in git log, basically we are able to see one commit which we made. And we are able to see with this commit who made the changes, when the changes were made, and we are able to see the commit description. Okay, then we have one command, git show. Git show command will show you who made the changes, when the changes were made, commit description, plus it will also show you what changes were made, in this particular commit. Okay, and here we are able to see in yellow color commit and then the commit ID. So whenever we make a change in our code repository, or whenever we track a change in our local repository, it will create a commit. Okay, it will create a commit. Okay, so the difference between git log and git show, Ramesh, is with git log command we will be able to get with git log we will be able to get all the commits which are made in the Git repository. So right now in our case we only had one commit. So right now it is showing one commit. But suppose you have a lot of commits in your Git repository. So when you will run git log, you will be able to see all the commits. With git show command, you will be able to see detailed information of your latest commit. So in our case, we had this as the latest commit, right? This was the only one commit we had in our repository, which was the latest commit. So with git show command, we are able to see detailed information of that particular commit. We are able to see who made the changes, at what time the changes were made, and what changes were made. What I want is, I want to push these files which are currently in my local repository to my remote repository. Okay, I want to push these files which are available in my local repository to my remote repository. Right, so this is our remote repository which we created in GitHub. Right, now I want to push these changes which I have made in my local repository to my remote repository. In our project directory, we need to run these commands. One more thing, all the commands which we are learning, like git add command, git status command, git commit command, all these commands you have to run from your project directory. Project directory in the sense, the directory where you have executed git init command. So if you remember, initially we executed git init command in this directory. So the commands which we are executing, like git status, git add, git commit, all those commands will only work inside this directory. If I go outside of this directory, and now if I run git status or any other command, it will give an error, not a Git repository. So all those commands you have to execute from the directory where you have executed git init command. If you will be outside of your project directory, then you will get this error. So right now we are in the project directory, the directory where we ran git init command. So here we will be able to run the git commands. Okay, now we will connect our local repository with the remote repository. So to do that, we need to run this command, git remote add. Then we have to give a repo name. Let's say I want to keep the repo name as my git repo. Okay, the repo name here which we are giving can be anything. Okay, and how you'll get the GitHub URL? In the repository itself, you will find this URL. Okay, you have to click here on HTTPS. By default, it will be selected, and you have to choose this URL. Then to check whether the repository is added, you can run this command git remote -v. So here you can see that repository which we added, my git repo is added, and we are also able to see the URL of our remote repository. Right, so this is the URL where we have our remote repository. Right, here you can see this is our remote repository URL. This is the URL where our remote repository is hosted. Right, so with this command, we are connecting our local repository with the remote repository. Okay, now we are going to push a change. Now we are going to push whatever changes which we have made in our local repository. We are going to push it to our remote repository. So to do that, we have git push command. git push. Then we have to give the repository name, which is this one. Okay, so we need to run this command git push and then the repository name. And this is the repository name which we added here, right? While adding our remote repository URL, here we gave this as the repository name. So in order to push changes to this remote repository, we need to give git push and then the repository name which we have added. Now it is asking us our GitHub credentials. It is asking us our username, and it will ask one password to. It will ask us our GitHub username and a GitHub password. Okay, and then we will be able to push the changes to this repository. So the username will be, to get your username, you can go to your GitHub account. You can click here on right top. Here you will be able to see your username. Okay, so in my case, this is my username. So this username we need to DevOps training. This is my username. After this, it is asking a password. Now this password is not your GitHub password. Okay, here the password which it is looking for is not your GitHub password. Okay, so we need to generate this password from our GitHub account. Okay, we need to generate this password from our GitHub account. So we will go to our GitHub account. Then here we will click on right top. Then we will click on settings. Okay, so you have to go to your GitHub account, click on the right top, then click on settings. Then here at the left side, scroll all over down, you will find developer settings. Okay, you will find developer settings. So we'll click here on developer settings, then personal access tokens, then token classic, then generate new token classic. Then it will ask you your GitHub password. Okay, then you need to give a name to this token. Okay, then you have to set an expiry time for this token. Let's say I want to set it to 30 days. Means after 30 days, the token which will be generated will be expired, which means you'll not be able to use it for pushing changes to your Git repository. Okay, then we have to define what access we want to give to this token. So right now we will give full access. Then make sure to save this token, because this token is only generated once. Okay, this token is only generated once. So just save it in your notepad or because this token is only generated once. You cannot recover this token. You cannot recover it, or nor you can reset it. The only solution you will be left over with is create a new token. Okay, so make sure to save this token. Now the password which it is looking for is basically the token, this token which we have just generated. Now we need to provide that token as the password. And now it has pushed the changes to the remote repository. So when you will be running this command git push and your repository name, you need to provide your GitHub username and GitHub, not GitHub password, that token which you have generated in your GitHub account. And then your changes will be pushed to the remote repository. Now let us go to the remote repository and let us see whether our changes are pushed or not. Here you can see all the changes are committed here. All the changes which we made in our local repository, we are able to see it here. Okay, and here you can see there is one commit. If you click on that commit, you'll be able to see who made the changes, what changes were made, and when those changes were made. Who made the changes? This user made the changes. When the changes were made, 22 minutes ago the changes were made. What changes were made? 3 files were added: index.html, script.js, style.js. All the information we have here. Plus we have a commit message also that will be given by the developer, right? So we are able to see here all the, we are able to track what changes were made in our code base. What changes were made, who made the changes, and when the changes were made, right? So to record a change in Git, what we do, we create a commit. And when we create a commit, it will basically create a record. It will be creating a track of that changes which we have made. And then we will push it again to our remote repository. So let's say in this file index.html, I will add some content. Let's say I'm adding here hello world. Okay, I have modified this file index.html. So to modify the file, you can use Vim. Vim is basically a command line text editor, or you can use Nano also, whatever you are familiar with. You can use that as the text editor to make changes in the file. Okay. Now if we do cat index.html, so we are able to see that the content which I added in the file. Then if we do git status, so we are able to see here that index.html file in our working area currently is modified. Okay, the index.html file currently in the working area is currently modified. Then now let's say I want Git to track these changes. Okay, or I want to create a track of these of the changes which I have made in my application file, in my code base. So we need to run git add and then the file name. Then git commit and then give a message. Okay, let's say code changes in index.html. Then git log. So it's very simple. First, you have to make changes. Whatever changes you want to make in your project directory, you will make those changes. Then you will add those changes by the git add command. Then you will commit those changes. Right? And after we commit it, if we run git log, we will be able to see a track. We are able to see that this user has made changes in the code, and at this time this user has made the changes, and this is the commit message. And suppose let's say I want to see what changes were made. So we can run git show command. So here you can see it is telling us that in index.html file, hello world was added. Okay, this data was added in the index.html file. So we are able to see who made the changes, what changes were made, when the changes were made. Okay, and one more thing, without connecting to the remote repository, we are able to make the changes. This is the beauty of distributed version control system. We do not need to connect always. We do not need a consistent access with the remote repository. Right now, whatever changes we have made are currently only local. Okay, those changes are now, are not currently on the remote repository. In the remote repository right now, we only have one commit. Okay, in the remote repository, if I hit refresh here, we only have one commit. But in my local repository, if I run git log, we have two commits. Okay, we have two commits. Okay, let us create one more commit. So I will just update one file, style.css, my CSS code. Okay, so in this style.css file, I have added some content. Now we will run git add command. Sorry, not git add and the file name. Okay, we will talk about this command later, when to use this command. So we are running git add command, and if we do git status now, so the file is in staging area. Okay, 1 minute. Okay, so I have made changes in the style.css file. Okay, I have added this content. After that, if we will run git status, so those changes are currently in the working area. Now, in order to create a track of the changes which we have made in the code base, we need to do git add and the file name, then git commit. Now if I do git log, so now I have 3 commits. Okay, now I have 3 commits, and if I do git show, it is telling in the latest commit that in the style.css file, this content is added in the code. Okay, so we are able to see who made the changes, when the changes were made, and what changes were made. And in total right now we have right now 3 commits. If we go to our remote repository, so right now here we only have 1 commit, right? In distributed version control system, we can work independently in our local repository. Once we are done making changes in our local repository, then we can push those changes to the remote repository. Right? So let's say now I am done making the changes in my code base. Now I want to push the changes, or I want these changes to be available in my remote repository. So to do that, we will do git push and then the repo name which we have added through that git remote command. Then again, it will ask you your username, and password. Password will be what? Password will be the token. Okay, so now the changes are pushed. Now if we go to our GitHub repository, earlier we had 1 commits. Now we have 3 commits. And whatever changes we made in the code, we will be also able to see those changes. Like in index.html file, I added hello world. In style.css file, I added my CSS code. Right? Plus, I will be also able to see the track. Okay, I will be able to see who made the changes, when the changes were made, and what changes were made. Let's say in the latest commit, I want to see who made the changes. So the changes were made by this user. When the changes were made 2 minutes ago. What changes were made? In style.css file, this code was added, this content was added. Plus we are able to see a commit message, right? So with this commit history, we can see, or let's say someone is working on this code base, or some developer is working. So in each commit, the developer will be able to see what changes were introduced in the code. Right? We'll be able to see what changes were introduced in the code base. Now let's say I want to check the differences between two commits. I want to see what changes were added in this commit and what changes were added in this commit. Or in other words, I want to compare two commits. So for that, we will run git diff command. Git diff, then commit ID of the first commit and the commit ID of the second commit. Git diff, commit ID of the first commit, commit ID of the second commit, or the commit IDs which you want to compare. Okay. So the changes between this commit and this commit is that in this commit, in style.css file, this content is added. The difference between this commit and this commit is that in this commit, in style.css file, this content is added. In this commit, this content was not there. Right? So to check the changes between two commits or to compare two commits, we can use git diff command. Git diff and then the commit ID. Okay, this is the commit ID, and commit ID will be always unique. Deployed one EC2 instance, right? And in that EC2 instance, we created a local repo. Okay, local Git repo. And how we did that? In our EC2 instance, first we created one directory. In that, and then in that directory, we ran this command, git init. Right? So with the help of git init command, we will be able to initialize a local Git repository. Right? So in the last session in our EC2 instance, we first created a directory, and then in that directory, we ran the git init command to set up the local repository. Right? Then in our local repository, we added some application files. Let's say index.html, script.js, and style.css. Right? So we added these files in our local repository. Then after that, we connected our local repository with the remote repository. Okay. After that, we connected our local repository to remote repository. Okay. In order to, I would say, push the changes which we have made in our local repository to the remote repository, what we did, we connected our local repository with the remote repository. And how we did that? We did with the help of git remote command. Right? With the git remote add command, we added the remote repository in our local repository. I mean, we added the path of the remote repository in our local repository. Right? And then with the help of the git push command, we were able to push the changes from our local repository to the remote repository. Right? So this approach you will be following in case if you are setting up the Git project for the very first time. Okay, this approach which we followed in the last session, you will be following in case if you are setting up the Git project for the very first time. Which means when there are no commits on the remote repository, when the project is being created for the very first time, at that time you will follow this approach, which is first you will create a remote Git repository. First is you will create a remote Git repository. Then in your local machine, when I'm saying local machine, it could be your EC2 instance or your laptop. In that machine, you will create a project directory. And in that project directory, you will initialize a local repo. Okay. And then in that local repo, you will add your changes or you will add the files. Then you will connect the local repo with the remote repo. And how you will do that? You will do that with the git remote add command. Then git push. So this is how you are going to work in case if you are setting up the project for the very first time. Okay, suppose there is a remote Git repository and there are no commits. So this way you are going to work, or you are setting up the project for the very first time. Then you are going to follow this approach. In this approach, you have to set up the local repository. You have to set up the local repository on your own. Okay, in this approach, you have to set up the local repository on your own, where you have to run the git init command. You need to run git remote add command, okay, to connect your local repository to the remote repository, right? So this approach we are going to follow in case if we are setting up the project for the very first time, which means when there are no commits on our remote repository, then we are going to follow this approach. Now let's say the git repository is already there. Suppose I've joined the organization, and in that organization they already have a git remote repository, and in that git remote repository already developers are working. Okay, already developers are working. So in that case, I will not set up the git repository with, I will not create a local repository. I will not be creating a local repository with git init. Okay, I will not be creating a local repository with git init. This git init approach I have to follow in case I am setting up the repository from scratch, or when I am creating the project for the very first time. At that time, I have to follow this git init approach. But if the project is already there, if the remote repository is already there and there are some commits on the remote repository. So in that case, what we will be doing, we will be cloning this remote repository. Okay, what we will be doing, we will be cloning the remote repository. Okay, we will be cloning the remote repository. So we don't have to set up the repository from scratch. Okay, now when we will be cloning the repository, like there is a command which we are going to use, like we are going to use this command git clone and then the GitHub repo URL. So when we are going to run this command in our server or in our local machine, a directory will be created by the repo name. Okay, when we will be running this git clone command, a directory will be created in our server by the repo name. And when you will go to this directory, in this directory you will find all the files which are present on the remote repository. So suppose, let's say on the remote repository there are 5 files and let's say 5 commits. So when you will be cloning the repository in your in this directory will now act as your local repository. And in this directory, you will have the exact state of the remote repository. So suppose in your remote repository, you have 5 files and 5 commits. So in your local repository also you will be having 5 files and 5 commits. Plus, now when you are going to make changes in this repository, in your local repository, you will be able to push those changes just by running git push command. Okay, you will be able to push the changes just by running git push command. But when you are setting up the project from scratch, in that case, like with git init, in that case you have to configure the remote repository. In that case, you have to run this command, git remote add, and then only basically you will be able to use this git push command. But when you are cloning the repository, in that case, you don't have to configure the remote repository. Git remote repository will be already configured in your local repository. Okay, the information of the remote repository will be already configured in your remote repository when you are cloning the remote repository. But when you are setting it for the very first time, and when you are using this approach, when you are setting up the local repository with git init command, in that case, you have to tell your local repository where is the remote repository, or where the you have to tell the repository, information of your remote repository. And then only basically you will be able to push the changes to your remote repository. Okay, so in the last session, we followed this approach, right? Where we were setting up the Git project from scratch, right? Where we were setting the Git project from scratch. So in this case, first we created a directory, we ran the git init command, then we added some files, we made some commits in our local repository. Then we connected our local repository with the remote repository with the help of git remote command. And then we push the changes to the remote repository. So this approach you have to follow when you are setting up the project for the very first time. But if you already have a remote Git repository where already developers are working on it, or let's say already this GitHub repository has some commits. Okay, already the Git repository has some commits. So in that case, you will follow this approach, which is you will be cloning the repository. Okay, and when you will clone the repository, the local repository will be automatically created. The local repository will be automatically created, and the local repository will be connected with this remote repository as well. You don't have to manually connect your local repository to the remote repository. Now let us see how to clone a repository. Okay, so git init, Shrikant, we have to run only once. Okay, when we are setting up the remote local repository for the very first time, at that time we have to use the git init command. After that, we don't have to run the git init command. Okay, git init command we have to run only once, and git init thing we have to only do when we are setting up the project for the very first time, where your remote repository is empty. There are no commits in your remote repository. In that case, basically you are going to follow this approach, which is where you have to set up the local repository on your own. But if the remote repository is already there, for example, let's say I'm working in an organization, and in that organization, they already have a remote repository, and there are already few commits in that remote repository. Then in that case, I don't have to set up the local repository from scratch. I don't have to run git init command to set up the remote repository, local repository. So in this case, I can clone the repository. Okay, in this case, I can clone the repository. I don't have to configure it from scratch. Okay, Rohit Kumar is asking what is a commit. So commit means like in our version, in Git, when we are making changes in the code, or when we are adding any new files in the project, so we commit those changes, right? So commit not only means the code, it also means adding files, and it also includes the changes which we make in the code base. Or overall, commit is recording the changes in the Git repository. Okay. Suppose let's say I have added few files in my project, and I want to, I would say, add these changes in my local repository or in my project. So in that case, we use the git commit command. We commit those changes. And with git commit, we will be able to track who made the change.
What git command is used to create a new branch and switch to it in a single command? Option A, git branch. Option B, git checkout. Option C, git commit. Or option D, git merge. Comment down your answer below in the comment section. Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
When the changes were made and what changes were made. So now let's say I'm working in an organization and the remote repository is already in place. So what we will be doing, we will be cloning this repository. Okay, we will be cloning this repository. Now how to clone? You can go to the remote repository and here you will find the clone URL. Okay, you will find the clone URL. Okay, so you need to run this command git clone and then the repo URL. Okay, git clone and the repo URL. And how to get the repo URL? You can go to the remote repository, then click here on code. Then you will find you have to choose HTTPS and this is the clone URL. So you have to copy it, then git clone and the repo URL. Now if we do ls here, so here you can see a directory is created. A directory is created by the name of the repo. Okay, here you can see the remote repository name is my repo. Now when we run the git clone command, a new directory is created by the repo name. This directory is created by, this directory is created when we executed this command. So this directory my repo is created by this command. And the name of the directory is the repository name, right? On the GitHub, we have the repository name by my repo. And here also we have the directory by the same name, my repo. Now if we go to this directory, and if we run git status, so git is already configured. Okay, in this directory, git is already configured. And if I run ls command, so whatever state I have currently of my remote repository, the same state I have now in my local repository or the cloned directory, in the clone directory. Now this clone directory is my local repository. Okay, the directory, after running this command, the directory which is created, now that directory is my local repository. Okay, and whatever state we have of our remote repository, that state now we have in this directory. Suppose in my remote repository, I have 3 files. So here also I have 3 files. In my remote repository, I have 4 commits. So here also, if I run git log command, I have 4 commits. Okay, here also I have total 4 commits. Okay, so this approach, git init approach, which we followed in the last session, is only when we are setting up the project for the very first time. And if the project is already in place, in that case, we clone it. Okay, in that case, we clone it. Okay, now let us commit a change in this repository, in the local repository, and then we will push the change to the remote repository. Okay, so for example, I'll create here one file, hello.html. And if I run git status command, the file currently is in working area. Then we have to use the git add command to add this file to the staging area. Then if we do git status, now the file is in the staging area. Now to record the changes which we have made in our local repository, we have to first commit it, right? So to commit it, we will use this command git commit, and then we have to provide a commit message, right? Let's say adding hello.html in the project. Okay, now if we do git log, now we have total 5 commits: 1, 2, 3, 4, and 5. Right? And this was the commit we just made. And if we go to our remote repository, in remote repository, we only have 4 commits. Okay. In the remote repository, we have only 4 commits. In our local repository, we have total 5 commits. Now let us push those changes. So to push the changes, we will run the git push command, and it is asking us our username and password for the remote repository. Okay, so this is my GitHub username, and the password is the Git token. Okay, the password is the Git token. Now the changes are pushed to the remote repository. Okay, the changes are now pushed to the remote repository. Earlier we had 4 commits. Now we have total of 5 commits. Right? And here in this commit, we are able to see who made the changes, when the changes were made, what changes were made, and a commit description. Right? But when you are setting up the project for the very first time, then you have to do this git remote add. But when you are cloning it, at that time, by default, this remote repository will be connected to your local repository. So you don't have to run the git remote add command. Right? If we go to the clone repository and if we run git remote -v, so we can see it is already connected. So we don't have to connect it. So Raga Sandhya, we have seen this in the last session, that how to commit, how to push multiple files in one go. So if you want, I can show it again. So I'm creating here. Okay, so just to give context to everyone. So here again, Sandhya is asking how we can push multiple files in a single commit. Okay, so I'm creating here multiple files. Let's say file 1, file 2, file 3, file 4, and file 5. Okay, so for example, I have created here 5 files, and I want to add these 5 files in one go. Right? So first of all, if we run git status, so you can see 5 files are in our working area. Right? So in order to commit them, first we need to add them to the staging area. Now one more thing to learn here. So far to add the files, we used to use this command git add and then the file name. Right? Git add and the file name, which is completely fine if you have couple of files. If you have 2-3 files, in that case, you can use the git add command. But suppose you have hundreds of files. Okay, suppose you have hundreds of files. In that case, it will be very difficult for you to add those files one by one. Right? In that case, it will be very difficult for you to add the files one by one. So in that case, you can use this command git add dot. Okay, in that case, you can use this command git add dot. What this command will do, it will add all the files which are in your working area. Okay, before running this command, when we ran the git status command, so there were 5 files in the working area. Now when we ran this command git add, now let us check the status. So all the files now are in the staging area. So if there are multiple files, so in that case, you can use the git add dot command. If there are multiple files which you want to add to the staging area, like 10, 15, 20, 100 files, right? So in that case, you can use git add dot. If there are 2, 3 files, then you can use git add and the file name. Okay. Now the files are in our staging area. Now they are ready to be committed. Okay. So if we do git log, so here you can see a commit is added, and then we will do git push. Sorry, git push. Then your GitHub username and the password. So I think someone was asking what is git token. So this is just a notepad file. This is just a file I have created in my local machine to save the git token. Okay, so you don't have to worry about what this file is. Just from this file, I am copying my git token and then paste. Okay, I think someone was also having challenges in pasting. So here you can see I just copied it from this file and I just pasted it, and the changes are pushed. Right? And when you are pasting or typing here the code, you will not be able to see it. That is just for security purpose. You will not be able to see it here. Right? Now those changes are now pushed. Yeah, here you can see 5 files are added, and that is the 6th commit. And we can see who made the changes, when those changes were made, and what changes were made. Okay, Raga Sandhya. Do we have the option to see the content with commit code? So Shrikant, we have learned this in the last session. So Shrikant is asking how to see the content with the committed code. So for example, let's say we added some changes in index.html file in this commit, right? So here we can see what changes were made in this commit, and we can see that in this index.html file, this content was added. We can see here in this commit, this content was added to this file. In the CLI also you can check. In the CLI also you can check what changes were added in a specific commit. So you can run, you first need the commit ID, and then you can run git show and then the commit ID. So here we are able to see what changes were made in this commit. So here we are able to see that this content was added in this file style.css. So we can see it from the CLI by git show command, git show and the commit ID. And we can also see it from the GUI, the GUI of graphical user interface of the remote repository. Okay, you can add SSH keys in your GitHub account. Okay, that is not part of our course, that I'm just telling you for knowledge, that you can add your SSH key. Okay, with SSH key, you will be able to automate. In your GitHub account, you need to add one SSH private key. And then when you will be running the git push command, just by running git push command, your changes will be pushed to the remote repository. So now we followed a different approach while working with our with Git, which is, let's say we had a remote repository where there were already some commits. So instead of creating a local repository from scratch, we cloned that repository. And when we cloned the repository, whatever changes we had or whatever state we had of this remote repository, we got that state in our local repository. So suppose here there are 10 files, so 10 files are in my local repository. There are 10 commits, so I have 10 commits in my local repository. Plus, my local repository is also connected with the remote repository. I don't have to run the git remote add to make a connection with the local repository to the remote repository. Okay. Now we are going to learn some basic operations. Suppose, let's say I have added some changes in my staging area. Or overall, we are going to learn how to roll back changes. Okay, so we are going to learn two things. One is how to roll back changes from staging area to working area. Suppose accidentally I added some files. Suppose accidentally I added some files in the staging area. Now I want to bring those files back to the working area. How we can do that? This is one scenario. And another scenario we'll talk about is how to roll back changes from working area. So suppose in my local repository, I have made some changes. Now I want to undo those changes. Okay, I want to undo those changes which I have made in my local repository. So how we can do that? Okay, so to do that, we have git reset command. Okay, with git reset command, we will be able to roll back changes which roll back the changes which we have added in the staging area. Okay, those changes will be gone from the staging area to working area. Yes, you can say roll back to the last commit or roll back to the latest commit. And if you want to roll back the changes from working area, so for that we have git reset hard command. Okay, for that we have git reset hard command. And let's say one more scenario. If you want to roll back changes done in staging and working area both, then in that case also we use this command git reset hard. So we will talk about other commits also. We are not talking here about commits. Okay, right now we are not talking about commits. We are talking about in our existing working area, if we are making any changes, let's say suppose which are in staging area or in the working area, how we can roll back those changes. Okay, later we will talk about how to undo commits. For that we have another command which is git revert, that we will talk later. So let's say I'm making, okay, suppose now right now if I run git status, so my working area is clear. Now in one of the file hello.html, I am adding some content. Okay, so in hello.html, I have added some content. So right now, if I do git status, so that changes are in the working area. Okay, that changes currently are in the working area. Now let's say I want to undo the change which I have made. Okay, let's say I want to undo the change which I have made in my working area. So in that case, we will use this command git reset hard. And once we do that, if I do git status, the working area is now clean. Plus the content which we added in hello.html, that is also gone. Right? Earlier when I ran the cat command, I was able to see some content in that file, which I added. Right? And after that, when we ran git status command, we were able to see that change in the working area. But after we ran this git reset hard command, those changes are gone. Okay, those changes are now gone. Git restore is also similar command that will also do the same thing. Okay, that will also do the same thing. So if you do git reset hard, all the changes which we have made in our current repository, which were in our working area are now gone. Okay, so now again I am making a change. Now this change is currently in my working area. Now let's say I have added this to the staging area. Okay, first I made some changes in the file. So those changes were in working area. Then I added those changes to the staging area. Now let's say I want to roll back, or I want to roll back the changes. I want to go back to working area. Right now, let's say I'm in the staging area. I want to move one step back. I want to go to the working area. So for that, we can use the git reset command. And once you do that, you are now in the working area. Okay, you are now in the working area. And suppose, let's say you want to completely roll back all the changes which are in your working area as well as in your staging area. Then again, you can use git reset hard command. So now those changes are completely gone. Whatever changes you had in your staging area as well as in your working area, all are gone. So this is just a way to undo the changes. Okay, so this thing which we discussed was all about undoing changes in our current local repository. Okay, the changes which are not committed. Okay, the changes which are not committed, and if we want to undo those changes, so in that case, depending on different scenarios, we can use these commands. Okay. But now let's say I want to undo changes from a specific commit. Okay, suppose if I run git log command and I want to remove all the changes which were added in a specific commit, or I want to undo all the changes which were done in a specific commit. For example, I want to undo all the changes which were made in this commit. Suppose in this commit a file was added. Okay, let's understand it by a use case. Suppose you added 5 commits in your Git repository. And in one of the commit, you added some code changes which are faulty, which are creating bug in the application. Okay. When suppose you added 5 commits and in one of your commit, you added some code which is faulty, which is creating bug in the application. Okay. And let's say you added that code in this commit. Okay. You added that code in this commit. Now what you want to do is you want to undo the changes which you made in this commit. Okay, whatever changes which were added in this commit, let's say you want to undo those changes. Right. So for that, we have git revert command. Git revert and then the commit ID of that commit. Okay, 1 second. Just before that, we will make sure our staging area is clean. Okay, so we have 5 commits and I want to undo this commit. So we will run this command git revert and then the commit ID. It will first ask you to add a commit message. Okay, it will ask you to add a commit message. In that commit message, you have to tell your use case, that why you are undoing these changes or why you are undoing the changes in this commit. Okay, so here you can add your your reason of undoing that commit. Let's say this commit had bugs or has unwanted files, and then save it. Now if you do git log, so whatever changes which were made in this commit are gone. And in this commit, if you remember, we added one file hello.html. Here you can see I added commit message also adding hello.html in the project. Now to undo the changes of this commit, what we did, we ran git revert and the commit ID. So whatever changes which were done in this commit are now gone from our local repository. Okay, now if I do ls, so that hello.html file is no longer here. Okay, the hello.html file is no longer here. Or we can run this command also, git show and then the commit ID. Git show and the commit ID. This is C2 commit, this is C3 commit, and this is C4 commit. Okay, this is C1 commit, C2 commit, C3, and C4 commit. Now suppose in this commit, I added some or I made some code changes which created a bug in my application. Okay, I added some changes which created bug in my application. Now I want to undo the changes which were made in this commit. Okay, I want to undo the changes which were made in this commit, or let's say in this commit or any of the commit. So for that, we can use the git revert and the commit ID of C3 commit. So when you will be running this command, all the changes which were added in your local repository related to this commit will be gone. And a new commit will be created, and that commit will be called as the revert commit. Okay, this commit will be called as revert commit. And what this commit is doing, this is basically undoing all the changes which were made in C3 commit. Okay, it is undoing all the changes which were made in C3 commit. Okay, Shrikant is asking, how do we use the git revert after commit stage? Yeah, so that's what we are talking here, Shrikant. Then you can run git revert and the commit ID. Right? Git revert and the commit ID to undo the changes which you have made in that commit. Okay, then Mandir is asking, by using git revert command, only changes made in particular commit will be reverted. commits after that commit will be there. That will not be reverted. Yes. So only the changes which are made in this commit will be removed, not other commits. Okay, other commit changes will still be there. But suppose if you want to remove changes from other commit as well, let's say you also want to remove changes from C2 commit, then you have to again use git revert and the commit ID of C2 in order to undo the changes from C2 commit. Changes made in C4 commit will not affect by changes in C3. So it depends upon what changes you are making in C4 commit. Suppose in C4 commit you have not made any changes related to C3 commit. But if you have made any changes related to C3 commit and C4 commit, then basically you will face one conflict. Okay, then you will face one conflict. Okay, we will see, we'll talk about that later, how to resolve conflicts in Git. Okay, but in that case, you will face one a conflict. So Kusum, please pay attention. Okay, I can repeat it. I can repeat it again. So let's say I have a local repository. In my local repository, I have 5 commits. Okay, I have 5 commits. Now in these 5 commits, there was one commit in that commit, there was some bugs introduced in the code. There were, let's say, because of that code changes, there are some bugs. Okay. Now what I want to do is I want to undo all the changes which were made in this commit. Okay. I want to undo all the changes which were made in this commit. So in that case, we will use git revert and then the commit ID of that commit. For example, in this case, let's say it is the C3 commit. Okay, if you want to undo the changes which were made in C3 commit, in that case, you can use git revert and then the commit ID of C3 commit. Once you do that, all the changes which were added in this commit will be removed from your local repository. Okay, and once those changes are removed, a new commit will be created. That commit will be called as the revert commit. Okay, a new commit will be created. That commit will be called as the revert commit. If we have multiple commits in C3, till where it will undo with revert command. So whatever changes which were made in C3, let's say you added hello.html file, you added index.html file, you modified some content in let's say file.txt, file.html. So whatever changes which were introduced in that commit, all those changes will be undo. Okay, all those changes will undo. Okay, here I'm creating a file jack.html. Now this file currently is in my working area. Now I need to get rid of this file. So we can do git clean -f. This will remove the file from the working area. And suppose, let's say I have modified a file. Let's say there is index.html file and I have modified this file. So those changes currently are in our working area. Now to undo these code changes, in that case, basically you can use git reset. Okay, those changes are now gone from that file. But in your working area, if you have added any file or directory, so to get rid of those files, you have to use git 7 commits. Okay, in our local repository currently we have 7 commits, and in our remote repository we have 6 commits. Okay, we have 6 commits. Now to push the changes, we will use the git push command. Okay, and this will also do the revert part. Okay, this will also do the revert part, like we reverted one commit, right? So in that revert commit, I mean, it will add a new revert commit, and in this revert commit, it is telling that the changes which were in this commit are now reverted. So this way we can undo changes from commits. Okay, this is very helpful. Git revert is very helpful when you will be working in an organization. Suppose you have made multiple commits, and in a specific commit there were some bugs or some errors which was making the application unstable. Okay, or whatever template or script you have written, making it unstable. So with git revert, you will be able to undo the changes which you have made in that particular commit. Okay, so Raga Sunday is asking, but it is actually not needed to push the revert commit, right? So this commit is telling us that to other developers that the changes which were introduced in this particular commit are now removed from the repository. Okay, suppose if we didn't have any revert commit concept, then others will not be able to know that some code changes are removed. Yeah, plus we can add a reason why we are removing it. For example, here I've added this commit had bugs or has unwanted files. Okay, now we are going to learn different styles of working with Git. Okay, so far we have learned about basic commands and basic operations. Now we are going to learn about different styles, or we are going to learn about Git workflow. So in Git, we have a concept of branching. Okay, in Git, we have a concept of branching. So when we create a Git repository, whether it is a remote repository or whether it is a local repository, by default, there is a branch created. Okay, by default, there is a branch created, let's say by the name master. Yeah, by the name master. Okay, and this branch is also called the default branch. Okay, so far, whatever code changes we were making in our local repository, we were making the code changes in this master branch. Now, why is this branch required? Okay, why is this branch required? Or why do we have concept of branching in Git? So suppose, let's say someone wants to make some changes or someone wants to contribute in my project. Okay, someone wants to contribute in my project. So instead of, instead of directly making changes in the master branch, what the developer can do, the developer can create a copy of the code base. Okay, the developer can create a copy of the, or I would say a replica of the master branch by another branch. Let's say dev branch. And when the developer will be creating a new branch, that branch will be having all the changes for whatever state we had in the master branch, the same state will be in the dev branch. So then the developer can work independently, which means the developer doesn't have to commit his changes directly to the master branch. Okay, the developer doesn't have to make that changes directly in the master branch. The developer can create a clone of that branch by let's say by a name, let's say dev branch, and then he can commit his changes in the dev branch. Okay, then he can commit his changes in the dev branch. Okay, and when we will be working in an organization, we will have we will be having a default branch. Usually it will be named by master or main. So this branch is also represented as the production branch, or I would say finalized code. Finalized code in the sense, the code which is ready to be deployed. Okay, the code which is ready to be deployed, or the code which is production ready, which we can directly deploy on the server. Okay, so usually we do not directly make changes in the master branch. Okay, by default, when we will be cloning the repository in our local machine, so by default we will be in the master branch. Okay, but we do not directly make commits in this branch. Instead of making changes in this branch, we create a new branch. And that new branch will be the complete replica of this branch. So suppose in this branch, I have 5 commits and 5 files. So in this branch, the new branch which I will be creating will be having the same state, which means 5 files and 5 commits. Then I can make changes in this branch. I can make changes in this branch. I can test those changes. Once I am done and once my code is working, once it is ready, then I can merge these changes to the master branch. Okay, I can merge the changes from the dev branch to the master branch. So this is just a style of working with Git. We can also directly work on the master branch. Okay, if he's even we don't have to create multiple branches, we can directly work on the master branch. But it is not a best practice. Okay, it is not a good practice. A good practice or best practice that we are directly making changes in the master branch. Okay, in master branch we will be having the production ready code, which means which will be tested, which is already tested, and which is working. Okay, so it is just a best practice that we create branches. Instead of directly making changes on the master branch, what we should do is we should create a branch. We should create a clone of the master branch and then make changes in this branch, make the changes and perform testing. Once we are done, let's say once the code is working and is tested, then we can merge the changes, whatever changes we have introduced in this branch with this branch. That is the right way of working, or that is the best practice of working with Git. But without branching concept also we can work with Git, which means let's say you have only one branch, master branch, and you are pushing all your changes to this branch. But that is not a good practice. Because suppose you are pushing changes and those changes have some faulty code. And let's say this code is used by the operational team to deploy the application in production environment. Right? So that may cause issues in the production environment. So the best practice is that we create a new branch from the master branch, then we modify the code in this branch, and then we test it, and then we merge it with the master branch. Once it is ready, everything is functional, everything is working, then we merge it with the master branch. So Kusuma is asking is if there are 3 developers coding, then copies of master branch can be created, right? If there are 1,000 developers working, master branch, we can create clone of any branch. Okay, there is no limit. Every developer will be, when the developer will be cloning the code, the developer will get the local repository. Then in the local repository, the developer can create n number of branches depending on his use case. There is no restriction of creating branches. Okay, so this is just a style of working with Git. Okay, this is a style, or I would say this is a best practice of working with Git. We can directly work with the single branch also, but it is not usually a good practice. Okay, or when there are multiple developers working, suppose you are the only developer. So before pushing your changes, you are testing it and you are checking the functionality. Then you can basically go with this approach, which is having only one branch. But suppose there are multiple developers who are working in the code. Suppose there are 10 developers who are working in the code. So in that case, the best practice is that you create a new branch. Each developer will create a new branch and will make his changes in that branch, will test it. And once it is tested, then the developer will merge it to the master branch. Exactly. We commit is not the right term. We merge the changes to the master branch. Okay. We merge the changes to the master branch. Okay. So when you will be working in an organization, so in the organization also you will be having a remote repository. And in that remote repository, you will have a default branch, which will be the master branch. Okay. Now let's say when you will be working in a company, the company will be having a project management tool like Jira. This is very important to understand, which I'm explaining. So the company will be having a project management tool. For example, if they are using Jira, like most of the organization use Jira. So you will be, suppose in your remote repository, you have these 3 files. Okay. Now your manager or your team lead wants you to work on index.html. So the manager will create, or the team lead will create a ticket. Okay. He will create a ticket and he will assign that ticket to you. And that ticket will be having an ID. For example, let's say project 123. Let's say this is the ticket ID. And in this ticket ID, the team lead or the manager will tell you that make changes, or let's say make changes in index.html file, add a new functionality or add a new feature, or whatever the changes that the team lead or the manager wants you to add. So they will assign you a ticket. And what you will do, you will clone this repository in your local machine. And once you will be cloning, you will get the master branch. Okay, in your local machine, you will be getting the master branch. Now from this master branch, you will create a new branch. From this master branch, you will be creating a new branch. The branch name will be project 123 of your ticket ID. Okay, the branch name will be your ticket ID. In general, the branch name can be anything, but I'm telling you, when we are working with this, I would say a project management software, let's say Jira. So usually we create tickets by, branches with the ticket name. So let's say with this branch name, we will be able to identify later that this branch is created for this ticket. Okay, that's the reason it's a good practice that we create branch name by the ticket name. Okay, so a ticket will be created by the team lead or your manager in Jira, that will be having an ID. And when you will be cloning your repository, you will be creating a new branch by the ticket name. Ticket number or ticket name. And then whatever changes you were asked to make in this ticket, you will be making the changes in the code. Once you are done making those changes, you will merge those changes with the master branch. You will merge those changes with the master branch. And then you will push those changes to the remote repository. Okay, then you will push those changes to the remote repository. So this style of working with Git is called featuring. Okay, this style of working with it is called featuring, in which we create a feature branch. Okay, in which we create a feature branch. Before making any code changes in Git, first we create a feature branch, and then we do all the code testing and everything. Once we are done with the code testing, then we merge the changes to the master one, and then we push the changes to the remote repository. Okay, so this style of working with Git is called featuring, where we are creating a feature branch. Okay, where we are creating a feature branch. Okay, so now let us understand how branches are created and how we merge changes from one branch to another branch. Then we will learn about one more style of working with Git. Okay, so far when we used to run git status command, so you'll be able to see this message that you are on branch master. Even if you go to your remote repository, you will see here branch name as master. So master is called the default branch. Okay, master is called the default branch. Here you can see a tag is also added, default. Suppose I want to make some changes in my code. For example, let's say here we have these files. Now let's say I am asked to make some changes in style.css file. Okay, I am asked to make some changes in style.css file. So what we will do first, we will create a branch. So to create a branch, we have to use this command, git branch and then the branch name. Git branch and the branch name. So let's say I'm creating a branch by the name feature. Okay, then right now we are still in the master branch. So to go to that branch, we have to run this command, git checkout feature. Now, whatever state we had of our master branch, the same state now we have of our feature branch. Whatever state we had of our master branch, the same state we have right now of our feature branch. Which means, suppose in my master branch, I had 7 commits. So in my feature branch also, I will have 7 commits. Okay, right now where I am in the feature branch. How to verify that? You can run the git status command. So in git status command here, we are able to see that we are on feature branch. Okay, so yeah, so here we have 7 commits. So overall, whatever state we had of our master branch, the same state we have in this feature branch. So in our master branch, we had 7 commits. So here also we have 7 commits. And whatever files we had even in our master branch, the same files we have in our feature branch. Okay. Now let's say I was asked to modify style.css file. So let's say here I am adding the code. I'm making some changes in that file. Okay, let's say I added this content. And if we do git status, so those changes currently are in the working area. Then we will, with the help of git add command, we will add it to the staging area. And then we will commit. So now in my feature branch, I have introduced one commit. Okay, in my feature branch, I have introduced one commit. Now in my feature branch, if I do git log one line, so I have total 8 commits. 1, 2, 3, 4, 5, 6, 7, 8. So total right now in my feature branch, I have 8 commits. And if I go to my master branch, to switch branch, we can use the git checkout command, git checkout master. So if I go to my master branch, here I have 7 commits. Okay, here I have only 7 commits. In the feature branch, I have 8 commits. Right. So once we are done making changes in the feature branch, and once, let's say, you have performed your testing which is related to that particular code and you are fine with that, I mean with the code which is added to your project, then to introduce changes which you have added in the feature branch to the master branch, we have to use git merge command. Git merge and then the branch name. First of all, you have to go to the master branch and then you have to run this command git merge and the branch name. Now, once you run this command, whatever changes which are introduced in the master, I mean, in the feature branch are now added to your master branch. Now, if we do git log online, one line, so you'll be able to see now in your master branch, there are 8 commits. Okay. Now in your master branch, you have 8 commits. Right. So this is just a different style of working with Git. Okay, where we are creating a feature branch. In that feature branch, then we are making our changes. Once we are done with the changes, once those changes are tested and working fine, then we add those changes, or then we merge those changes with the master branch. And then we push those changes to the remote repository. So Jira, Srikanth, is a not ticketing tool. It is basically used for project management. And yes, we can create tickets in that tool. Can we merge a branch to other branches if we need other than master? Yes. So Sandesh is asking, suppose if we have multiple branches, let's say master branch, dev branch, feature branch, and I want to first merge my changes to the dev branch and then to the master branch, or let's say I want to merge only changes to dev branch, so that also we can do. So first you have to go to the dev branch and then run git merge and then the branch name which you want to merge. Kusma is asking if 2 developers merge at the same time from 2 different feature branches, will there be any changes loss of any one developer? No, there will be no changes. I mean, there will be no loss of code changes. I mean, commits. We will see that. We will talk about it. C1, C2, C3, C4, C5. Okay. Now from the master branch, we have created a new branch, feature branch. Okay, the branch name can be anything. Then here you have added a new commit. Let's say whatever changes you wanted to do, you have done it and you have created a commit. Now your commit, you have tested it and it is working fine. Okay, I mean, it has no impact on the application or whatever the code is about. Okay. Now, once you are done making the changes, you will merge the feature branch with the master branch. And once you will do that, so the new commit which is added in the feature branch will be added to the master branch. Suppose here also you had C1 commit, C2 commit, C3 commit, C4 commit, and C5 commit. Initially, you will have these commits only, right? When you will be creating a branch from the master branch, so whatever state you had from the master branch, the same state you will have of the feature branch. So suppose in master branch there are 5 commits, in your feature branch also you will have 5 commits. Now let's say you have created a new commit in feature branch, let's say C6, and you have tested it and it is working as expected. Now you want to introduce this commit in your master branch. So in that case, you will run, first you will switch to master branch. Okay, or let me put it this way. So in the master branch, to create the feature branch, you will run this command, git branch feature. Okay, this command you will be running in the master branch. Once the branch is created, to switch the branch, you will run this command. And once you are done making the changes in the feature branch, then you have to go back to the master branch or the branch where you want to merge the changes. Then in the master branch, you have to again, from the master branch, you have to run git merge and the branch. Okay, this you have to run in the master. And once you will run this command, whatever changes which are added in feature branch will be added to your master branch. Okay, this is not only applicable for one commit. Suppose in the feature branch, the developer has created multiple commits. So all the commits which the developer has added in the feature branch, when we will be running the git merge command, all those commits will be added to the feature branch. Okay. Now let us understand how this will work when there are multiple developers. So let's say this is the remote repository. And in the remote repository, let's say we have the master branch. So we will come on that, Sandesh, don't worry on that. We will talk about that as well. Okay, so suppose there are 3 developers. So all these developers have cloned the repository by the git clone command. All these developers have cloned the repository from the remote repository, right? And whatever state was there in the remote repository, the same state now they have in the local repository. Suppose in the master one there were 5 commits. So when they ran git clone, so all these developers now in their local machine have 5 commits. Okay, just to make it simple, I'll use 3 commits. Let's say on the remote branch there are 3 commits, and when the developers cloned it, here also they have 3 commits in their master branch. Now from this master branch, they will create a feature branch. Okay, in their local repository, they will be creating the feature branch. Then these developers will be making changes in the feature branch, and once they are done making the changes in the feature branch, they will merge the changes from the feature branch to the master branch. So suppose this developer has added 2 commits. Okay, suppose this developer has added 2 commits. Right now, when this developer will run git push, the remote repository will be updated with the new commits. Okay, the remote repository will be updated with the new commits. Okay, now let's say this developer has also added a new commit. Okay, this developer was working on some other feature of the application and has added a new commit. Now, when this developer will be pushing the changes, the developer will get an error that your master branch is not in sync with the remote branch. Suppose the developer 2 made some changes in the feature branch, then he has merged those changes to the master branch. Now he is pushing those changes to the remote branch. Now this developer will get an error that your master branch, sorry, your dev branch is, let's say, 2 commits behind from the master branch. Okay, this developer will be getting an error that your local repository, your master branch is 2 commits behind the remote branch. So in order to sync it, this developer has to run git pull command. Okay, this developer has to run git pull command. Now, once this developer run git pull command, whatever commits which were present in remote repository will be added in his local repository, in his master branch. Then he can push those changes to the remote repository. And whatever changes he added, that changes will be added as a commit in the remote repository. Then the same thing will be applicable for this developer also. When the developer will be merging his changes from the feature branch, once he is done making the changes in the feature branch and he has merged his changes to the master branch, now when this developer will try to push the changes to the remote repository, he will get an error that your local master branch is behind from the remote master branch. What error the the developer will be getting? Yeah, this is the exact message the developer will be getting. Your branch is behind by 7 commits. Okay, suppose let's say in the remote master branch there are new commits added. So when the developer is going to do git push, the developer will get this message that your current branch, your current master branch is 7 commits behind, or whatever the number of commits are there on the remote branch. So here you can see it is also saying use git pull to update your local branch. So first the developer has to run git pull, and then the developer will be able to run git push command. Okay, then the developer will be able to run the git push command. Okay, so I hope everyone is able to understand this concept. So this concept of merging looks very easy, but it is not as easy as it looks. Okay, because in case, suppose this developer has made some changes, for example, in this file. Okay, in index.html file, the developer has made some changes, and the developer has made changes in line number 5. Okay, for example, this developer made some changes in line number 5, and developer 2 also made some changes in index.html file in line number 5. So in this case, when this developer 2 will try to pull the changes from the remote repository, this developer will get an error of merge conflict. Okay, the developer will be getting an error of merge conflict. And merge conflict we have to solve manually. Okay, merge conflict we have to solve manually. So for solving merge conflict, we have Git merge tool. With this tool, basically we fix the merge conflict, and once we have fixed the merge conflict, then we push the changes to the remote repository. So Gaurav, I don't think yes, we can say that developer will that is actually a weird scenario when all the 3 developers will be running git push at the same minute, at the same second, right? If they are going to run the command git push at the same time, at the same second, then one push will be accepted at a time. All these 3 people will not be able to push at the same time. So testing, Sandesh, what do you mean by testing here? Can you tell me what you mean by testing? Testing, you can say, like developers perform unit testing. Okay, developers don't do functional testing, developers perform unit testing, where they just check the I would say, I mean, function, I mean, like whatever code they have added. So they just perform a, I would say, dry run kind of thing. That is called basically the unit testing with the code. And the functional testing is not done by the developers. Okay, so we will talk about that, how testing is performed. Okay, right now we are talking about one style of working with Git in which we create feature branches. There is one more style in which when the developer will be pushing the changes to the remote repository, he will not be pushing those changes to the master branch. Right now we are seeing that the developer is directly pushing changes to the master branch. But in our another style which we will be learning of Git, in that approach, the developer will not be pushing changes to the master branch. The developer will be first pushing changes to a dev branch or testing branch, and that will basically trigger the CI/CD pipeline, which will be performing the code testing, functional testing. And if the code is good, I mean, if it is working fine, then that code will be merged with the master branch. So we'll talk about it. That is basically, we'll talk about it later. Okay. So in case if multiple developers are working on the same code and on the same line of code, then the developers will get a merge conflict error. When they will be merging their changes or when they will be pushing their changes, pulling the changes from the remote repository, they will be getting a error, which is they will get a merge conflict error. And that merge conflict we have to solve manually. Now let us see how, in which case we will be getting merge conflict. Okay, so right now I'm in the master branch. Now from the master branch, I'm creating two branches. Let's say feature A branch and feature B branch. Okay, I have created two branches. Now first I will go to feature branch. Now I am in the feature branch. Now in feature branch, I am making some changes in index.html. In feature branch, now I am making some changes in index.html. In line number 3, I am adding some code. Let's say I'm adding feature A. In index.html file, in line number 3, I have added feature A. Now I am committing it. Okay, so I have made a commit. Now I will go to feature B branch. And in feature B branch, I don't have that content. Right? In feature B branch, whatever state I had of the master branch, I have the same state. Right? In master branch, I had only content in 2 lines. Right? Now here I am adding feature B. And I am adding feature B in the same line where I added feature A in feature A branch. Git add, git commit. Okay, So in master branch, like you can also use git log and then the branch name to check commits of that particular branch. So in our master branch, currently we have 1, 2, 3, 4, 5, 6, 7, 8 commits. Okay, in the master branch we have 8 commits. Let's see in feature A branch. Feature A branch we have 9 commits. There is one additional commit. And feature B also we have 9 commits. Okay, now I am done. Now I want to merge those changes with my master branch. So first we need to go to the master branch and then git merge and then the branch. Git merge feature A. Okay, so right now we didn't get any error, was smooth. Now if I run git merge feature B, merge conflict. This will only happen in case if multiple developers have made code changes in the same file and in the same line. In only that case, you will have this merge conflict. And in case of merge conflict, you have to logically fix it. You have to manually fix it. Now to fix it, we have to use git merge tool. Okay, you have to use git merge. So Sandesh, here we are not pushing. Here we don't have any changes in the remote repository. Right now we are not pushing any changes to the remote repository. Even if we are going to pull the change, then also basically we will be getting the same error, merge conflict. So it was very fast. Okay, what was very fast? I didn't understand. So let's get back where we were. So we were in the master branch. I'm repeating it again, those who think it was very fast. So first we ran git status and we were in the master branch. Then we created one feature A branch and one feature B branch. We created 2 branches. Then we went to the feature A branch. Then in feature A branch, we added some content in index.html file. Okay, we added some content in index.html file. Then, yeah, this was the content we added. Then we ran git status command and we saw that the changes were in staging working area. Then we added those changes. Then we committed the changes in the feature A branch. Right. I hope Harshdeep, you are able to follow up till here. Thank you. So in feature A branch, now there is a new commit. Then we went to feature B branch. Now in feature B branch, we made some changes in index.html file, and this was the content which we added. And this content we added in the same line where we added the changes in feature A branch. Then we added those changes to the staging area, and then we committed that change in the feature B branch. Right. Then we ran git log online command, git log master, then the git log, the branch name, and one line command. And when we ran this command, so we saw in our master branch, we have 8 commits. In feature A branch, we have 9 commits. And in feature B branch also, we had 9 commits. Now, in order to add those changes to the master branch, first we went to the master branch and then we ran git merge and feature A. And then we ran git merge and feature B. So when we merged feature B branch, so we were getting merge conflict. Why we were getting merge conflict? Because the the changes which were made in feature B branch were in the same line which were in feature A branch. So only in this case, basically, we will get merge conflict. For example, suppose in feature A branch, the code changes were made in line number 3, and in feature B branch, the code changes were made in line number 4. So in that case, you will not get this merge conflict error. Okay. Or let's say in feature A branch, the developer made changes in index.html, and in feature branch, the developer made changes in hello.html. So in that case, you will not get this merge conflict. You will get this merge conflict in case if both the developers are working in the same file and same line. Okay. Then to fix this merge conflict, we have to manually fix it. So to fix this merge conflict, we have to use this command, git merge tool. And then you have to hit here enter. Now when you will run this command, git merge tool, okay, 1 minute. Okay, I'm just connecting to the EC2 instance with SSH, another SSH client, because while using Vim or Nano in the browser-based SSH, the screen gets distorted. Okay, don't worry about these commands. These thing I am only doing to connect to the EC2 instance. Okay, this thing I am only doing to connect to the EC2 instance. Okay. So we were on this stage where we ran git merge tool command. So in git merge tool command, we are able to see here 4 screens. This is the state. The middle one is the state of the actual file which was in master branch. Before it was merged by any other branches, the state of this file in the master branch was this, where there were no content added. Then this state is of the feature A branch. This one, the left one, this left terminal is the state of the feature A branch. And then this, the right one is the state of feature B branch, the state of index.html in feature B branch. Then here it is asking us to fix the code conflict. Okay, this will be your actual file. This will be your actual code. So now it is asking you to fix this code conflict. Okay, now it is asking us to fix the code conflict. So Raka Sandhya, we need to run git merge tool command. We need to run git merge tool command. So now we need to fix the code conflict manually and logically. Depending on your code, you have to fix this code conflict manually and logically. Okay, so let's say I have fixed this code conflict. I have added feature A content in line number 3 and feature B content in line number B. Now, once I am done with that, we will run this command WQA exclamatory mark. You have to press escape WQA. Then you will see that there are few additional files created, okay, which are basically the stale files. So to get rid of these additional files, you have to run git clean -f, then git merge contain. Now the changes added in feature A branch and feature B branch are now added to your master branch. Okay, whatever changes you did in feature A branch, feature B branch are now added to your master branch. Yes, git clean -f. So let me again move here. Here we talked about that git clean command. So git clean command is to remove. See, when you will be using that git merge tool, Git will be creating some additional files. Those files will be reflecting the state of that index.html files in different branches. Now, once you have fixed the code conflict, then to get rid of these files, you have to run git clean -f command. Or you can run combination of df both, git clean -df. So let's say there is a master branch. In master branch, for example, there are 3 commits. Then from this master branch, we have created, let's say, 2 branches, feature A and feature B. So whatever state we had of our master branch, the same state we will have in our feature branch. So for example, in master branch, there were 3 commits added. So in feature branch also, there will be 3 commits. Right? Now let's say in feature A branch, in index.html file, you added some content in line number 5. Let's say you added this content, feature A, in line number 5. And you added some content in feature B in the same file, and in the same line. Now, when you are merging the changes, when you will be merging the changes from feature A to master branch, at that time it will be smooth. Smooth in the sense you will not get any code conflict, or you will not get any merge conflict. The new commit which you have introduced in feature A branch will be added to your master branch. Then the change which you have added in feature branch, when you will be merging this change to the master branch, then you will get basically a merge conflict. Then you will get a merge conflict. And merge conflict you will only get if you have made the changes in the same file and in the same line. Suppose this developer would have made changes in line number 6 or any other line, then you will not get this merge conflict error. Then it would be straightforward. Okay. So suppose both the developers have made the changes in the same line number, then you will get merge conflict error. When you will be running git merge command, with feature A branch, okay, when you will be running git merge command, feature A branch, then you will not get any error. But when you will be running git merge feature B command, then you will get one error of merge conflict. Then you will get an error of merge conflict. Then to fix this merge conflict, you have to use git merge tool. You have to use this command, git merge tool, and this command will open that screen, right, which we saw here. This command will open a screen with 4 tabs. Okay, there will be 4 files created. One file will be your index.html file. One file will be your index.html file in feature A branch. this window will have the state of index.html file in feature A branch. Then this file, I mean this terminal or this box will be having the state of index.html file in feature B branch. And in this file, the middle one, you will have index.html before merge from feature A branch. Okay, whatever state you had of index.html file before merging from feature A branch, that state of file you will be able to see here. So Git overall will create three additional files. Okay, Git will create three additional files. Then in this terminal, in this window, you have to fix the code conflict. You have to manually fix it. Okay, you have to manually fix the code conflict. Once you are done fixing the code, you have to press escape plus colon WQA. What this command will do, it will save and quit all the files. And after that, you have to run git clean-f. Git clean-f to get rid of these files, these additional files which are created by the merge tool. And after that, you have to run git merge continue. And all these things you have to do only in case of a merge conflict. If there are no merge conflict, if this developer has made changes in some other file and in some other line, then this case will never occur. This case will only occur in case multiple developers are working on the same file and on the same line of code. Then only basically we will get a merge conflict. And then only basically you have to use the git merge tool and you have to fix it manually and then git merge continue. And when you will be fixing your merge conflict, then basically it will ask you to create then a new commit will be created. That commit will be called as the merge commit. Okay, that commit will be called as the merge commit. We will talk about merge commit. We will cover that in the next session. For now, understand till here that to fix merge conflict, you have to use the git merge tool. And once you have manually fixed it, then git merge continue. Okay. So when we will be merging the changes from feature A branch to master branch, at that time, let's say if there is a new additional commit in feature A branch, so that will be introduced in the master branch. Okay, that will be introduced in the master branch. Now let's say there is a new change introduced in feature B. Okay, suppose in this commit, the developer made changes in index.html file, and in this commit, the developer made changes in, let's say, style.css file. Right now, we are not talking about merge conflicts. Okay, so let's say this developer has made changes in this file. So if the developers have made changes in different files, then there will be no merge conflict. Merge conflict will only occur if multiple developers are working in the same file and in the same line number that we saw in the last session, right? If both the developers are working in index.html file and on the same line number, then basically we will have the issue of merge conflict. But if the developers are working in multiple files, in different files, then there will be no issue of merge conflict. Now, when this developer will merge his changes to the master branch, okay, when this developer will be merging changes from feature B branch to master branch. So whatever changes this developer has added, that change will be added in the master branch. Okay, a new commit will be created. A new commit which will be from the feature B branch, from this branch. Plus, there will be one additional commit created. Okay, there will be one additional commit created, and that commit is called merge commit. Okay, that commit is called merge commit. One commit, see, initially in the master branch, we had 3 commits, right? That was the state of master branch initially. Then in feature, then one developer created a feature branch and introduced one commit. Then he, I would say, merged his changes of feature branch to master branch, and then this commit was created from this branch. Then this developer created a new commit, and this developer then merged the changes. So his commit is added to the master branch, but now additional one more commit is created. That commit is called merge commit. Now let us understand why merge commit was created by this developer, or by when this developer is adding a commit, why at that time merge commit was created. When this developer was merging the changes, at that time merge commit was not created. Okay, when this developer is merging the changes, at that time there was no merge commit created. But when this developer is merging his changes, at that time a merge commit is created. So the reason why a merge commit is created is because, so let's say when this developer was, I would say, merging his changes, so whatever state the master branch had, almost the same state feature branch had. For example, in master branch, there were 3 commits. So initially in feature branch also, there were 3 commits. And then the developer added new commits. Right? So when this developer merged his changes to the master branch, at that time, there will be no additional commit created. Additional commit in the sense, there will be no merge commit created. Merge commit will be created in case, for example, this developer is making changes in his branch, right? But now his branch is outdated. Okay, outdated in the sense, suppose here there are 3 commits, 3 commits from the master branch, but now your master branch have 4 commits. Okay, now your master branch has 4 commits. This commit is introduced by feature A branch. So now your master branch is ahead of feature B branch, right? Now your master A branch is ahead, sorry, master branch is ahead from the feature B branch. There are 4 commits in the master branch, and there are only 3 commits in the feature branch. Then after that, in feature B branch, the developer added a new commit. Now, when the developer will be committing his changes or merging his changes with the master branch, at that time, a merge commit will be created. Okay, at that time, a merge commit will be created. Because the master branch, or I would say feature branch, is not in sync with the master branch. Even if it would be in sync, then also basically a merge commit will be created. Okay, so I am in the local repository and in the master branch. And in my master branch, currently I have there are a lot of commits currently in the master branch. So what we will do, let us create another Git repository just for this demo. Okay, so I have created a new local repository. And currently there are no commits in the master branch. So let us create few commits. So I'm creating here one file, index.html. And I will add this file to the staging area and then commit it. And let's say I'll call this commit as C1 commit. Okay, now if we do git log one line, so in the master branch, now we have one commit. Now let us create one more commit in the master branch. So let's say in the second commit, I'm going to add new file style.css. Okay, so now in the master branch, we have total 2 commits. Okay, now from this master branch, I will create 2 branches, feature A branch and feature B branch. So to create a branch, we have this command git branch and then the branch. Okay, and when we will be creating the branch, so whatever state we have of our master branch, the same state we will be having of the feature A and feature B branch. Okay, so right now I am in the feature A branch. Now here, if I run git log one line, so we have the exact state of the feature branch. Like here also we have 2 commits. Now if I go to feature B branch, so here also we have the exact state, which means we have only 2 commits in the feature branch as well. The same number of commits we have in the master branch. Okay, and the content also is same. So in the master branch, we have 2 files and 2 commits. So in the feature branches also, we have 2 files and 2 commits. Okay, so overall, when we are creating the branch, so whatever state we will be having of the master branch, the same state we will be having of the feature branch. Okay, now let's go to feature A branch, and there we will add one commit. So let's say I'm adding one file. Let's say feature A.html. Then git add, git commit, and I'll call this as FC1. So Nishan, that's what I have been saying, that when we create a branch, it will also copy the data. Right? That's what I showed here also. That when we are creating a branch, whatever state we had of the master branch, the same state will be replicated to the feature branch. So in master branch, let's say I have 3 files. So when I will be creating the feature branch, the same 3 files will be copied to the feature branch. And whatever number of commits I will be having in the master branch, the same number of commits we will be having in the feature branch. Okay. And to list the number of branches we have in our local repository, so we can use this command git branch -a. Anand, I'll come to your Nathan Kumar. I'll come to your question as well. Let me complete this topic and then I'll come to your question. Okay. So to list all the branches we have in our local repository, we can use this command git branch -a. With this, we are able to see all the branches which are currently in our local repository. And in this output, you are seeing here that there is one branch which is highlighted in green. Plus, we are seeing here one asterisk. So this basically represents that our current branch is this branch. Or you can also run git status command. That will also show you in which branch currently you are on. Okay. Now here in this branch, we have created one file, feature A.html, and we have also committed it. right? We have introduced one commit in the feature branch. Okay, in master branch, we had 2 commits. In feature branch, we have introduced one commit, FC1. Now we will go to feature B branch. And here we will create one file. And I'm adding here one commit. Let's call it as FBC1, feature B commit 1. So initially in the master branch, we had 2 commits, and the same number of commits we will be having in the feature branch when we created the branch. Right now in feature A branch, I added one commit. And in feature B branch also, I added one commit. Now we are going to merge these changes with the master branch. So first we will merge the feature A with the master one. Now to do that, first we need to switch to the master branch. Git checkout master. After to git status, so we are now in the master branch. Then git merge and then the branch. Okay, so first we switch to the master branch and then we ran git merge and the branch. Now if we do git log, so here you can see a commit is added in our master branch, which is from the feature branch. We have done is first we went to the master branch and then we ran this command. And when we ran this command, the commit which was added in the feature branch is now added to the master branch. So now in master branch, we have total 3 commits. Okay, now in master branch, we have total 3 commits. One commit is added from the feature A branch. Now let us merge the changes from feature B branch. So right now we are in the master branch and here we will run git merge feature B. Now once you merge it, if there are no merge conflicts, so you will see this message, this window. And this window is basically of merge commit. Here it is asking you to add add message in the merge commit. Okay, so you can add any message depending on your use case. Let's say merging feature B branch with master branch. Okay, any message you can add. And it's, I would say it's optional. If you don't add, then also it is fine. Okay, after that, you have to press Control plus O, and then Control plus X. By default, it will be opening in the nano text editor. Okay, when you will be running git merge feature B, so it will open that merge commit window in nano. Okay, in the nano text editor. Now, if we do git log, git log one line. So now in the master branch, we have a commit from the feature branch FC1, and we also have the commit from the feature B branch, plus we have one additional commit. And this commit is called the merge commit. Feature B branch with the master branch. And once we did that, the commits which were in the feature branch are now introduced in the master branch. Plus an additional commit is created. That commit is called the merge commit. Okay, a new commit is called, a new commit is created, which is the merge commit. Now Git Rebase is also similar to Git merge. Okay, which means, let's say we have a master branch, and we have feature branches. Okay, we have a master branch and we have feature branches. Now, let's say in the master branch, we have 2 commits. And in the feature branch also, we have 2 commits. Okay. And let's say in feature A branch, there is a new commit added. Okay. Now you can merge these changes from your feature branch to the master branch with the help of Git Rebase command as well. Okay, you can do the same thing with Git Rebase command as well. For example, okay, let's say this is your master branch and this is your feature A branch and this is your feature B branch. And in feature A branch, there is a new commit added. Now, and in feature B branch, let's say there is a new commit. Now we can merge these changes, merge the changes from feature A branch or feature B branch with Git Rebase command as well. Okay, we can do this by Git Rebase command as well. For example, first we will go to the master branch. And now instead of using Git merge command, we can use Git Rebase command. Git Rebase and then the branch. Okay, Git Rebase and the branch name. So if both are doing the same thing, then what is the difference? Okay, the difference is when you will be merging the changes from feature B branch with the master branch. In case of Git merge, when we are using Git merge and feature B, at that time, a merge commit is created, right? At that time, an additional commit is created, which is the merge commit. But when you will be using Git Rebase command to do the same thing, at that time, there will be no new merge commit created. There will be no additional commit created. Okay, there will be no additional commit created in case if you are using the Git Rebase command. But if you are doing it with Git merge command, at that time a merge commit will be created. Now let us understand when to use Git merge and when to use Git Rebase. Okay, even if it is creating a merge commit, we don't have any issues, right? Just a new additional commit is created. The problem will arise when multiple developers are working on the project and multiple developers are merging their changes. So when each developer will be merging his changes, a new additional commit will be created, which will be merge commit. So suppose 10 developers have merged their changes. So there will be 10 additional merge commits created. Okay. In that case, 10 additional merge commits will be created, which will end of the day increase your, or I would say, increase your the commit history. Right? In your commit history, you will be having a lot of merge commits. Right? So instead of using Git merge command, we can use Git Rebase. And with Git Rebase, we will not be, when we'll be using Git Rebase, it will not create an additional commit. Okay. Now let us understand in which style of Git we will be using Git Rebase. Okay, in which style of Git we will be using Git Rebase and in which style of Git we will be using Git merge. Okay. Okay, so the branches which we were discussing, like the feature branching Git style we were learning, and which we create branches. Okay, so these branches which the developer will be creating in his local machine, these branches will be only in his local repository. Okay, these branches will only sit in the developer's local repository. These branches will not be there in the master branch, in the remote repository. these branches will not sit in the master branch. I mean, in the remote repository. Okay, in feature branching style, when the developers will be creating their own branch, so these branches will stay in their machine. These branches will not be pushed to the remote repository. The reason is because suppose there are 100 developers working, and let's say all the developers are creating their own feature branches. And if they are pushing those branches to the remote repository, then there will be lots of branches there. Let's say if there are 100 developers and each developer have created their own feature branch, then there will be hundreds of branches in the remote repository. That will increase the size of your, overall of your Git repository. Right? So this feature branch will only sit in the developer's local machine. This feature branch will not go in the remote repository. In the remote repository, in this style, in feature branching style, we will be having only one branch, which is the master branch. And feature branches will be in the developer's local machine. Feature branches will not be in the remote repository. Because if we start creating feature branches, hundreds of feature branches, in the remote repository, then there will be a lot of branches in your remote repository, which end of the day will increase your code repository size. Plus, it will be very difficult to manage if there will be multiple branches. Right? Now we have one more style of working with Git, in which there will be a dev branch. In the remote repository, this one which we are talking about is basically a remote repository. Okay, this is a remote repository. Remote repository means the GitHub repo. So in this style of Git, there will be one branch master, plus there will be one additional branch, let's say dev branch. Okay, there will be one additional branch, dev branch. Now, when the developers will be cloning the code, so they will be cloning, when they will be running git clone command in their local machine, so they will be getting all the branches which are available in the remote repository. Right? For example, let's say in the remote repository, there are two branches, master and dev. So in their local machine, they will get master, dev, these two branches. Then later, based on their use case, they can create their own feature branch. Okay, then they can create their own feature branch. Let's say feature A, feature B. Okay, then they will be merging their changes in the dev branch. They will not be merging changes in the master branch. In this style of Git, the developers will not be allowed to make changes in the master branch. Master branch will be locked. Locked in the sense when the developer will try to merge changes in the master branch, they will get an error that the master branch is locked and is in read-only mode. So the developers will not be allowed to merge changes to the master branch. Okay, developers will not be allowed to make changes in the master branch. Okay, so they will be having one public branch. Public branch means the branch which will be on the remote repository. Okay, this type of branch is called public branch. Okay, this one, the master branch is basically our default branch. Okay, default branch, or it is also called the main branch. Then other branches which we create are called public branches. Public branches, they are called public branches because they are on the remote repository. Okay, and the branches which developers create, like feature branches, So these branches are called private branches. Private branches, they are called private branches because these branches will sit in the developer's machine. These branches will not go to the remote repository. And hence these branches are called private branches. Okay, so in this style of working, in this style of Git, we have a dev branch, we have a public branch on the remote repository, and the developers will be merging their changes with the dev branch. They will not be allowed to merge changes in the master branch. So what developers will be doing, they will be merging their changes with the dev branch, and then they will be pushing their changes to the remote repository in the dev branch. Okay, they will be pushing their changes to the dev branch. First, from the feature branch, they will merge the changes with the dev branch, and then from the dev branch, they will be pushing their changes to the remote repository. And then from the dev branch, the changes will be merged to the master branch. Okay, then from the changes from the dev branch will be merged from the merged from dev branch to the master branch. Now, one important thing to understand here is, overall, we are discussing this to understand when to use Git merge and when to use Git rebase. So for public branches, when we are merging public branches, at that time we use Git merge. When we are merging public branches, at that time we use Git merge. What are public branches? The branches which are on the remote repository. Let's say on GitHub. The branches which are on GitHub, those are public branches. So when we are merging changes from public branch to another branch, in that case, basically we use git merge command. But when we are merging changes from private branch to a public branch, in that case, basically we use Git Rebase command. Okay, and we saw one advantage. The advantage was that when we are using Git merge command, so a merge commit is created, right? A merge commit was created. But with Git Rebase, when we will be merging the branches, there will be no additional commit created. Okay, no additional commit will be created. So overall, it will not increase your commit history. Right? So we use Git Rebase when we are merging changes from the private branch to the public branch. And when we are merging changes from the public branch, one public branch to another public branch, in that case, we use Git merge. Okay, in which a new merge commit will be created. Right, when we will be merging changes from the dev branch to the master branch, at that time, if the master branch is behind from the dev branch, or let's say if there are new additional commits in the master branch, at that time a merge commit will be created. Okay, at that time a merge commit will be created. So for merging public branches, we use Git merge. For merging private branches, we use Git rebase. Now again, what is public branch and private branch? So public branch is a branch which is sitting in your remote repository. Okay, the branches which you have in the remote repository are called public branches. Okay, so whatever branches you have here are called public branches. And the branches which you create in your local machine, like the feature branches, so those branches are called private branches. Okay, those branches are called private branches. And the branches which are in your remote repository, those are called public branches. We never push the feature branches, the feature branch to the remote repository. Okay, feature branch is never never pushed to the remote repository. Okay, we only push changes. I mean, like from feature branch, we will be merging changes with the dev branch, and then we will be pushing the changes from the dev branch to the remote repository, remote public repository. Sorry, remote public branch. So the branches which we have in the remote repository are called public branch, and the branches which developers create in their local repository are called private branches. And private branches are never pushed to the remote repository, because if developers start pushing branches to the remote repository, the private branches, then in that case there will be a lot of branches, right? If there are 100, 200 developers working, or if they are working frequently on adding different features in the application or in the code base, so there are hundreds of branches created. Okay. Okay, now in our remote repository, let us create one branch. Okay, we will create it from the local repository itself, and then we will push that to the remote repository. So I'm cloning the repository again. So I'm removing all the repositories, all the directories which we created. Okay, so I have cloned the remote repository. And currently, if we do git branch -a, so we only have one branch, which is the master branch. Now here we will create one branch, dev. Then we will go to this branch. And right now we are in the dev branch. Okay, right now we are in the dev branch. Now let us create two branches, two private branches. Suppose there are two developers. So let's say one developer has created feature A branch and one developer has created feature B branch. Then we will merge those changes from the feature A and feature B branch with the dev branch. And one more thing to note here is right now I'm creating these branches from the dev branch. Right now I'm sitting in the dev branch, and from the dev branch, I'm creating these feature branches. Okay, from the dev branches, I'm creating these feature branches. So now whatever state I have of the master branch, that state I will not be having in the feature branch. Okay, so let's say in my local repository, I have master branch, dev branch, now let's say in the master branch, let's say we have 3 commits. And in the dev branch, I have 2 commits. Now let's say I'm creating the branches, feature branches from dev branch. Suppose first I went to the dev branch, and from this branch, I'm running these commands. Git branch feature A and git branch feature B. So whatever state I will be having of the dev branch, the same state will be replicated to the feature branches. Okay, the same state will be replicated to the feature branches, which means let's say in the dev branch, I had 2 commits. So in the feature branches also, I will have 2 commits. But when I will be creating these branches from master branch, so whatever state I will be having of the master branch, the same state will be replicated to the feature branch. But now when I'm creating from the dev branch, so whatever state I have of the dev branch, the same state I will be getting in the feature branch. So let's say in dev branch, we have 2 commits. So in feature branch also, we will get 2 commits. Okay, now let's make some changes in feature A and feature B branch. Okay, so right now I'm in the feature A branch, and here I will create one file. Let's say feature A file. Okay, now I'm committing the changes. Let's say FAC1. Feature A, commit 1. And if we do git log 1 line, so we have a new commit in the feature A branch. Now let's move to the feature B branch. So in feature B branch also I'm adding a change. I'm adding a file. Okay, so we have created a new branch, feature B branch. Sorry, in the feature B branch, we have added a new commit. Okay, let me show you in this way. So git log dev 1 line. So in the dev branch, currently we have 1, 2, 3, 4, 5, 6, 7 commits. In the dev branch, currently I have total of 7 commits. Now let us see the commits in feature A branch. In feature A branch, total we have 8 commits. And in feature B branch also we have total 8 commits. Okay, now let us merge changes in the dev branch. Because in the master branch, we will not be having access to merge the changes. Okay, when you will be working in an organization, the master branch will be locked. You will not have write access in the master branch. Okay, you will only have read access in the master branch, because master branch will be your production ready code. Right, master branch will be your production ready code, which will be end of the day deployed to the servers. Right. Okay, so now we will go to the dev branch, git checkout dev. Now here we will use the git rebase command. Okay, now we will be using git rebase command to visualize this. So master branch and dev branch will be sitting in our remote repository. Right now we only have master branch, but we will push dev branch as well. So we will be having both these branches sitting on GitHub on the remote repository. So both of these are public branches. Okay, both of these are public branches. And these branches, feature A and feature B branch, these are private branches, which will sit in only in the developer's machine. These branches will not sit in the remote repository. Okay, these branches will not sit in the developer's machine. I mean, these branches will sit only in the developer's machine. Okay, so I can see a lot of questions in the chat, so I will answer those questions once I am done with this topic. And after that, your questions will be answered. Okay, so now to merge changes from private branch to the dev branch, we will use Git Rebase. Why we will use Git Rebase? Why not Git merge? Because if we will be using Git merge command, in that case, it will be creating additional merge commits. And that will increase your commit history. Right now, we are basically taking, I mean, just for learning purpose in our branch, I mean, in our Git repository, we have hardly 5 or 10 commits max to max. But when you will be working in a, in an organization, so there you will be having thousands of commits. right? And let's say if you are using the git merge command, so when you will use the git merge command, every time it will create a new additional commit, which is the merge commit. So your commit history will grow because of these additional merge commits as well. Right? So when we will be merging the private branches with the public branch, so at that time we will use Git Rebase, so that there is no additional commit created. And when we will be merging the dev branch with the master branch, at that time we will be using Git merge. Okay, or in other words, when we will be merging the public branches, at that time we will use Git merge command, because that will occur only once, right? That will only occur once. Whereas let's say there are 100 developers, so 100 developers have created their own feature branches, right? So when they will be merging the changes, they will be merging in the dev branch, right? And when they will be merging changes, so they will be using Git Rebase. Else, at every commit, a new merge commit will be created. Okay, so if 100 developers are merging changes, so 100 additional merge commits will be created. But when we will be merging changes from dev branch to master branch, that will be only done once. So even if it creates a merge commit, then also it is fine. And with that merge commit, we are just telling that we have merged dev branch with the master branch. Okay, so right now we are on the dev branch. Okay, and we saw here in the dev branch, we have total 7 commits. In the feature branch, we have 8 commits. Feature A branch, we have 8 commits. And feature B branch, we have 8 commits. Now we are using Git Rebase to merge those changes. Merge those changes in the dev branch. So currently I am in the dev branch. So Git Rebase feature A. Now if we do git log 1 line, so the change from the feature A branch is now introduced in the dev branch. Now let us use the same command, Git Rebase feature B. Okay, now if you notice, there is no additional commit created. Earlier, if the same thing we would be doing with git merge, so at this point it would be creating a merge commit. But as we are using Git Rebase, there will be no additional merge commit created. Here you can see feature B commit and feature A commit. And there is no additional new commit created. Okay, there is no additional commit created, merge commit. Now, once we are done merging the changes, then we can push these changes to the remote repository. Okay, now when we are pushing changes for the very first time, at that time, basically, we have to tell where we want to push the changes and in which branch. So this thing you have to only do once when you are pushing the changes or when you are creating the public branch for the very first time. Git push, origin, and then the branch name. Origin is basically pointing to your remote repository, which you have here. Okay, so in this command, we are telling git push that we want to push the local changes to this remote repository origin and to the dev branch. Then it is asking for the credentials. Okay, the changes are now pushed to the remote repository. Now in the remote repository, we have 2 branches, master and dev. And master branch now has total 9, dev branch has total 9 commits and the master branch has 7 commits. So for private branches, we use Git Rebase, and for public branches, we use.
What is the purpose of a Docker file in Docker? Option A, to store container images. Option B, to define the structure of a Docker container. Option C, to manage Docker volumes. Or option D, to configure Docker network settings. Comment down your answer below in the comment section. Just a quick info guys, Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Git merge. So now let's say in case if we want to merge changes from dev branch to master branch. So in that case, we will be using the git merge command. Okay, but only an authorized person will be able to merge changes from the dev branch to the master branch. Authorized in the sense the person who will be having admin access to the repository, or the person who is a collaborator to this remote repository with write access. Okay, write access in the master branch. Only that guy will be able to merge the changes from the dev branch to the master branch. Or for example, let's say we have one more branch. Let's say before dev we have one, let's say release branch or test branch. Okay, let's say we have a test branch. So when we will be merging this dev branch with the test branch, so in that case, we will use the git merge command. And then when we will be merging from test branch to master branch, then we will again use the git merge command. So only for public branches, we use git merge command. For the private branches, we use git rebase. Because when we are using git merge command, a new merge commit is created. So after every commits, there will be new additional commit created. That will increase the size of your repository and increase the number of commits. So master branch Ragasandhya will be created. See, when we will be cloning the remote repository, this is the concept we have learned when this is the nature of distributed version control system, right? So when we do git clone, so whatever state we will be having of our remote repository, the exact state will be replicated to our local machine. So suppose in our remote repository, we have 3 branches. So all these 3 branches will be created in our local repository. And whatever commits we have in these branches, the same number of commits we will be having in our local repository. So overall, when we run the git clone command, so we get the exact state of our remote repository. Chandrakant, I didn't get what you mean by is it default or have to be set manually. So AB, we have discussed what is the advantage of rebase. I hope it is clear to you. Shrikant, I hope private branch is clear to you now. Yes, syntax is same. We have to use the same command like we used for git merge. The same command we have to use for rebase. Yes, you can say AB that public and private concept is only for git rebase. When we are working with, or when we are working in this style of git. Okay, when we are working in this style of git where we have multiple branches in the remote repository. At that time, basically, we use the git rebase command. Okay, at that time, we use the git rebase command. I would say addressed. If still you have any question or if your question is not answered, you can type it on the chat if I have missed any question. Okay, so Raghunandan is asking what is the role of DevOps engineer in this whole scenario. So, I mean, as a DevOps engineer, see, right now we are talking more in terms of, I mean, we are taking an exam. We are right now only learning only how Git works. Okay. So later when we will be learning different tools, or as a DevOps engineer, when we will be working with some templating tools like Ansible, Terraform, Kubernetes, Docker Compose we don't have in our course. So if we will be learning these tools, so in these tools, basically we create templates. Okay. And these templates will be sitting in your Git repository. So as a DevOps engineer, we will also be managing a Git repository where we will be keeping our stuff, our Ansible playbooks, Terraform templates, Kubernetes manifest file. In Docker Compose, we have Docker Compose file. Okay, and as a DevOps engineer, we also do coding, shell scripting, Python scripting, right? So for that, for the version control management of our code, so for that also basically we will be using, I mean, Git, right? So that's where basically we will be using Git as a DevOps engineer. And even Git merge command is also not required. You can just create a master branch, and in that master branch, you can push all your changes. Right? So these are different styles of working with Git. Different styles, or I would say best practices of working with Git. Earlier, initially when we started, so we just created one master branch and we were pushing all the changes to the master branch. So that way also we were able to work with Git, but that is not the right way of working with Git. So the right way of working with Git is either we create feature branches, right? Or either we create public branches in the remote repository and we create local branches in the local repository. Local branches or private branches in the local repository. Right? So when we are working in this concept, like when we are creating public branches, private branches, so in that case, when we are merging changes from the private branch to the public branch, so in that case, the best practice is that we use Git Rebase. But you can also use Git Rebase to merge changes from dev branch to the master branch. You can do that also. But this is, I would say, the standard way of working with Git. You can see, you can directly, or you can use one tool. You can just use Git merge to merge all the changes. Or you can use Git Rebase also to merge all your changes. Both will do the same thing, which will be merging the changes. Just in Git merge, you will be, I mean, there will be a new merge added, new merge commit added. Right? So this is, I would say, a standard way of working with Git. And right now we are learning, that's why we are not able to, I would say, understand the challenges. Right now in our branch, we have 7-8 commits. When you will be working in an organization where you will be having hundreds or thousands of commits, at that time you will understand, this problem. So suppose you have merged your changes in your local branch. Now you want to push, in your local repository, and you want these changes to be introduced to your remote branch. I mean, to your remote repository. Suppose in your remote repository, you have a master branch, let's say a dev branch, for example, let's say a dev branch, and in dev branch, let's say you have 2 commits. And in your local machine, in your dev branch, you have 3 commits. Now, if you want to add your changes, or I would say update your dev branch in the remote repository with your local branch, I mean, with your local repository branch, in that case, we use Git push command. So once we will do Git push, so whatever state we have of our dev branch in our local machine will be added here. Okay, will be updated with our local repository branch. And pull request is not part of our course. So pull request, I would say, is a different concept. It's not of Git. That concept is specific to the, I would say, provider in the sense like GitHub, GitLab, Bitbucket. In these, I would say remote repository, we have that concept of Git pull request. Okay, but here we don't have anything Git pull request in the Git CLI. This is the third session of Git. This is the third session of Git. Okay, so I think someone was asking. Yeah, Kanak was saying we have only learned basics of Python. Okay, so this is just a recommendation. Okay, based on my experience, I'm telling you that as a DevOps engineer, what you should know in Python. Okay, as a DevOps engineer, what you should know in Python. Okay, so first of all, you should know basics in Python. Basics in the sense how to create a loop, how to create a function, right? For loop, while loop, functions in Python. And you should also have an understanding of list, tuples, sets, dictionary. Then you should also know how to use modules, basic modules like math module or OS module, sys module, basic modules. Then as a DevOps engineer, I would recommend you to learn these Python modules. One is OS module, sys module, regex module, Boto3 module, and request module that is basically used to query APIs, then JSON module. So as a DevOps engineer, you should be familiar in using these modules. OS, sys module, regex. Regex is for a regular expression. And also you should know how to perform file handling. File handling in the sense how to open a file, how to edit a file. Okay. And apart from that, as a DevOps engineer, you should know these modules. Boto3 is for AWS. Request is for querying APIs. JSON is basically used when we are working with JSON documents. Okay. So if you know the basics, you can start learning about these modules. Okay. Now, when you will be, let's say from this developer, let's say this is dev 1. And this is developer 2. So when this developer will be merging his changes from dev branch to, feature A branch to dev branch, that will be smooth. Right? Once he merge the changes, like with git rebase command, so a new commit will be created. A new commit will be added in the dev branch. Okay. A new commit will be added in the dev branch. Now, when this developer is going to push the changes, then in the dev branch, a new commit will be created on the remote branch, in the remote repository. Okay, now there are total 3 commits. Now here also this developer 2 has added a new commit in feature branch and he has merged his changes to the dev branch. So that will be smooth. But now when this developer will be trying to merge his changes to the dev branch, the developer may get merge conflict. No, not merging the changes. Suppose, let's say when the developer will pull the new changes, right? When the developer will run git pull, okay, to sync his local dev branch with the remote branch, when the developer will run git pull, the developer may get an error of merge conflict. If there are no merge conflict, then the pull will be successful. But if there would be merge conflict, code conflict, then the developer will get an error of merge conflict. Okay. Now what the developer wants is, the developer wants first to introduce these changes, whatever changes are in the remote repository in his branch. And then he wants the new changes which he's adding to be added on top of it. Okay. So in that case, basically we use the git stash command. What git stash will do, it will undo the changes which this developer has made in this commit. It will undo the changes temporarily. This particular change will be removed. And then the developer can first run git pull command and can sync his local repository with the remote repository. Then the developer can redo his changes, like the developer can use this command git stash pop, and whatever changes he added in this commit will be then merged with the new commit, or will be added to the newer commit. Else the developer will get an error that your, then the developer may get a merge conflict error. Okay. Now I don't want to commit these changes, or let's say I am running git pull command. So when I am running git pull command, I am getting an error that your current branch is not in sync, or I'm getting an error of merge conflict. Okay, suppose when I am running git pull command, I'm getting an error of merge conflict. So what so overall, because of that merge conflict error, I'm not able to I'm not able to add the changes from the remote repository. For example, suppose in my remote repo, I have 3 commits. And initially in my dev branch, there were 2 commits. Right? And let's say I merged my feature branch with the dev branch, and there is a new commit created. Now I don't want this commit. Let's say there is a new commit added. Now when I am pulling my changes from the remote branch in order to sync my dev branch, so I'm getting a merge conflict error. Because let's say in this commit which this developer has made, he has made some changes in the same file and in the same line number which this developer has made. So when I'm pulling the changes, I'm getting a merge conflict. Right? So in that case, what I can do, I can undo my commit. Sorry, no, not my commit, I can undo my changes. So let's say here I have made some changes in the file. So we can do git stash. What git stash will do, it will temporarily remove your changes. So suppose in file 1, I added some content. Sorry, file 2. In file 2, I added some content. So now that content is gone. Now I can do git pull to get the changes from the remote repository. And once the changes are added, or once the changes are pulled from the remote repository, then I can do git stash pop. And when I will be doing git stash pop, so whatever changes I made before running git stash command, those changes will be added back to my local repository. Okay, so earlier before running the git stash command in file 2, we added this content. Right, so that content is now back. Or in general, let us understand this in general. Suppose I am making some changes in my branch, and those changes, let's say, are in working area or in staging area, and I don't want to commit those changes. Okay. For example, let's say currently in my working area, I have one file, file2.txt, and in this file, I have added this content. And let's say I have another file, and in this file, I'm adding some more content. Okay, so I have total of 2 files. I have modified 2 files. Now I want to temporarily undo these changes, temporarily. So in that case, we can use git stash. Git stash. This will temporarily undo the changes. Okay, and my working area is clean. And now when I will be catting these file2.txt and index.html, the content is gone. The changes which I made before running git stash are gone. Now let's say I want to get back those changes. So we can do git stash pop. And once we do git stash pop, all the changes which we made before running git stash are now there. So git stash command you can use to undo your changes in the working area as well as in the staging area. If the changes are in the staging area, in that case also you can use git stash. Okay, in that case also you can use git stash to temporarily undo your changes. Okay, if you want to permanently undo your changes, in the last session we learned about this command, git reset hard. Right, this will permanently undo your changes. But if you want to temporarily undo your changes, in that case we can use git stash. The command is simple. You have to just run git stash, and then git stash pop. If you want to bring back those changes, git stash pop. So git stash you can use in case if you want to temporarily undo your changes. Suppose in case if you want to pull some changes from the remote repository and you are getting a merge conflict. So in that case, first you can undo your changes which you have made in your working area or staging area, and you can first get those changes from the remote repository, and then with git stash pop, you can add your changes. Okay, so overall use of git stash is to temporarily undo changes which we have made in our working area or in the staging area. So with this, we will be able to undo our changes temporarily. And if we want to permanently undo the changes, then we learned about git reset hard command, right? So with that, basically the changes which we have made in our working area and staging area will be permanently removed. So let's say this is the public repository, and this public repository is in this user's account. Okay, this public repository is in this user's account, WordPress. Okay, if the repository will be in my account, then it will look like this, my GitHub username and then my repository name. So for example, this is a public repository which is sitting in some other's GitHub account. Okay, now I want to contribute in this project. Okay, I want to contribute in this project, or I want to build my own solution out of this open source project. I want to customize it and I want to build my own solution. So first of all, I will not be able to commit on this repository. I will be able to clone it. Okay, as it is a public repository, anyone in the world, anyone in the internet can clone it. Okay, as it is a public repository, so anyone can run git clone command and clone the repository. Okay, anyone on the internet can just use the git clone command to clone the repository as it is a public repository. But let's say when I'm going to make any changes in this repository and I want to commit those changes, to the remote repository, I will not be able to do that because this repository is not owned by me. Okay, this repository is not owned by me. So I want to create my own repository with all these code. I mean, whatever state we have of this repository, I want to create a repository with the same state. Okay, if you see here, the number of commits in this repository is 47,500. Okay. Okay, so let's say I want to create a clone of this repository in my GitHub account. Okay, so in GitHub, we have a feature of fork. Once you click here on fork, this repository will be created in your GitHub account. In my account, it seems it is already there. Okay, so now that repository is deleted. Okay, so again, coming back to forking. So let's say this is a repository which I want to create a fork of, or I want to create a replica of this repository in my account so I can commit changes. Okay, so here we'll click on fork. Then the repository name which you want to give in your account. Then create fork. So once you do that, once you create this fork, in your GitHub account, a repository will be created by this name. I mean, by that, by the source repository name. And whatever state is there in the public repository, I mean, in that GitHub account. Suppose in this GitHub account, there are 47,500 commits. So the same number of commits we will be getting in our GitHub account. Okay, the same number of commits we will be getting in our GitHub account. So here we have 47,500, the same number of commits we have. Here we have a lot of files and the same number of files we have here. Just the only difference is that in this account, I cannot commit my changes. When I will be making any changes in the code and when I will be pushing those changes, I will not be able to do that. But here, when I have forked this repository, I will be able to commit my changes in this repository. Okay, I will be able to commit the changes in this repository. So with the help of forking, we can replicate any public repository in any GitHub account in our account. With that, basically, we will be getting read-write access to that repository, but in our GitHub account. Not local copy, it is a copy in the GitHub account. I don't know what you mean by local copy. So it is a copy in account to account. So let's say in this account, we had the repository by the name WordPress. Now with the help of forking, in our account, we have created the same repository with the same state which this repository had. Okay, thus the difference is that here you cannot commit changes. But here, as it is now in your GitHub account, you can commit your changes. Okay, you can commit your changes. Plus, let's say if there are new commits added in this repository. Let's say when you cloned this repository, when you created the fork of this repository, let's say there were 47,500 commits. So when you fork this repository, in your account also there will be this number of commits. But let's say in future, there are new commits added in this repository. For example, now there are 48,000. So the new commits which are added or the new changes which are added in this repository will not be replicated to your repository. Okay, the new commits or the new changes which are added in account 1 will not be added to account B. But if you want, you can get those changes. If you see here, in our account, when we have forked the repository, you will see here one option of sync fork. Okay, you will see here an option of sync fork. With this option, if there are new commits added in this repository, in the source repository, then those new commits will be added to your repository as well, in case if you want to sync it. Okay, in case if you want to get new changes. So PHP, Rohit, is a programming language. Okay, PHP is a programming language. So this, I mean, just for example, I was taking WordPress. WordPress is a very popular content management system, which is used for creating blogs and website, and it is written in PHP. Okay. So suppose I want to contribute in this project, or I want to use this open source project to build my own product or my own, I would say, custom project. So in that case, I can fork this repository in my account. Okay, I can fork this repository in my GitHub account. Then I will be having commit access to that repository. As it is going to be in my repository now, then I can commit changes to this repository. So before starting with Docker, we will be talking about some fundamentals. We will be talking about what challenges we used to have before Docker and how Docker came in picture. Okay, we will be talking about what challenges which we used to have before Docker and how Docker came in picture. So before Docker, we used to run our application. So Docker is all about, I would say, running application. Okay, Docker is basically used for running applications. So before Docker, we used to run our applications in physical server. Okay, most of you may know about this, like as you have already learned AWS cloud computing. So before Docker, we used to run our applications in a physical server. So Shrikant, what is fast here? Can you tell me? See, even if it is fast, then also I'm repeating it the same thing twice and thrice. So if you're not able to catch, you should be able to catch in when I'm repeating the same thing 2-3 times. Okay, you are new. Okay, that is good. If you are new, everyone is new. Okay, so before Docker, we used to run our applications in physical servers. Okay. For example, let's say there are 3 applications. One application is written in Java 8. One application, let's say, is written in Java 11. One application is written in PHP, and this application is only compatible to run on Linux environment. Okay, application 1 is written in Java 8. Application 2 is written in Java 11, and application 3 is written in PHP and is only compatible to run on Linux server. Okay, so can anyone tell me, can we run multiple applications on the same server? Suppose, let's say I have a physical server, and on this physical server, I want to run multiple applications. Let's say I want to run these 2 applications, app 1 and app 2. Can we run multiple applications on the same server? No, we cannot run multiple applications on the same server. Okay, see, we can run it. I will not completely deny that we cannot run it. We can run it, but it may cause conflicts. Conflicts in terms of libraries, dependencies, right? And usually it's not a good practice to run multiple applications on the same server. Okay, multiple applications on the same server. Okay, so we cannot run multiple applications on the same server, even if we can. So it is usually not a good practice that we run multiple applications on the same server. So when we used to have physical servers to run our application, so in that case, for each application, we need one server. For each application, we need one physical server. Let's say this physical server for running application 1, this for running application 2, and this for running application 3. Okay. When I am saying physical server, this is basically the hardware. On top of the hardware, we have the operating system. Okay. On top of hardware, we have the host operating system. Host operating system can be any operating system. Let's say Linux or Windows. Okay, it can be any operating system, Windows or any Linux distribution. Then on top of the host operating system, we install runtime. What is runtime? Runtime is basically the programming language. Let's say Java, Java 8, Java 11, or whatever the programming language is. Okay. Then on top of that, we deploy the application code basically. Right. So before Docker, before the evolution of Docker, we used to run our applications, app1 code in physical servers. And for depending on the number of physical server, depending on that, we need number of physical servers. So for example, I want to deploy 3 applications. So I need 3 physical servers. Okay. If I want to deploy 100 applications, so I need 100 physical servers. Okay. And if I'm purchasing, for those 100 physical server, first I need to purchase those servers. Then I need dedicated IT professionals who will be taking care of those servers. Plus I need a dedicated space, dedicated room, dedicated land for keeping those servers. Right. So overall, this kind of architecture we used to have in a data center. Right, where we used to have physical servers, and in each server we used to run one application. So the first problem in this scenario is, or in case of physical server, is one server, one application. Sorry, not one server, one application, one server. Right, exactly, dedicated server. Then another challenge we have in this scenario is of wastage of resources, or the resources are not fully utilized. Okay, there are 2 challenges. One is one app in one server and wastage of resources. Now let us understand what is wastage of resources. So suppose my application 1 is running in this server, and the server configuration is this: 4-core CPU, 16 GB RAM. And my application is only consuming 2-core CPU and let's say 4 GB RAM. my application 1 is only consuming okay. So let's say my server has 4-core CPU, 16 GB RAM. Okay. And my application is only consuming 2-core CPU, 4 GB RAM. Okay. My application is only consuming 2-core CPU, 1 GB RAM, 2-core CPU, 4 GB RAM. This is the consumption by my application. Okay. So overall, if we if we talk about the overall usage, so some resources will be consumed by my operating system, by my host operating system. For example, my host operating system is taking 1 GB RAM. Okay, 1 GB RAM is taken by my host operating system. Then my application is consuming 4 GB RAM. Okay, application and runtime, let's say it's consuming 4 GB of RAM. Now, out of 16 GB of RAM, only 5 GB of RAM is utilized. Okay, out of 16 GB of RAM, only 5 GB is utilized, which means in the server, I still have 11 GB of RAM unused. Okay, in the server, I still have 11 GB of RAM unused. And these resources I cannot use for running another application. Okay, these resources I cannot use for running another application. So overall, there is basically wastage of resources. So in physical server, the resources are not fully utilized. Okay, we are not able to fully utilize these server resources. So right now we are talking in terms of RAM, but it could be in terms of CPU resources. It can also be in terms of storage resources. Suppose this server has a 1 terabyte of disk, and let's say 100 GB of disk is utilized by my host operating system, and let's say 20 GB is in use by my application. Then rest available storage is unused. Okay, so overall, in case of physical servers, we used to have wastage of resources. Okay, resources of the physical servers were not fully utilized. So when I'm saying resources, it means CPU, memory, disk usage, and network usage. Okay, so these resources were not fully utilized of the physical server. Now, to solve this problem, we have a concept of virtualization. Okay, we have a concept of virtualization. With the help of virtualization, the challenges which we used to have in physical server were solved. So in case of physical server, we had these two challenges. One was one app, one server. Okay, one app, one server, and wastage of resources. Right now, with the help of virtualization, the problems were solved. So in case of virtualization, also we have a physical server. Okay, but this physical server will be of higher configuration. Higher configuration in terms of resources. Okay, let's say it will be having 16-core CPU and 64 GB RAM. Okay, so on top of this hardware, we will be having a host operating system. The host operating system could be Windows or Linux. Then on top of this host operating system, we will be installing a software which is hypervisor. Okay, we will be installing a software which is hypervisor. So with the help of hypervisor, hypervisor is a software which is used to create a virtualization environment. Or hypervisor is used to convert physical hardware resources to virtual hardware resources. Then with the help of this hypervisor, we create virtual servers. Okay, we create virtual servers. And these virtual servers will be having their own hardware configuration. Okay, they will be having their own hardware config. They will be having their own operating system. Okay, so overall, these servers will be virtual servers. Or in other words, we also call it as virtual machines. There are multiple terms actually we use, like we call it virtual servers, we call it as virtual machines, we call them as guest OS. Right. So let's say in this case, I have a physical server with higher configuration. And let's say my use case is that I want to deploy the same 3 applications. Okay, I want to deploy the same 3 applications. App 1, which is written in Java 8, App 2, which is written in Java 11, and App 3, which is written in PHP, and this requires Linux server. Okay, for example, application 3 requires a Linux environment. So before virtualization, to deploy these 3 applications, we required 3 servers. We required 3 physical servers. Right? But with the help of virtualization, with a single server, with a single big server, we can, on the physical server, we can install hypervisor, which basically provides a virtualization environment with which we can create virtual machines. So we can create virtual machines. Okay, virtual machine 1 for application 1. And when we will be creating these virtual machine, we will be defining what operating system we need. Let's say I want Windows 7 operating system for application 1. So we will be defining the operating system. We will be defining the resources. Resources in the sense like CPU, like 2-core CPU, 4 GB RAM, or depending on whatever resources that application needs. Plus, we will be defining storage. Let's say I want this server with 50 GB. Then for second application, App 2, let's say App 2 is compatible to only run on Windows 10 environment. So I can, in this virtual machine 2, I can install Windows 10. Then let's say App 2 requires 4-core CPU and 8 GB RAM. And storage, let's say it needs 100 GB. So when we will be creating this virtual machine, at that time, basically, we will be asked for the operating system, resource configuration, like CPU memory, and the storage configuration. And each of these virtual machines will be isolated to each other. Isolated to each other and isolated to the host operating system. Okay, they will be having their own set of resources. They will be having their own operating system. Now, let's say I have my third requirement of running third application on a Linux server. So here the operating system I want is Linux. And let's say the application requirement is 2-core CPU, 4 GB RAM. And storage requirement is 40 GB. So with the help of virtualization, I will be able to create multiple servers. Okay, I will be able to create multiple virtual servers, and I will be able to deploy multiple applications on the same physical server. Right? In case of virtualization, we only have one physical server. And on the same physical server, we are installing a hypervisor. And with the hypervisor, we are creating virtual servers. And these virtual servers have their own hardware and software configuration. But in this case, in case of physical server, we need, for each application, we need physical servers. Plus, the resources of the physical servers were not fully utilized. But in this case, suppose let's say my physical server has 64 GB RAM. Okay, my physical server has 64 GB RAM. 1 GB, let's say, is utilized by my host operating system. Then let's say 4 GB is utilized by my application 1 VM. Application 2 VM, let's say, is consuming 8 GB RAM. Application 3 VM is consuming 4 GB RAM. Okay, so in this case also, I have still available resources. For example, in total, let's say all my, the overall consumption of my physical server is, let's say 1 GB RAM for the host operating system, 1 GB RAM by the application 1, sorry, 4 GB RAM by application 1, 8 GB RAM by application 2, and again 4 GB RAM by application 3. So the total consumption here is 17 GB. So from my physical server, my current usage is only 17 GB. Okay, which means somewhere around, which means around 47 GB of RAM we still have free. Okay, we have 47 GB of unused RAM. But in this case, suppose in future I have some other requirement. I want to deploy more applications. So I can use this unused resources to create another virtual machine. Okay, I can use these unused resources to create another virtual machines. Or suppose in future, these servers require more hardware resources. Suppose in future, let's say from 4 GB, application 1 requires, let's say from 4 GB, it requires 8 GB of RAM. So I can use the physical server's unused resources to allocate to my existing virtual machines, or I can create new virtual machines out of it. So with the help of virtualization, I'm able to solve both of these problems. Right? Before virtualization, for each application, we need physical server. But with virtualization, we only need one physical server. One physical server, and top of that physical server, we create virtual machines. Plus, in this case, if the resources are not utilized, so I cannot deploy other applications on this server. So these resources were unused. In this case also, these resources are unused, but I can use it in future to scale my existing virtual machines, or I can use it for creating new virtual machines, by which I will be able to utilize these physical resources. Right? So the problem which we used to have with physical servers, those problems were solved through virtualization. But still, there is one challenge in virtualization, which was of wastage of resources. Okay, which was of wastage of resources. Why wastage of resources? Because at the server level, at the virtual machine level, on top of the EC2 instance, let's say I have installed a container engine. Okay, let's say I have installed Docker. Now, once we install Docker in a server, so once Docker is installed, then we start calling that server as a Docker host. Okay, this is just a terminology in Docker. The server where Docker is installed, that server we call it as a Docker host. Okay, that server we call it as a Docker host. Now in this Docker host, to create a container, we need a container image. Right? To create a container, we need a container image. So on this host, on this Docker host, we have to download the image, which is called pulling the image. Okay. We have to pull the image from the image registry in order to create a Docker container. Okay. So in the image registry, we will be having the container images. And in order to spin up a container in my Docker host, I need to first pull the image. Once I have pulled the image, then with the help of the Docker command, I will be able to spin up a container. Okay. Now, depending on my use case, there will be different types of images available in the image registry. Okay. So one of the popular image registry in Docker we have is Docker Hub. Okay. This is the most popular image registry. Apart from Docker Hub, there are a lot of image registry available in the market. So these are some of the most popular image registries. Okay, I would say these are the public image registry. Okay, which is accessible to anyone on the internet. Anyone can basically download images from these image registry. What is Docker Hub? Docker Hub is the image registry. And in an image registry, we have container images. Now here in Docker Hub, we can search for a container image. Depending on our use case, we will find here container images. So let's say I want to deploy a container of Ubuntu. Okay, I need to deploy a container of Ubuntu. So here we can search for that. Here we can search for the image for Ubuntu. Yeah, so here you can see there is an image available for Ubuntu. Just like in AWS, while creating the EC2 instance, let's say I want to create an EC2 instance of Ubuntu. So what we do? We need a AMI of Ubuntu, right? Without AMI, we cannot launch a EC2 instance. Similarly, without the container image, we cannot deploy a container. Right? So here you can see we have an image for Ubuntu. Okay. Now, in order to use this image of Ubuntu, I need to run this command docker pull Ubuntu in my Docker host. And what is Docker host? Docker host is the host where we have the container engine installed. In any Linux server or in any Windows server, once you install Docker, okay, so that server now we can call it as Docker host. Right? So in order to use this Docker image to create the Docker container, first we need to pull the image. And here we have the command docker pull Ubuntu. With this command, this Ubuntu image will be downloaded in our Docker host. And later we can use this image to deploy a container. Yeah, all the container images are free. We are not charged for using the container images. No, we don't have to define any additional configuration on the Docker host. By default, your Docker host will be connected to the Docker Hub image registry. Okay, once you install Docker, so by default, Docker will be connected to your to the Docker Hub image registry, which is this. So when you will be running docker pull command, so your Docker image will be downloaded from the Docker Hub. Okay, it will be downloaded from Docker Hub. Now we don't have to define any hardware configuration like the RAM configuration, CPU configuration. We can define that also, but usually, I mean, at the time of deploying the container, we can define those configuration like how much CPU we want to assign to the container and the memory we want to assign to the container. But if we do not specify those, those configuration, so by default, the container will be using all the resources which are available on the Docker host. Okay. So for example, let's say I have deployed this container. So this container will be using all the resources which are available to my host operating system. So let's say on my host operating system, I have 2-core CPU and 4 GB RAM. So my container will be using all the resources. Okay, my container will be using all the resources. It will be using 2-core CPU and 4 GB RAM. But depending on our use case, at the time of deploying the container, we can, I would say, set a threshold, or we can set a limit for the resource usage for the container. Yeah. So here on Docker Hub, we can find any container image. Now, container images are categorized basically in 2 types. Okay, just like in AWS, we have AMIs, right? Just like in AWS, we have AMIs. Now, these AMIs are of 2 types, majorly of 2 types. One AMI is the base AMI, and one AMI is the one AMI is the app AMI. In base AMI only comes with the operating system. Okay, base AMI only comes with the operating system, whereas app AMI comes with the operating system as well as with the application. Okay, base AMI only comes with the operating system. App AMI comes with the operating system as well as with the application. Right. For example, like we have Ubuntu, we have Red Hat, we have Windows, right? At the time of launching the EC2 instance, we choose an AMI, right? So these AMIs, where we only have the operating system, these AMIs are called base AMIs, right? And app AMIs, like in AWS Marketplace, we can find app AMIs. So for example, we have AMI of WordPress, which is basically an application. We have AMI of MySQL, which is basically a database, right? We have AMI for, let's say, Django, okay, which is again an application, right? So with the help of app AMI, so let's say I'm using this app AMI to launch an EC2 instance. So when my EC2 instance will be deployed, it will have the operating system as well as it will have the application, right? Similarly, in Docker also, in our container images are categorized in 2 types. One is base image and one is app image. In base image, we only have the operating system. Okay, we only have the operating system. And in app image, we have the operating system as well as our application. Okay, we have the operating system as well as the application. Okay, so right now the image we saw here, like we discussed here, was Ubuntu. So that Ubuntu image is the operating system image. Okay, so if I'm going to deploy a container with this Docker image, it will only come with the operating system, Ubuntu. Okay, similarly, we can find base images for different operating systems. Let's say CentOS, it will come only with the operating system. Debian again is a Linux distribution. So if I'm going to use this container image to deploy the deploy a container, that container will only come with the operating system. Right? Just like in EC2, whatever state we have of the container, we have of the AMI, the same state we have in our EC2 instance. Right? For example, let's say I'm launching a EC2 instance of Ubuntu. And if I'm using base AMI as Ubuntu, so whatever state I have of the base AMI, the same state will be in my EC2 instance. So let's say in my AMI, I've chosen Ubuntu as the operating system. So in my EC2 instance also, I will get the Ubuntu operating system. Right? Same way, in case of containers, we create a container. We create a container with a container image. Okay, so let's say I'm creating a container of Ubuntu. So I need a base image of Ubuntu. And when I will be spinning a container with this container image, the container will be having the Ubuntu operating system. Okay, it will be having the Ubuntu operating system. So Sarnaya, there is, without creating a Docker Hub account, we can still use the container images. Right. Full images like downloading the operating system and app to the container. That is correct. Okay. So base images are the operating system images, which only have the operating system. Okay, which only have the operating system. We can also call them as OS images. All right. So base images only have the operating system, whereas the application images have the operating system and the application also already installed. Right. So for example, for application images, like we have MySQL. So let's say I want to deploy a container which should have the operating system and which should have this software MySQL already installed. Okay, so we have a container image available for MySQL. We have a container image available for MariaDB. MariaDB is also a database. Okay. Let's say I want to deploy a container image with MongoDB. MongoDB is a NoSQL database. So when I will be using this container image to deploy a container, so that container will have the operating system as well as MongoDB already installed. Okay, let's say WordPress. Okay, WordPress is a very popular CMS, I would say, CMS system. Okay, which is basically a web application, okay, with which a lot of companies basically use WordPress for developing blogs and websites. Okay. So let's say when I'm going to use this image to deploy a container, so that container will come with this WordPress application already installed. It will come with the operating system as well as it will come with the application WordPress already installed. Okay, we can find images for Apache. Apache is what? Apache is a web server software. Okay. So here in Docker Hub, we have the image by the name httpd. We can deploy Tomcat. Tomcat is basically a web server for hosting, I would say, Java-based web applications. Then we have Nginx. Nginx is also a web server. So we have a Docker image for Nginx. So if I'm going to deploy a container with this Docker image, Nginx, so it will come with the operating system as well as it will come with Nginx already installed. Right. So depending on our use case, we use these images. Right. Let's say my use case is that I want to deploy a container with MySQL database. So I can simply go with application images, which will come with that application or the software already installed. Right. And if the application image is not available, in that case, we will go with the base image. We will go with the base image and then we will be manually installing that application. Right. So for example, for base image, we have Ubuntu, we have CentOS, we have Amazon Linux. Okay. All the Linux-based distributions. Okay, like Red Hat, Fedora, Oracle Linux. Okay, so for all the Linux-based distributions, we have base images available. Okay, then application image depends upon the application. So like for MySQL, we have an image. For Nginx, we have an image. For Apache, we have an image. Okay. For MongoDB, we have an image. For WordPress, we have an image. Okay. So depending on the application, we have a lot of, I would say, application images available. Okay, all the popular, I would say, applications are available in Docker Hub in the form of application image. Okay. So the application image will come with operating system and application already installed. So for example, when I'm going to deploy an Nginx container with this image. So my container will come with operating system as well as it will come with the Nginx software already installed. Okay, just like in case of AMIs. Suppose I am deploying an EC2 instance with MySQL AMI or WordPress AMI. So that EC2 instance will come with the operating system and it will also come with the application. Operating system can be anything, let's say Ubuntu, and the application depending on whatever application I'm deploying. Let's say I'm deploying MySQL. Let's say I've chosen MySQL AMI. So in my EC2 instance, I will get the operating system as well as.
In Ansible, what is the purpose of an inventory file and how is it used in the configuration management process? Option A, it stores sensitive information like passwords and API keys. Option B, it defines the desired state of the system. Option C, it specifies the list of hosts and their connection details. Or option D, it contains the playbook, logic, and task. Comment down your answer below in the comment section. Just a quick info guys, Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Yes, the MySQL database already installed. Same way, in case of Docker containers. So when we will be deploying a container, let's say with MySQL image, it will come with the operating system as well as it will come with It will come with the database software MySQL already installed. So Priya, we don't install operating systems. Just like in AWS when we are working with AMIs. So in AWS, do we install operating system? In AWS, we use operating system images, OS images to deploy EC2 instances. Same is applicable in case of containerization also. In containerization, we do not do any operating system installation. We use container images. These container images have the operating system already installed and configured, just like AMIs. Like AMIs have the operating system already installed and the operating system already configured. Same way, container images also have operating system already installed and configured. Quay.io. So this is our image registry, which is, I would say, managed by Red Hat. And Docker is basically a company. Okay, Docker is a company. So this Docker Hub is managed by Docker. Okay, this Docker Hub image registry is managed by Docker. Similarly, we have this image registry Q.io. This image registry is managed by Red Hat. Okay, Red Hat is a company and Red Hat manages this image registry Q.io. Same like Docker Hub, here also we can find container images. Okay, like here we can search at the right top, we can search for container images. Okay, but this is not as much, I would say, user friendly as we have Docker Hub. Docker Hub is more user friendly. Yeah, you can find container images. Yeah, and you can also find the pull commands. To pull this container image from this image registry Q.io, you need to run this command in your Docker host. Yes, both are basically image registries. Okay, both are image registries managed by different providers. So this Q.io is managed by Red Hat and Docker Hub is managed by Docker. Okay, and both are public image registries, which means anyone can pull images, container images from these image registries. Okay, anyone on the internet can pull Docker images from these image registries. In our course, we will be working with Docker Hub just to give you an understanding about different image registry. That's why basically we are talking about this. Apart from Docker Hub, Q.io, there are a lot of image registries available. Okay. Image registries are also of two types. One is public image registry. So for example, for public image registry, we have Docker Hub, Q.io. Both the image registries which we just saw are public image registry. Okay, both are public image registry, which means anyone on the internet can download images from these image registries. For private image registries, like we can set up our own private image registry. Okay, apart from that, AWS provides ECR, Elastic Container Registry. That is again a private repository, private image registry. Okay, so in AWS, we can create our own image registry where we can store our own container images. Okay, we can also create container images and we can also, I would say, publish them in an image registry. Okay, we can also publish them on Docker Hub, as well as we can also create our own private image registry. Okay, so we can set up it on AWS. We can also set up it on Azure. Okay, Azure also have Azure Container Image. Okay, they have their own service for setting up an image registry. where we can publish our own container images. All right, now let us get started with Docker. Now, as we understand the life cycle of Docker. Okay. So to create a Docker container, first on our server, we need to install a container engine. Okay. So let's say we need to install Docker. Then in order to create a container, we need a container image. To create a container, we need a container image. And these container images we can find on a image registry. So depending on our use case, first we need to find a container image in the image registry. Then we need to pull the container image in our Docker host. And then with that container image, we will be able to deploy a container. Okay. So these images are free. Okay, we are not charged for the Docker images. So Priya, I have been, multiple times I have been saying Docker host means the EC2 instance or the Linux server where Docker is installed. In any server where you have Docker installed, in Docker terminology, we call it as Docker host. So in your laptop, if you install Docker, then you can, based on Docker terminology, you can call your laptop as a Docker host. So in any server or any operating system where you have Docker installed, that that machine in Docker terminology, we call it as Docker host. But in general, you can call it as a Linux server also. That is just a terminology which is used in Docker. And these container images which are available in these public image registries are completely free. We are not charged for using them. All right, now let's deploy a EC2 instance. And in that EC2 instance, we will be installing Docker. Which in our AWS account, we will be launching one EC2 instance. And we will be using Ubuntu as the operating system. Okay, so name of the instance, I'm keeping it as Docker host. Then operating system here, I'm choosing Ubuntu. Then instance type, we will go with t2.micro. And we will create a key pair. Or if you already have a key pair, you can use existing key pair. I'm going to create a new key. And storage, we will increase it to 20 GB so that we do not run out of storage. So the instance configuration is that I'm giving it a name, Docker host. AMI, we are choosing Ubuntu. Instance type is t2.micro. This is the key. I've created a new key. You can use, if you already have an existing key, you can also use your existing key. And storage, I'm setting it as 20 GB. Now, launch instance. Very good, Sandesh. So just like you install the software in your Windows laptop, okay, you are asking a good question. I think I have mentioned this in our Git session also. Okay, so all these tools, as we have already discussed, all these tools we will be, or I would say the hands-on of all these tools we will be doing on top of AWS. And in AWS, we are going to use Linux as the base operating system. Okay, Linux, or I would say Ubuntu. Okay, and when you will be working in an organization, you will be also working with Linux. Rarely you will be working with Windows. Okay, first of all, make this clear to you that I'm making this clear to you that first of all, when you will be working in an organization, you will be rarely using Windows. Okay, Windows you will be using in case if there is a traditional application which is only compatible with Windows environment. For example, .NET application, which can only run in a Windows environment. Okay, so in such cases, you will be using Windows. Plus, Windows comes with a license, with a very expensive license. So usually companies do not prefer using Windows, but still you may find a few organizations using Windows, which are running some traditional applications, which are only compatible with the Windows environment. Then, yeah, so all these tools which we are learning, all these tools you can install in Windows as well. Okay, so Git, I have already shared with you how to install Git in Windows. If not, then you just need to go to download Git. This is the site. This is, I think, already shared in the doc file, which we have been following. Yeah, so in this site, you can find installation depending on whatever operating system you have. Mac OS, Windows, Linux. For all the operating systems, you have installation guide available on this site. Now Docker. Now let's talk about Docker. So Docker provides a solution which is called Docker Desktop. Okay, or you can simply Google download Docker. Yeah. So you can get Docker for Linux, Windows, and Apple. Okay. You can install it in any operating system platform. Suppose in your laptop you have Windows, you can install it in Windows. Suppose in your organization you are using Windows Server, so you can install it in a Windows Server. Okay. In our case, just to keep the platform similar for everyone, and just as I would say in the industry, we use Linux. Okay, so that's why we are doing all our hands-on on Linux. Okay, but you can install these softwares in a Windows system as well. Thinking that apt update will install new packages or will update the operating system or update the existing packages which are installed in the operating system. So you are wrong. Apt update command will update the package indexes or the information of the packages which are available in the remote repository. It will create a cache of the information of the packages in the operating system. So before installing any package, okay, this I would say a Linux lesson. So before installing any package in Linux, or I would say in Debian-based Linux distribution, for example, Ubuntu Debian, and we have Kali Linux and other Linux distributions. So before installing any package, we need to run apt update -1. Without running this command, we will not be able to install the packages. Suppose before running this command apt update -y, if I'm just running any command, like if I'm trying to install any package, for example, apt install Git or apt install Docker, so that command will fail. So the very first thing before installing any packages, we have to run apt update -y. What does this -y does? If we will not use -y, then it will prompt for user inputs, which will be, it will be asking whether you want to update. It will ask you for user prompt. Yes or no. Okay, so with why we are automating that. Okay, so with this command, Docker is now installed in our EC2 instance. After installing Docker, we will run this command: sudo systemctl start Docker and sudo systemctl enable Docker. So this command we are running in order to start the service of Docker. And this command we are running to enable the service of Docker on boot. Okay, so with this command, the service of Docker will be started in the runtime. I mean, when the server is running, at that time the service will be started. With this command, sudo systemctl enable Docker, when we will be rebooting the server, okay, or when we are going to restart the server, at that time the service of Docker will be started. Else, suppose if we don't run this command, so when we are going to perform a reboot, so when the server will be in running state, the server may not have Docker service running. And in that case, we have to manually start it. So just in order to make it running on boot, we are running this command systemctl enable Docker. So Git is not basically a service. Okay, Git is just a CLI tool. Okay, in Git, basically, we don't need to do this because we are basically using the Git client. Okay, there we don't have any daemon. Yes, it's a one-time command, systemctl enable. We just need to run once. After that, to verify the installation, you can run docker info command. Sudo docker info. Okay, so in the output of this command, you will be able to see the version of Docker and other information related to Docker, like how many containers which you have, how many number of containers you have on the host, how many containers are running, paused, stopped, the number of images you have, operating system related information. Right. So if you are able to run this command docker info, it confirms that Docker is successfully installed. Okay. Right now, to run any Docker command, let's say in Docker, we have a command docker ps. Docker ps command is basically used to see all the running containers. Okay, so if right now, if I run this docker ps command, I'm getting a permission denied error. But if I run this command with sudo, I will be able to execute this command. But without sudo, I'm getting a permission denied error. Okay, the user currently which I'm logged in with in the EC2 instance is Ubuntu. Okay, in Linux, we have this command whoami. With whoami command, we will be able to see that on the EC2 instance with which user we are currently logged in with. So currently in the EC2 instance, we are logged in with Ubuntu user. Now with Ubuntu user, when I am running the docker command, I'm getting permission denied. But when I'm using sudo, I'm able to run the docker command. Right. So when you will be working in an organization, you may not have access to sudo. Okay, when you will be working in an organization, you may not have access to sudo. Right now, let's say I want to make this user, this system user Ubuntu, to manage Docker, or I want this user to use the Docker commands without requiring sudo privileges. Okay, so when we install Docker in our EC2 instance, okay, so after Docker is installed in our EC2 instance, a group is created. Okay, a group is created by the name Docker. Okay, after we install Docker in our EC2 instance, a group is created by the name Docker. Okay, this is actually a concept of operating system In operating systems, we have users and groups. Okay. For example, Ubuntu. Ubuntu is a user. EC2 user is a user. Root is a user with which we can log into the Linux operating system. Okay, and this is something which is also applicable for Windows also. I'm not just talking about Linux. In Windows also we have users. For example, when you log into your laptop, so you log into your laptop by a user, right? You log into your laptop by a user. Same way in Linux also, we log in to our server by a user. So right now to this server, to this EC2 instance, I'm connected with Ubuntu. Right. Same way, we have groups. Okay. Similarly, we have groups in the server. Okay, just like if you remember in AWS, you may have learned about IAM groups. Right? In IAM, we create a group, and in that group we add IAM users. Right? If you remember, in IAM, we used to create IAM groups, and in that IAM groups, we used to add IAM users. Right? Same is applicable here. In the operating system also, we create groups and we add users to the group. Okay, we add these users to a group. Just like in AWS, we created a IAM group. For example, let's say admin. Then later to this admin group, we add our IAM users. For example, John, Adam, Harry, let's say these are all IAM users. So we add these IAM users to a IAM group. Same thing is applicable in operating system also. In operating systems also, we have groups. Okay, and we add these users to the group. Okay. And when we add these users to the group, the user gets special privileges. Okay, the users get special privileges. For example, in IAM groups. Okay, suppose in IAM group, let's say you have attached a IAM policy of admin access. Okay, as you guys are familiar with AWS, that's why I'm taking an example of AWS to understand, to give you an understanding of this concept. Okay, so in IAM groups, first we create a group and then we attach a IAM policy. Right, so let's say in AWS, I have created an admin group, and in that admin group, I have attached administrative access IAM policy. Then whatever users I'm going to add in this group admin. Okay, so the privileges which I have assigned to this admin group, let's say the administrative IAM policy. So whatever access we have assigned to this admin group, the same access will be granted to these IAM users. Okay, whatever access we have defined to this IAM group admin, the same access will be, I would say, granted to these IAM users, which belongs to this group. Okay, let us understand it in this way. So we have group and we have users. On groups, we have special permission. Okay, by default on group, there is no special permission. We have to add special permission. But for now, just understand it in this way. That's on group, we have special permission. And then when we add a group, when we add a user to the group, the user gets the special permission which is applied on the group. Okay, the users who will be part of this group will get the special permission which this group has. Right, just like in AWS, we create a admin IAM group, and then to that admin IAM group, we attach a IAM policy. And then when we add users to that admin group, IAM users to the admin group, the users which belongs to that group will gain the access or gain the privileges which the admin group has. Right. So same is applicable here in Docker. So when we install Docker in our EC2 instance or in our Linux server, a group is created by the name Docker. When we install Docker in our EC2 instance, a group is created in our EC2 instance by the name Docker. Okay, and this group has special permissions. Okay, this group has special permission. The special permission is that any user which I will add in this group, any user which we will add in this group will be able to run the Docker commands. Okay, or in general, any user which I'm going to add in this Docker group will be able to manage Docker. Okay, any user which I will be adding in this group will be able to manage Docker. Okay, so in my operating system, in my Linux operating system, right now I have Ubuntu user. Now I want this Ubuntu user to manage Docker. Okay, I want this Ubuntu user to manage Docker. So in order to give these privileges to this Ubuntu user, I can add this Ubuntu user to Docker group. I can add this Ubuntu user to Docker group. Now, once I add this Ubuntu user to Docker group, the user will be able to manage Docker. Okay. Once I add this Ubuntu user to the Docker group, the user will be able to manage Docker. Okay. So right now, here you can see I'm logged in with this user Ubuntu. And when I'm running Docker command, I'm getting permission denied. Right now, let us add this Ubuntu user in Docker group. Okay, so to see the groups in the operating system, we have one file, cat etc group. Okay, etc group is a file which is present inside the etc directory, and in this file we have the list of groups which are available in the operating system. So here you can see there is a group by the name Docker, and this group is added by the Docker installation. So when we ran this apt install docker command, apt install docker.io command, at that time the group was added in our operating system. At that time this group was created. Actually, in the output of the installation log also we will be able to see that group addition. Right now, yeah, so overall when we ran the apt install docker.io command, at that time this group was added in the operating system. Okay, now this group has special privileges. The special privileges this group has is that when we will be adding any user to this Docker group, the user will be able to manage the Docker commands. Right. To add a user to this group, we need to use the user mode command, user mode, and then the username, then -G, and then the group name. The command is user mode, then the username, and then the group name. So let's say I want to give this, I want to add this Ubuntu user to Docker group. So to do that, we need to use this command. Once you do that, to verify whether this Ubuntu user is added to the Docker group or not, you can run ID Ubuntu, ID and then the username. So here you can see in the Ubuntu user, here you can see in groups, we are able to see Docker group. Earlier, this Docker group was not there. Okay, earlier the Docker group was not there. So here we are using -G to specify the group name. Okay, there is actually multiple meanings of -G, I mean, in Linux, we have a concept of primary group, secondary group. Okay, so we'll not go in depth on that. That is actually Linux administration. Okay, so for now, with -G, we are adding the Ubuntu user in the Docker group. Okay. So when we run id Ubuntu command, id and the username, we are able to see that in groups of this Ubuntu user, we are able to see the Docker group. After doing this, you have to log out from the EC2 instance and log in again. Sorry. Now, if we run the Docker command, now we are able to run the Docker command successfully. Yes, you can use that command also. Okay, so now when we are running the Docker command, we are able to get the output. Earlier, if you remember, when we were running the Docker command with Ubuntu user, we were getting a permission denied error, right? We were getting a permission denied error, but now we are not getting any permission denied error. We are able to run the Docker command without sudo, right? Earlier, if you remember, we were getting permission denied error when we were running this command. Now, without sudo, we are able to run this command without any errors. And this is all because we added this Ubuntu user to the Docker group. And this Docker group had special permissions. And the special permission was that any user which will be added to this group will be able to manage Docker. Yeah, hub.docker.com. And here we have to search for the image. Okay, it could be any operating system, it could be any application. Okay, so first we have to go to Docker Hub and we have to search for the image. So let's say my use case is that I want to deploy a Ubuntu container. So I need a Ubuntu image. Okay, so we went to Docker Hub and here we search for Ubuntu. And we found a container image for Ubuntu. Now, in order to use this image, first we need to download this image to our Docker host. Okay, in order to use this image, we need to download this image to our Docker host. To do that, we will be using this command, docker pull, and then the image name. Okay, to pull an image from the image registry, we need to use this command, docker pull, and then the image name. So in our EC2 instance, we will run this command, docker pull, and then the image name. So once we run this command, the image of Ubuntu will be downloaded in our Docker host. Okay, the image will be downloaded in our Docker host. If we visualize this, so what currently we have done is, so let's say we have an image registry, which is in our case Docker Hub, and in our Docker Hub we have an image which is Ubuntu. Okay, now we have a EC2 instance, and in this EC2 instance we have installed Docker. And as we have installed Docker in this EC2 instance, we can also call this EC2 instance as Docker host. Right. Now let's say I wanted to deploy a Docker container. So I went to Docker Hub and I found a container image for Ubuntu. Now, in order to use this container image to deploy container, first I need to download this image. To download the image, we have to run docker pull and then the image. Okay, So in our case, we wanted to pull, we wanted to deploy a container of Ubuntu. So we are pulling the image of Ubuntu. Now, once we run this docker pull Ubuntu command, the image which is available in our image registry will be downloaded in our EC2 instance, in our Docker host. Okay, with this command, the image which is available in the image registry is now downloaded in our Docker host. Now, to see this image which is downloaded in our EC2 instance, we have one command, docker image ls. With this command, we will be able to see the images which are available in our Docker host. So right now we are able to see one image, which is Ubuntu. Okay, we are able to see one image, which is Ubuntu. Okay, so when we pull an image from the Docker, from the image registry, so with this command, we will be able to see all the images which are available in our Docker host. Now let us first understand the command output, then we will move further ahead. So when we are running docker image ls command in the Docker host, so when we are running the docker image ls command, we are able to see an image, right? We are basically getting this output, right? We are getting this output. Right. So in this output, the first part, let me take it in black. The first part, this part is the image name. Okay, this part is the image name. Then we have image tag. Then we have something called image tag. You can call it as image tag or image version. Okay, image tag or image version. So right now in our case, it is showing latest, which means we have downloaded the latest version of this image. Okay, it means we have downloaded the latest version of this image. For example, in operating system, we have different versions. For example, if we take an example of Windows, so the latest version of Windows available is Windows 11. Okay, which is the latest version of Windows. But we have other versions also, like we have Windows 10, Windows 8, Windows 7, and other versions. Right. So right now, in this command, in this command output, we are able to see the tag as latest. It means that the latest version of this image is currently downloaded in our Docker host. Okay, but let's say we want to download a specific version based on the image. Let's say we want to download a specific version. Suppose I want to download, right now we have downloaded Ubuntu latest image. Now let's say I want to download Ubuntu 20. Right now the latest version of Ubuntu is 23. Okay, let's say I want to download Ubuntu 22, or I want to download Ubuntu 20. Okay, in Ubuntu also we have versions. Okay, in Ubuntu we have version based on years. Every year basically Ubuntu launches a new version. Okay, or let's say I want Ubuntu 21 or Ubuntu 20. Right. So in our Docker Hub, here you can see image Ubuntu And if you see here, we have a section of tags. Okay, we have a section of tags. So right now, when we ran the Docker pull command, this image was downloaded, which is the latest version currently of Ubuntu. Then we have different tags available. Okay, Lunar is a version. I mean, the latest release of Ubuntu, I mean, they have named it as Lunar. Yeah, then we have on version basis also 23.04, 22.04. Okay, Focal is again a name of an Ubuntu release. 22.10, 20.01, 20.01. Bionic again is a release name, 18.04. Right. So we have different versions available of this image. Just like same is applicable for our EC2 instance also. Like for the AMIs also, right? While launching the EC2 instance, we choose an AMI, right? We choose an AMI. And by default, the AMI is of latest operating system. If I choose here Ubuntu, so Ubuntu currently it is showing 22. Maybe in AWS, they only have this version as the latest, but here you can find different versions of Ubuntu available. 22, 20, okay, and other versions for Ubuntu. Okay. So when we run the Docker pull command, Docker pull and the image name. So by default, the latest available version of the image is downloaded. Okay. When we run the Docker pull image command, by default, the latest version of the image is downloaded. Okay. I'll add it in another sheet. By default, when we run the Docker pull command, Docker pull and the image name command, the latest version of the image is downloaded. Okay, version I am just using just for ease of understanding, but in Docker terminology, we call it as tag. Okay, so when we pull a image, when we run this Docker pull image command, the latest tag of the image is downloaded. Okay, which is, I would say, the latest available version of that image. Okay, so when we run this command, Docker pull Ubuntu, so the latest version of Ubuntu image is downloaded. Now, let's say I want to download a specific version. Okay, I want to download a specific version. So first of all, that specific version should be available on the image registry. Let's say I want to install Ubuntu 18. I mean, I need a Ubuntu image with Ubuntu 18 as the operating system. So first of all, I have to go to tags. I have to go to, first of all, that particular image. Then I have to go to tags. Then I need to search for the version, whether that particular version is available or not. If that version is available, then I can use that particular version. Okay, but if the version is not available, then I will not be able to use it, or I will not be able to pull it. Right? For example, here in AWS, we don't have the latest version of Ubuntu. Let's say Ubuntu Server 23. So if it is not available, then I cannot deploy a EC2 instance of Ubuntu 23. Right? If it is not available, then I cannot deploy a EC2 instance with Ubuntu Server 23 version. Right? So same is applicable here. If the version, I mean, if the tag is not available, then we cannot deploy or we cannot pull an image of that particular version. Okay. So if the version is available, then to pull it, you can run this command, docker pull image name, then image tag. Okay, image tag, or you can call it as image version. So suppose let's say I want to get the let's say this version of Ubuntu 18.04. Okay, so I can run this command docker pull Ubuntu and then the image version, sorry, image tag. Okay, and in Docker Hub we have this image tag available. Okay, so to pull the image, we can run this command docker pull Ubuntu, then the image name and then the version of the image. Yeah, now you can see it is now pulling Ubuntu image of this tag. Now once it is pulled, now if we run docker image ls, so you can see we are able to see the image and the version or the tag of the image is this. Right? So now when I will be deploying a container with this image, so the operating system of Ubuntu which I will be getting is 18.04. When I am going to deploy a container with this image, Ubuntu, which has the latest tag, so I will get the latest version of Ubuntu, let's say, which is Ubuntu 23. Yes, it is possible to download image from other repository other than Docker Hub as well. So you can go to this site, for example, whatever the image registry is. Let's say I want to download image from this image registry. So let's say I want to download image of Ubuntu. Yeah, so let's say there is an image available. So here you can find the command to download the Docker image from this image registry, query.io. By default, it will be downloading from Docker. By default, your Docker daemon is connected with Docker Hub. So you don't have to explicitly specify the image registry information. Okay. But if you want to download it from some third party, like let's say from this image registry, then you have to explicitly specify information of the image registry. All right, now let's move forward. Now we understand the output of Docker image ls. All right, now let us deploy a container. Okay. So to deploy a container, we will use this command docker run -it, then -- name, container name, image name, and a command. First, let us understand this command, then we will execute it. Okay, so to deploy a container, I am running this command. Now in this command, I am specifying this switch IT. And one is this switch -- name. And we are passing something this, and we are passing something this. Okay. So IT stands here is for interactive terminal. Okay, it stands for interactive terminal. So let's say I want to deploy a container and I want to, at the time of deploying the container, I also want to log into the container. Okay, I want to deploy a container and at the time of deploying the container itself, I want to log into the container. So in that case, we will be using this switch -it. Then we are using -- name. This is used to specify the container name. And this is optional. Okay, this is option. If we do not specify a container name, then also it will work. Okay, but in that case, it will assign a random container name. Then we are passing here image name, from which image I want to create the container. Okay, from which image I want to create the container. Then we are passing bash. Bash is nothing but the command. Okay, in bash basically we are specifying. I mean, after the image name, we are specifying a command which we want to execute when the container will be deployed. Okay, so after the image name, we specify a command which should be executed at the time of container deployment. Okay, then image name is like the Docker image name. Container name, like this name will be assigned to our container. IT is for interactive terminal. IT means, suppose if I want to log into the container, if I want to get login access inside the container. So for that, basically we specify -IT. Later we will understand more about -IT, when to use. Okay, actually there are two switches. One is IT and one is IT and one is D, -D. Okay, now here in this case, -D means running the container in background. Okay, if we want to run the container in background, we use -D switch. It basically means running the container in detached mode. Okay, or for now you can understand, if you want to run the container in background mode, if you don't want to log into the container, in that case we specify -D. So the container will be running in background. The container will be running in background. If you want to log into the container at the time of deployment of the container, in that case we will use -IT. And IT command we will be using with operating system images. When we are working with operating system images, at that time we will use the IT command. Okay, the operating system images we cannot run in background mode. Okay, the operating system images we cannot run in the background mode. We can only run app images in the background mode. Okay, we can only run app images in the background. For example, here I am specifying image name as Nginx, which is an application, which is a web server. Right. So in that case, I can use -D. I can actually use -D also, and I can also use -IT. But in case of operating system images, I cannot run that container with -D. If I will run the container will exit. Okay, if we will run the container with -D without with -D of operating system image, the container will exit. So Freen, I understand this is your first session, that's why you're asking this question. So we have discussed this in our very first session of Docker, which is the last session. So container is equivalent to a virtual machine. Okay, in today's session also when we started, so container is equivalent to a virtual machine. And in AWS, EC2 instance is a virtual machine. Right? EC2 instance is a virtual machine. Okay, so now when we run this command, yeah, so as we will do the hands-on, you will understand what is IT and -d. I have explained it, but I understand it's very first time, so you're not able to understand. So -IT stands for interactive terminal. First of all, understand the full form. IT stands for interactive terminal. D stands for detached. And I'll write it down when to use IT so that I don't have to repeat again and again. So IT is used to deploy, or I would say, if you want to connect to the container at the time of container deployment. In that case, we use -i. Okay, if you want to connect to the container at the time of container deployment, in that case, we use -i. OS images, or I would say the base images, can, or I would say containers with base image, base or OS image, can, or I would say should be deployed with -it switch. Else, they will terminate. Terminate once deployed. So the containers which are using the operating system image or base image should be deployed with -it switch. Else they will terminate once deployed. Okay, there is actually a reason why they will terminate. As we will move forward, we will understand that as well. Okay, so IT is used to deploy a suppose if you want to deploy a container and if you want to connect to it, in that case we use -i. So after the container is deployed, I am right now inside the container. If you see here on the EC2 instance, I was logged in with Ubuntu. Now inside the container, I'm logged in with root user. Okay, here you can see completely different information. The host name is different. The username is different, right? So IT is used in case if we want to log into the container or connect to the container at the time of container deployment. And when we are deploying containers with base image or the operating system image, we should use -it switch. Else the container will be terminated. Terminate, or it will be in stopped state once we deploy it. And later in the course, we will understand why it will be in stopped state. Okay. Now let us talk about -d. -d -d, it is used to deploy container in background. Okay, -d stands for detached. Overall, it means deploying the container in background. So right now, when I am deploying the container with -it, I am logged in inside the container. But suppose I don't want to log in inside the container. I just want the container to be deployed in background. So in that case, we specify -d. With this, once you will run the Docker run command, the container will be deployed in background. Okay, and -d should be used only with app images. Okay, -d should be only used with app images. If you will use -d with the base images, like the operating system images, it will not work. Okay, if you will deploy, let's say, Ubuntu container with -d, the container will terminate. It will stop. Okay, so -d should be only used with app images. And later we will understand why with -d the container will run with app images, and why with base images we have to use -id. Later we will understand. Okay. So now when we deployed the container, we are logged into the container, right? Because we used -id. So in this command, with this command, we are deploying the container with interactive mode. This is the container name. This is the image through which this container is deployed. And at the time of deploying the container, let's say I wanted to run this command, bash. Okay. With bash, basically, we will get a shell inside the container. Okay. With bash, we will get a shell inside the container. In Linux, to interact with the operating system, we need to use a shell. Okay. In Linux, to interact with the operating system, we need a shell. In Linux, to interact with the Linux operating system, we need a shell. Okay, so we have different types of shells available. One of the most popular shell is bash. Apart from that, we have sh shell, we have zsh. Okay, so there are a lot of shells available. Okay, so to interact with the operating system, we need to use a shell. So here, to interact with the container, we are using bash shell. With bash shell, we are logging into the container. Okay. With bash shell, we are logging into the container. Now, right now, we are inside the container. Okay, right now we are inside the container. Now, let's say I want to log out from the container. Okay, now let's say I want to log out from the container. So we need to press Ctrl+P, then Ctrl+Q. Ctrl+P and Ctrl+Q. Now here you can see, now I'm back in my EC2 instance. Okay, here you can see this. Earlier we were inside the container. Now if I run here docker ps command, so here you can see we are able to see one container running. With docker ps command, you will be able to see the running containers. Okay, with docker ps, you will be able to see the running containers. Yes, we can also use the exit command, but with exit command, the container will terminate. Okay, with exit command, the container will terminate. Okay, so we are able to see the container running. Okay, now quickly let's understand this output also. So when we are running this docker ps command, we are able to see, we are getting this information. Okay. So in this command, first we are able to see container ID. Okay, this is what? This is the container ID. So just like when we deploy a EC2 instance in AWS, so our EC2 instance has a unique instance ID. For example, this EC2 instance I have deployed. So this EC2 instance has a unique instance ID. Same way, when we deploy a container, the container also has a unique container ID. Okay, this is a unique . Yeah, don't worry about the commands. I will share the commands. Okay, right now, don't worry about the command. The command was ctrl+p and then ctrl+q. Okay, right now focus on understanding the concept. Command I will share with you in the doc file. For exiting from the, use this command, Ctrl+P and Ctrl+Q, and then to see your container running, you can run docker ps. Okay, so container ID is the ID of our container, which is unique. Then image. Image is telling us the container image from which this container is created. Okay, this image name is telling us the container image from which the container is created. So the container which we deployed is using Ubuntu image. Okay, the container we deployed is the Ubuntu image is created. Just like when we deploy the EC2 instance, at that time instance ID is generated. Same way when we deploy the container, at that time container ID is generated. Then it is showing command. What is command here? Command is the command which is executed at the time of container deployment. Okay, so if you remember, to deploy the command, container, we used this command, docker run -it, then --name, the container name, then image name, and then we specified a command. Right after the image name, we specified a command. So we are able to see the in this output docker ps in command section, we are able to see the command which was executed at the time of container deployment. Then we are able to see created. So created is telling us when the container was created or when the container was deployed. Okay, created is telling us when the container was deployed. Then status. Status is telling us since when the container is up. So here we are able to see 8 minutes. It means the container is up since 8 minutes. Okay, the container is up since 8 minutes. Then ports. Ports we will actually talk later. Ports just for now. Exposed ports on the container. Just like in EC2, we have security group. Similar kind of concept we have here of ports. We will talk about it later. Okay, just right now as we are talking about the command output. So that's why I'm telling you right now, but later we will talk about this in detail. So right now in our case, it is blank. And then we have name. What is this name? This is the container. Okay, so this is the container. Okay, I'll quickly add the commands here. Okay, so we use this command to deploy the container. Before that, to pull, or I would say to list Docker images in Docker host, we run Docker image ls command. Then to log out from container, we need to run ctrl plus q and ctrl plus p and ctrl plus q. Okay, with this command, we will be logged out from the container. Then to list running containers, we have Docker ps command. What Docker ps command will do, it will show you the running containers. Okay, it will show you the running containers. So Kanishka, it is just a command which is used to, I would say, come out from the interactive mode. Okay, with which we are just coming out from the interactive mode from the terminal. Like this is just, I would say, a combination of keys. Like in Linux also we have different key combination like Control plus C, Control plus D. Okay, Control plus C is used for exiting from a command. Control plus D is used for forcefully exiting from a command. Right? No, here Control plus P doesn't means copy paste. Yeah, it's different thing. Okay, so with Docker PS, we are able to see the running container. Now let's say I want to stop this container. Okay, I want to stop this container. So to stop a container, we have this command docker stop, then container name. You can specify the container name or you can also use the container ID. It's completely up to you. Okay, you can use the container name or you can also specify the container ID. Whatever you are comfortable with, you can use. I personally use container name. So with this command, your container will be stopped. Now, if we do Docker PS, we are not able to see any container. Why? Because with Docker PS, we can only see running containers. And with this command, we have stopped the container. Okay, it is just like shutting down the EC2 instance. Right? So the same way to stop a container, we have this command docker stop and the container. You can specify either the container name or the container ID. It is completely up to you. Okay, so with this command, we will be able to stop the container, then to start the container. Yeah, Kanishka, we will talk about it. Sorry, Nagar will talk about it, how to Ubuntu image was running in container. After stopping container, image will be automatically stopped. So that is basically a illogical question. I mean, yeah. So suppose, for example, if I stop this EC2 instance, so will my image stop? No. Right? If I stop this EC2 instance, so my image will not be stopped. Image has no relationship with the instance state. Right? Whether the instance is running stopped, it has no relationship with the AMI. Same way, whether the container is running or stopped, it has no relationship now with the container image. Container image is only used at the time of creating the container. After that, it has no relationship with the container. It's now a completely independent instance or independent entity. So let us first understand how to log into the container, as most of the learners are interested in how to log in back to the container. So to log in back to the container, to log in to a running container. Okay, you can only log into a running container. You can log in. You cannot log into the to a stopped container. So to log into a running container, you need to run this command docker exec -it, then the container name or container ID, then the command which you want to execute. Okay. So for example, docker exec -it, then my container name is my container and bash. With this command, you will be able to log into your container. Okay. So let's say this is my running container. This command will only work for running container. Right? For stopped, it doesn't make sense because if the container is stopped, then we will not be able to log into it. So docker exec -it, then the container name, or you can specify the container ID and then the command. Now we are logged in back to the container. Okay. Now we are inside the container. To log out, Control+P, Control+Q. Control+P, Control+Q. Okay, so we know how to stop a container. We also know how to start a container. We also know how to log into a running container. Okay, now let us learn to check container resource usage. Okay, so let's say I want to check the resource usage of my container. Resource usage in the sense how much CPU it is using, how much memory it is using, how much network resources it is using, how much disk resources it is using. So for that, we have this command docker stats. So on the server, we can run docker stats command. Right. Now here we are able to see the container ID of our container, container name, the CPU utilization of the container, which is almost, I would say, 0%, which means currently our container is not consuming any CPU resources. Then we are able to see the amount of memory which currently our container is using. So our currently our container is only using 1.8 megabytes of RAM, which is nothing. You can say almost 2 MB of RAM. Okay, our container is currently using only 2 megabytes of RAM. Okay, so you can compare the resource utilization with virtual machine. Virtual machine will be at least consuming 300-400 megabytes of RAM. And here your container is just consuming 2 megabytes of RAM and 0 CPU usage. That's why we call containers as lightweight. And why they are lightweight? Because they only have the libraries and binaries which are required to run the application. They don't come with additional software, which we have discussed in the last session. They don't come with additional softwares. But in virtual machine, it comes with a lot of additional softwares, which consumes a lot of CPU and memory resources. Right? So currently the container which we deployed is only using 1.8 megabytes of RAM. Okay, in percent wise, it is using 0.919% of your host memory of your physical server, not physical server, of your EC2 instance. Then the amount of network it is using and the amount of disk it is using, and then the process ID of that particular container. The process which is running inside the container. So with Docker stats, we will be able to see detailed resource usage information of the containers which are running on our Docker host. Now let's say if you want to check container usage of a specific container. Okay, with this command, it will show for all containers. all running containers. Okay, if the container will be stopped, then it will not be consuming any CPU or memory resources. Right? See, just understand start and stop just like your EC2 instance. If your EC2 instance is stopped, then it will not be consuming any CPU or memory resources. And if your EC2 instance is stopped, you will not be able to log into your EC2 instance. Same is applicable here. If your container is in stopped state, you will not be able to log into it. If your container is stopped, you will not be able to see the resource usage of your container. Not physical server, I mean of our Docker host. Command for that, we have different switches. One switch is you can use -m, or you can run the docker help command. Here you will find one switch which is -m, with which you can set a memory limit. And we have one switch of -c, with which you can specify the CPU limit. Okay, with -c and -m, you will be able to allocate CPU and memory resources. That is not in our code, that's why I'm not discussing about it. So, but just for your knowledge, if you want to restrict resources, or I would say allocate specific resources to your container, so with -c switch and -m switch, you will be able to do that. So to remove the container, first of all, the container should be stopped. You cannot remove a running container. Okay, so to remove a container, first you need to stop a container. Docker stop container name, container ID, and then you have to use docker rm command. Okay. Docker stop and then docker rm. But suppose if you want to forcefully remove a container, forcefully in the sense if the container is in running state, but you want to forcefully remove it. You don't want it to be stopped, just you want it to be forcefully removed. So to remove or to forcefully remove a running container, use docker rm-f and then the container name or container ID. Okay. So to remove a container, let's say I have this container running. I want this container to be removed from my Docker host. So first we need to stop the container.
What is the purpose of a Jenkins file in Jenkins? Option A, to store configuration setting for Jenkins job. Option B, to define pipeline as code for building, testing, and deploying applications. Option C, to provide a graphical representation of the Jenkins pipeline. Or option D, to schedule periodic backups of Jenkins server. Comment down your answer below in the comment section. Just a quick info guys, Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs descriptions for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Then if you do docker ps, we are not able to see the container because we have stopped it. And now if you do docker ps-a, we are able to see the container. Now to remove it, we will run this command docker rm and the container. Now, if you do Docker PS or if you do Docker PS-A, we are not able to see the container. So removing a container is just like terminating a EC2 instance, right? Suppose in my AWS account, I don't want this EC2 instance, so I can terminate it. So same way, suppose in my EC2 instance, I don't want a container, so we can remove. Okay. Now let's say to remove an image, which is currently not in use by a container. Yeah, stopping means, stopping means stopping the EC2 instance. For example, this is my EC2 instance. So Docker, when I'm running Docker stop, so Docker stop is equivalent to stopping the EC2 instance. And when we are running Docker RM, so with Docker RM, we are terminating it. Let's say suppose this is EC2 instance and I no longer want this EC2 instance. So I can terminate it. But if I will stop the EC2 instance, I can later start it depending on my use case. Same way in case of Docker also, if I stop the container, later I can start it. When I need it, I can start it. But let's say I no longer need that container. So in that case, we can remove it with the Docker RM. With that, the container will be completely deleted or terminated from our EC2 instance. Okay, it is just deleting or terminating a EC2 instance. Whereas stop is equivalent to stopping the EC2 instance. And if we stop a EC2 instance, later we can start it. So same way, if we stop a container, later we can start it. But if we terminate a EC2 instance, then later we cannot recover it. Same is applicable with Docker RM command. So if we remove the container, we cannot later recover it or we cannot start. Okay, Nishant is asking, I hope Gaurav it is clear to you. Okay, Nishant is asking if we stop and then start the container, will my container ID will be the same or different? So your container ID will be same. For example, if you stop and start a EC2 instance, your instance ID will be same. Same is applicable for container also. If you stop and start a container, the container ID will remain same. The container ID and container ID and container name will remain the same. It will not change. Okay, so to remove an image, we have this command, docker rmi, and then the image. Then to remove an image forcefully. Okay, forcefully means which is currently in use by a container. In that case, we need to use docker rmi-f and then the image name. Okay. To forcefully remove an image which is currently in use by a container, we have to use this command. And that will not impact the running container. Okay, so let's say I have two images. Now let's say I don't need this image. So currently, let's say this image is not in use by any of my container. Currently, in our case, we don't have any container, right? So I can simply run docker rmi command, sorry, not rm, docker rmi command, and then the image name. And docker image ls. That image is now removed from the Docker host. Now let's say one scenario where I have a container running with a container image. Okay, so now when I'm going to run docker RMI command and the image name, so we will get an error that the image is currently in use by a container. Right. So in that case, if you want to forcefully remove it, so you can use docker RMI-f and the image. Now if you run docker image ls, the image is now removed. I mean, the image information is removed, but the image still is currently in our Docker host. And this will not impact the running container. This will not impact our running container. Yeah, and yes, you can also specify the image tag. If you will not specify the image tag, by default, it will try to delete the latest image. Yes, we can have multiple containers using the same image. Just like we can have EC2 instance, multiple EC2 instances using the same AMI. Right? I can use Ubuntu AMI to deploy multiple EC2 instances. Same way I can use Ubuntu image to deploy multiple containers. Okay, I can use a single image to deploy multiple containers. Okay, now let us learn. Okay, to rename a container, let's say we have a container running, and let's say I want to rename the container. For example, I have this container running. The name of the container is my container. Now let's say I want to rename this container to some other name, or I want to change the container name. So we can use this command docker rename, then the old container name, and then the new container. Right now, when we run docker ps, the container name is now changed to this name. To rename the container, we use this command docker rename, then the old container name, and then the new container. Okay, one more thing I would like to add, which would be here. To check the container disk usage, or I would say to check storage occupied by a container, we can run docker ps-s command, or you can run docker ps-as command. Okay, to check the storage occupied by the container from the Docker host or from the host operating system, we can run docker ps-as command. Right, so please join the session on time. Okay, so when we are running docker ps-as, we are able to see one more information, which is size. So right now, in the container, we haven't created any data or we haven't created any file. So that's the reason it is showing 0 bytes. Or there is no data currently stored in the container. That's why it is showing 0 bytes, which means this container is not using any storage from the host operating system. We are able to see here virtual size, and this virtual size is basically of the image. So this container is created from an image which has this size. The size of that image is this. But the container currently is not occupying any storage from the host machine. If you will start storing any data inside the container, we will be able to see the size of the data here. Okay, we need to install web server, then yes, then yeah, install Apache and Linux. Okay, after installing, yeah, so first is we need a web server. Web server could be Apache or Nginx. What's next? Where to keep the application files? Yeah, where to copy the files? Yes, we need to copy the application files to www HTML. Okay, those who are not familiar with this, I hope most of you would be familiar. Most of you have been, I mean, you may have learned this in your AWS lesson, right? Okay, those who are not familiar, this is very important to understand. So to deploy a web application in a Linux server, we need to deploy a web server. Okay, we need to deploy a web server. So majorly we have two types of web servers. One is Apache web server and one is Nginx web server. Okay, one is Apache web server and one is Nginx web server. So to install Apache, we need to run these set of commands. Okay, in a Linux server, to install Apache web server, we need to run these set of commands. Right, in order to deploy web server and in order to start the web server, we need to run these set of commands. And web server, this is in general, a web server listens on, what is the port of a web server? Default port of a web server? Good. So the default port is port 80. Right? So it doesn't matter which web server we are talking about, whether it is Apache or whether it is Nginx. All these web servers by default listens on port 80. Port 80 is the port number. Okay. So the port number of Apache is port 80. Then in Apache, we have document root. What is document root? Document root is the directory or the path where we have to keep the application files. Okay, where we have to keep the application files. So for Apache, the document root is www HTML. Here we have to keep the application files. And this directory is called the document root of Apache. Okay, this directory is called the document root of Apache. And one more thing, Apache config. So suppose I want to modify any configuration in my Apache web server. So we have this file etc apache2 apache2.conf. Okay, with this file you will be able to customize any configuration changes in Apache web server. Okay, so Ragan Sandhya, if you're asking this question, it means you don't understand what is systemctl start and what is systemctl enable. So systemctl enable is completely optional. If you want to run it, you can run it. If you don't want to run it, don't run it. It depends upon your use case. If you want the Apache service to be in running state after you reboot the server, then you can run this command. If you don't want it, don't run it. Okay, and I have explained this command, I would say, yeah, today only I think we have discussed this. So yeah, so we use this command systemctl start. See, these things are, I would say, applicable for everything. Okay, applicable for any service. Systemctl start Docker, systemctl enable, whatever service name. This concept is applicable for any service. So when I am running systemctl start service name, the service will be started at the runtime. Runtime means till the server is running, till then the service will be in running state. Okay. Systemctl start the service. So till the service, the server is running, the service will be running. Okay. So systemctl start service name we use to start a service in runtime. And what is runtime? Till the server is running, the service will be running. Then systemctl enable service name. This command will enable the service on boot and for deploying containers with app images. Okay, for deploying containers with app images, in that case, we can deploy containers with detached mode, or we can also deploy them with interactive terminal. Okay, usually the application images we deploy in detached mode, which means when we will be deploying the container with -d switch, the container will be launched in background. Okay, so usually with the application images we use -d switch, but with application images we can also use the -it switch. Okay. All right, so we are going to do one hands-on, and in this hands-on we are going to deploy a container with a application image. Okay, so first let us talk about what is the application image. In application image, we discussed in the last session that in application image, the operating system is also present and the application is also already present. Right? For example, Nginx. Okay, Nginx is basically an app image which is available on Docker Hub. Okay, now when I'm going to deploy a container with this image Nginx, the container will have the operating system plus it will have the application, or you can say software. Okay, so the Nginx, if I'm going to deploy a container with Nginx image, so it will come with the operating system and it will also come with Nginx already installed. Okay, similarly, let's say MySQL image. MySQL is also an application image. So let's say when I'm going to deploy a container with MySQL, so it will come with the operating system plus it will come with the software, the database software. I mean, MySQL already installed. So we don't have to manually install it. Right? So in our demo, we are going to deploy a container with Nginx as the app image. And where we can find the images, we can find the container images on a image registry. Right? So in the last session, we learned about Docker Hub, which is a public image registry. And here we can find images. Right? So let's say I want to deploy a container with Nginx web server. Okay. So if we search here for Nginx, so we have one image available for Nginx. Okay. Also, in the documentation of the image, which is available on Docker Hub, if you scroll down in the overview section, you will get detailed information of the particular image. Okay, like from who is the creator of this image, what are the tags which are supported in this image. Okay, then some reference link to the for the documentation, let's say of Nginx. Then what is Nginx? How to use this image. Okay, so everything is available in the overview section of the image. Okay, so we are going to use this image to deploy a container. Yes, sir. We can have both operating system and application image both in the same container. We will see that, but let's deploy a container with Nginx, and then we will connect to that container. We will log into that container, and we will verify whether we have the software Nginx installed or not, and we will verify the operating system. Okay, so application images have both the operating system also and the application also. Right? Application images have both the operating system also and the application also. Whereas the OS images only have the operating system. For example, Ubuntu. When I'm going to deploy a container with Ubuntu, that container will only come with Ubuntu operating system. When I'm going to deploy a container with CentOS image, so my container will only come with CentOS as the operating system. But when I'm going to use an application image, for example, Nginx, so my container will come with operating system as well as it will come with the software already installed. Okay, so both the things are present in the image, in the application image, the software also and the operating system as well. And one more way I would like to tell you guys to search for an image, is you can use this command, docker search and the image name. Docker search and then the image name. So what this command will do, it will go to Docker Hub. What this command will do, like here in Docker Hub, we are searching the image name, right? In Docker Hub, we are searching here the image name. The same thing this command is doing for us. Okay, the same thing this command is doing us for us. Okay, like in Docker Hub, let's say I want to search for an image, right? Let's say I'm on Docker Hub site and I want to search for an image. So what I will do, I will specify here the image name, right? For example, Ubuntu. And then I will get a search result of the images. Same way, let's say I want to search for the images in the Docker host itself. Okay, instead of going to Docker Hub, I want to search for the image in the CLI itself, on the Docker host itself. So we can use this command, docker search, and then the image there. And the output which we will be getting, the output will be the same output which we are getting here on the Docker Hub. Okay, so for example, if I search here docker search and then the image name, let's say Ubuntu. So here you can see I'm able to get a list of images, and the same list of images we are able to see here on Docker Hub when we are searching for Ubuntu image. Here you can see first image is Ubuntu, then second image is WebSphere Liberty, Ubuntu, WebSphere Liberty, Ubuntu Upstart, Ubuntu Upstart. Okay, so the same images or the same output we have here. Okay, it is little up and down, but overall we have the same output. Okay, so instead of going to Docker Hub, you can also search for image from the CLI. Okay, so we will pull this image, Nginx. And if we are not specifying a tag, so what it will do, it will download the latest image of Nginx or latest image which we are requesting. Okay, so here we are running this command, docker pull Nginx, and we haven't specified any image tag, right? In the last session, we talked about image tag, right? Image tag, or we also call it as image version, right? So if we are not specifying an image tag, so it will pick the latest version of that image. Okay, it will pick the latest available version of that image. Now, after running the Docker pull command, let's say I want to see the images which are available in my Docker host. So we can run Docker image ls command, and we are able to see here one image. Right. Now let us deploy a container with this image. Now here to deploy the container, I'm using -d switch. Then the container name, and then the image name. And the container is deployed. Okay, right now you can see we are on the Docker host itself. We are not logged in inside the container. And now if I do Docker PS, so we have a container running. So with -d, the container is deployed in background, right? When we were using -it, right? If you remember in the last session to deploy Ubuntu container, so we are using this switch. And when we used to deploy the container with this command, so we used to log in, we used to get a bash shell inside the container, right? We used to get a bash shell inside the container. Right. Now we deployed our container with this command. Docker run -d -name and the image. Now with this command, when we executed this command, we were able to see some ID. Here you can see here I executed the command, and after executing the command, a ID was generated. What is this ID? This ID is our container ID. Okay, this is the container ID. Now, when we do Docker PS, we are able to see the same container ID here. Okay, so with -d, the container is deployed in background. Right. So when we ran this command, we are not logged into the container. Okay, but the container is deployed and running in background. The EC2 instance which we created belongs to public subnet. Yes, the EC2 instance which we created belongs to the public subnet. Correct. Okay. Now, one more thing to note here is, if you remember when we were deploying the container with -it switch. Okay, when we were deploying the container with -it switch, we also specified one command. Right? After the image name, we also specified one command. And what is this command? This is the command which will be executed at the time of container deploy. Okay. But in case when we are deploying our container in detached mode or in background mode, so we don't have to specify any command. Okay, when we are deploying our container in detached mode, in that case, we don't have to specify any command. Okay, but when we are deploying our container in interactive mode, at that time we have to specify a command. Right. So for this container Ubuntu, when we were deploying a container with Ubuntu image, so we specified here a bash command. And with this command, we were getting the bash shell inside the container. Right? We were getting the bash shell inside the container. Okay, so we have the container running. We can log into this container. To log into the container, we learned this command docker exec -it, then the container name, and then the shell with which we want to log into the container. Okay, so this we discussed in the last session, that the command here which we are seeing in docker ps command. So this is the command which is executed at the time of container deployment. So when this container is deployed, at that time this command was executed. Okay, when the container is deployed, at that time this command is executed. Okay, so when we are running this command docker exec -it container name bash, so we are now logged into the container. Okay, now we discussed that in the app image we have the operating system as well as the software. Now let us verify whether inside the container we have the operating system and the software or not. So to check the operating system, in Linux we have one file, OS releases, cat etc OS releases. In this file, basically we will be able to see the operating system information. Okay, so here you can see currently in this container we have Debian operating system, Debian as the Linux distribution. Okay, so this confirms that the container has an operating system. And to verify Nginx, you can run this command, Nginx ---- or Nginx -v. Yeah. So if you run this command Nginx -v, we are able to see the version of Nginx. So this confirms that inside the container we have the operating system as well as the application also already installed. Application or the web server software also already installed. Okay, so these things we already discussed in the last session, that in this command, the first thing is the container ID. The second thing is the image from which the container is deployed from, right? So this container which we deployed it with Nginx image. And this is the unique container ID of the container. Then in command section, we are able to see one command. And this command is the command which is executed at the time of container deployment, which means when we deployed this container with this Nginx image, at that time, this command was executed inside the container. Okay, when we deployed the container with this image, at that time, this command was executed inside the container. Then we are able to see when the container was created and since when the container is up. Then we are able to see the name of the container. Plus, we are able to see one additional information, which is port. Okay. In the last session, we discussed that this is called exposed port. Okay. So currently, the container which we have deployed is exposing port 80. Why it is exposing port 80? Because Nginx works on port 80. What is Nginx? Nginx is a web server. Okay, Nginx is a web server. Right. For the operating system image, the port was blank. So what is Nginx? Nginx is a web server. And Nginx works on port 80, HTTP port. Okay, Nginx works on port 80, HTTP port, which is the HTTP protocol. Yeah, we will talk about that, how we can expose on port 80 and port 443. We will come on that. Okay, so when we deployed our container with this image Nginx, so we are able to see one port exposed. So inside the container, inside the Nginx, inside the Nginx container, we have the Nginx web server listening on port 80. Okay, we have the Nginx, Nginx web server listening on port 80. Now let's say I want to access it. Okay, let's say I want to access it. Okay, right now when I am running this command, okay, right now I'm inside the container. To come out from the container, we are running Control P and Control Q. And now when we do Docker PS, we are able to see the container is running and it is exposing on, it is listing on port 80. Now let us try to access the application which is listing on port 80. So to access it, we will use the EC2 instance public IP. And we are not able to access it. So why we are not able to access it? One reason could be that in the security group, we do not have port 80 open. Right? One reason can be that in the security group, we do not have port 80 open. Okay, so this is our EC2 instance. If we go to the security tab, so currently in my security group, I don't have port 80 open. So let us open port 80 in the security group. So right now you can see in inbound of my security group, I have port 22. Okay, now if we try to access, still we are not able to access it. Okay, still we are not able to access it. But when we are running the Docker PS command, we are able to see that our container is listing on port 80 or is exposing the Nginx web server on port 80. But when we are trying to access it from the public IP of our EC2 instance, we are not able to access it. Okay. So currently, if we visualize this, or in our Docker host, we have a container running, right? A container running, which is using Nginx image, right? And which is listing on port 80. Okay, which is listing on port 80. So currently it is running in a different network. Okay, one more thing I would like to add here. When we install Docker, a network is created. I would say a custom network is created. Okay, custom virtual network is created, which is used by the containers. Okay, so when we install Docker, okay, when we install Docker for the very first time, so at that time, a network was created. In our EC2 instance or in our Docker host, a network was created. And the name of the network is Docker 0. Okay, this is basically a virtual network. And this is created when we install Docker. Okay, this is created when we install Docker. So if we log into the EC2 instance, and if we run here IPA command, yes, or we can run ifconfig command as well. IF command actually is not available. So if we run IP space A command, so we are able to see here one network interface, Docker 0. And this is a virtual interface, virtual network interface. Okay, this is a virtual network interface. And when we deploy containers, so the containers are deployed in this network. Okay, the containers are deployed in this Docker 0 network. So right now our container is listing on port 80, but it is not accessible outside. It is accessible inside the EC2 instance. Right now from the EC2 instance, inside the EC2 instance, if I try to access the Nginx web server, I will be able to access it. In the EC2 instance, if I try to access the Nginx web server on port 80, I will be able to access it. But when I will try to access it outside, okay, outside from the EC2 instance, from the host network, from the public IP of the EC2 instance, I will not be able to access it. Okay, we will not be able to access it because it is running in a different network. Okay, and our EC2 instance has a different network. Okay, when we launch a EC2 instance, our EC2 instance has a ENI. Okay, when we launch a EC2 instance, our EC2 instance has a ENI. What is ENI? ENI stands for Elastic Network Interface. Okay, so when we deploy a EC2 instance, our EC2 instance has a ENI. Okay, those who are familiar with on-premises or in general, ENI is equivalent to NIC. NIC stands for Network Interface Card. Okay, NIC stands for Network Interface Card. In the cloud, or I would say in AWS, the same NIC, we call it as Elastic Network Interface. So when we launch a EC2 instance, our EC2 instance is attached. I mean, our EC2 instance has a ENI attached. For example, if we see this EC2 instance, okay, this is my EC2 instance, and this EC2 instance has, okay, here we are not able to, yeah, here you can see network interfaces. Okay, this is our EC2 instance, and this is network interface, and here we are able to see that on our EC2 instance we have a ENI attached, network interface attached. Okay, we have a network interface attached. So ENI or NIC cards are basically used for network communication. Okay, NICs are used for network communication. Suppose two systems wants to communicate with each other. Let's say there are two EC2 instances and they want to communicate with each other. So both the EC2 instances should have NICs. If they don't have NICs, they will not be able to communicate with each other. Okay. So this is actually a very fundamental concept. Those who are not aware, so we will talk about it. So in our laptop desktops, and our desktops, let us first understand about, I mean, how we have NICs in laptop desktop, then we will come on EC2 instance. Okay, so in our laptop desktops, we have this attached. Okay, this is a NIC. This is how basically a NIC looks like, a hardware NIC. So in our laptop, in our desktops, we have this NIC. Right? In your laptop, you may have seen this port where you may have attached a LAN cable. Yeah, this one. Here we attach a LAN cable. Right? So this is basically a NIC. Without a NIC, a device cannot communicate on a network. For example, I have a desktop or I have a laptop, and if this laptop desktop doesn't have a NIC, okay, suppose this laptop desktop doesn't have a NIC, so then this system will not be able to communicate on any network. Suppose this system, this laptop desktop wants to connect to the internet. This laptop desktop will not be able to connect to the internet because it doesn't have NIC. Okay, so NIC is basically used for network communication. Suppose there are two servers. These two servers wants to communicate with each other for transferring data. Right? So both these two servers should have NICs. If they don't have NIC, they will not be able to communicate with each other. Okay, if they don't have NIC, they will not be able to communicate with each other. So this is not only applicable to laptop, desktops, or for server. This is applicable to any device which is connecting on a network. Even in our mobile phone, right? Even in our mobile phone also we have NICs. Okay, in our mobile phones also we have NICs. Okay, and with the help of NICs only, our mobile phone is able to connect to a network. For example, to the internet. Okay. So NICs basically are used for network communication, right? So same way in EC2 instance also we have a NIC. Okay, same way in our EC2 instances also we have a NIC. In AWS terminology, we call that NIC as Elastic Network Interface. Okay, we call it as Elastic Network Interface. So when we launch a EC2 instance, our EC2 instance has a ENI, Elastic Network Interface, which is nothing but the network interface card. Okay, and this ENI basically has two IPs. One is the public IP and one is the private IP. Okay, one is the public IP and one is a private IP. Suppose if our EC2 instance doesn't have this ENI, so our EC2 instance will not either have public IP and it will not either have private IP. And if it doesn't have a public IP or private IP, we will not be able to connect to it. Right? If it doesn't have a public IP or private IP, we will not be able to connect to it. Right? So our EC2 instances have ENI attached. Here you can see, this is the EC2 instance. You have to go to networking tab, network interfaces, and here we are able to see the interface. And here we are able to see the public IP and the private IP. Yes, ENI comes by default when we launch the EC2 instance. Okay, this public IP which is assigned to our EC2 instance and the private IP assigned to our EC2 instance is actually coming from this ENI. So yeah, now when we install Docker, in a EC2 instance, in our EC2 instance, a virtual network is created and the network name is Docker 0. Okay, when we install Docker, a virtual network is created in the EC2 instance and the network name is Docker 0. If we see in our EC2 instance, if we run IP space A command, with IP space A command, we will be able to see all the network interfaces in a Linux server or in our EC2 instance. So here you can see we have one network interface Docker 0, which is basically a virtual network interface. Okay, and when we deploy containers, okay, when we deploy container, our containers are deployed in this network. Okay, when we deploy containers, our containers are deployed in this network. So Nishant, where you are not able to see the ENI? Right. So when we are running IP space A command, we are able to see the ENI. This is the ENI, Ethernet. Okay, ETH0. This is the ENI which we are able to see here with the help of IPA command. And you can verify that also. If you see this is our EC2 instance, then you go, if you go to networking tab, this is the private IP of our EC2 instance. 172.31.30.136. And in the EC2 instance, if you run IP space A command, you will be able to see ETH0 interface. And here you will be able to see the same IP address, which you are able to see on the EC2 dashboard. 172.31.30.136. Okay, 30.136. So this is the ENI which is connected to your EC2 instance. And this is the ENI which is created. This is not ENI, this is basically a virtual network interface card which is created when we install Docker. Okay, and the containers which we deploy, the containers are deployed in this network. Okay, the containers which we deploy, the containers are deployed in this network. Okay, so this is, I would say, not a new concept. Even in virtualization, when we create a virtual machine, okay, suppose in your laptop or desktop, let's say this is your Windows 10 or Windows 11, let's say Windows 11 laptop or Windows 10 laptop. Now in your Windows 10 laptop, let's say you have installed a hypervisor, let's say VirtualBox, Oracle VirtualBox. Okay. Now when you install this hypervisor, a virtual network is created. Okay, in your Windows 10 laptop desktop, a virtual network is created. Now, when you create any virtual machine, in your laptop, that virtual machine is connected to this network. And the same thing is applicable in case of containers as well. Okay, the same thing is applicable in case of containers as well. Okay, so when we deploy the containers are connected to this Docker Zero Net. Yeah, we can say like VPC, like when we deploy a EC2 instance in the VPC, so the EC2 instance is connected with the subnet, with a specific subnet, right? Subnet which is part of the VPC. Right. So currently our container is running. Yeah, Ethernet, Wi-Fi adapter, these are all NICs, network interface cards. Ethernet is basically used for wired connection, and Wi-Fi adapters or Wi-Fi NIC cards are used for wireless connection. Okay, so right now the container which we deployed of Nginx is listening on port 80. I mean, it is exposing the web server on port 80. But we are not able to access it outside. The reason we are not able to access it outside, we are not able to access it from the outer network is because both our EC2 instance is running in a different network and our Docker Zero is basically a different network. Okay, our Docker Zero is a different network. And our EC2 instance is in a different network. So can anyone tell, can two machines in different network can communicate with each other? For example, let's say I have two EC2 instances and one EC2 instance is in this network. Okay, one EC2 instance is in this network and another EC2 instance is in this network. But no issues, I will repeat it again. Yeah, so here you can see we have different network ranges, class A IP address, class B IP address, class C IP address. So class A IP address, or I would say any IP address belonging to class A will not be able to talk with a IP address in class B. And any IP address in class B will not be able to communicate with a IP address in class C. Two different networks cannot communicate with each other. Okay, this is actually a fundamental concept of networking, that two different networks cannot communicate with each other. And that's the reason the EC2 instance deployed in this network and a EC2 instance deployed in this network will not be able to communicate with each other because they are in different networks. Right? This is a class A IP and this is a class C IP. Okay, this is a class A IP and this is a class C IP, and hence they will not be, sorry, class B IP, and hence they will not be able to communicate with each other. Now the same thing is applicable in our case. Our EC2 instance is running in a different network and our Docker Zero network interface is running in a different network. And hence, when we are trying to access the application over public IP of the EC2 instance, we are not able to access it because both of them are in a different network. Okay. Now, in order to expose the application, okay, in order to expose the application, in AWS also, it will not be able to communicate with different CIDR. And this is a fundamental concept of networking. This is applicable everywhere where we are talking about networking, whether it is AWS, whether it is on premises, whether it is inside EC2, anywhere. Okay, so as they are in the different network, hence we are not able to access it by the EC2 instance public IP. Now, in order to access it over the EC2 instance public IP, we need to do port mapping. Okay, we need to do port mapping. So to do port mapping, at the time of deploying the container, we need to use this switch -p. Then we need to specify a port number, then the image. Okay. Now here we are specifying two port numbers separated by a colon. Here, the left side port, the left one. Okay, here we are specifying two port numbers. One is the left one and one is the right. So the left one is indicating, or the left one is representing the host port. Okay, host port or the port of the EC2 instance. Okay, the left side port is representing the host port, the EC2 instance. And the right side port is representing the container port. Okay, the right side is representing the container port and the left side is representing the host port, the EC2 instance. Right. So with this, we will be able to expose our application over the host network or over the EC2 instance public IP. So right now in our case, we have, okay, so let's say this is our EC2 instance, and in our EC2 instance, we have a container running, and this container is using the Docker 0 network. Okay, the container is using the Docker 0 net. I'll show you that, that how this container is using the Docker 0 network. We will see that there is a command to check that. And our EC2 instance is running in a different network. Okay, our EC2 instance is running in a different network. Now, the container which is running inside our EC2 instance is listing on port 80. Okay, or is exposing the Nginx web server on port 80. Now, in order to make it accessible over the host network, or in order to make it accessible on the EC2 instance network or over the public IP, we have to do port mapping. And in port mapping, by this switch, we are telling that any request, with this switch, we are telling here, like we will be using this command. With this command, we are telling that any request coming on the EC2 instance on port 80, any request coming on the EC2 instance on port 80 should be forwarded to port 80 of the container. Here, what we are telling that any request coming on EC2 instance on port 80 is this port. Okay, port 80 is this port. So any request coming on EC2 instance on port 80 should be forwarded to port 80 of the container. Where we are telling the port number of container, we are telling the port number of container here. This is the container. So what we are telling here is that any request coming on the EC2 instance on port 80 should be forwarded to port 80 of the container. And how we are doing that? We are doing that with the help of port mapping. And once we will do that, we will be able to access the application by port 80 of the EC2 instance. Okay, we will be able to access the application by port 80 of the EC2 instance once we do the port mapping. Okay, first let us see how this container is using Docker Zero network, then you will get more clarity. Yeah, here you can see this is our container IP address. Okay, just like our EC2 instance has a private IP, same way our container also have a IP address. So we are able to see the container IP address here. Okay, and if we run IPA command, and if we check Docker Zero network is starting from 172.17.0.1. And if you see the container IP is also of the same range, 172.17.0.2, 0.1, 0.2. Right? And if you see the gateway is the Docker Zero IP address. Okay, so this confirms that this container is deployed in or is using this network interface. Okay, and from this network interface, it is getting this IP address. Okay, not getting this interface, I mean, this container is deployed on this network, Docker Zero network. And it has this IP address, which belongs to this network. Okay, and our host have a different network range. If you compare the IP address of the host network and the Docker Zero network, so they are two different networks. Okay, one is ending with /20 and one is ending with /16. Apart from that, if you see the network range, so one is starting from 172.31, another is starting with 172.70. So both are in two different networks. And if they are in two different networks, they will not be able to communicate with each other. And hence, we were not able to access the application by the EC2 instance IP. No, I haven't mapped it. It will be mapped by default. So when we will be deploying the containers, that's what I have been explaining, that when we deploy a container, the container is connected to this Docker Zero interface. Okay, and from this network interface, it gets a IP address. Okay, from this network interface, it gets an IP address. So we don't have to manually specify any IP address. This is, I would say, the default configuration. So when we deploy a container, the container is by default connected to this Docker Zero network. And from this Docker Zero network, it gets the IP address. Yeah, so we will come on that, how two containers will work. First, let us understand how it will work for one container. Then we will talk about how it will work with multiple containers as well. Okay, so right now, when I'm trying to access the application by the instance IP, right now, I'm not able to access. Okay, because they are in two different networks and hence we are not able to access it. Now, in order to expose it, okay, in order to expose it on the host network, on the EC2 network, we have to do port mapping. And to do port mapping, we have to use this command, docker run before the image name, we have to do the port mapping. Now, if we do docker ps, we are able to see that any request coming on the EC2 instance on port 80 will be forwarded to port 80 of this container. Any request coming on port 80 of the EC2 instance will be forwarded on port 80 of the container. Now let us try to access it. Earlier, we were not able to access it. Earlier, before port mapping, we were not able to access it. So now we are able to access it. Okay, now we are able to see the default page of Nginx, which is welcome to Nginx, which means now what is happening? Now any request coming on our EC2 instance on port 80. In the browser, when we are opening, when we are accessing our, I would say, when we are specifying the IP address of our EC2 instance, so by default, it requests on the EC2 instance on port 80. Right? And with this port mapping, what we have configured that any request coming on our EC2 instance on port 80 will be forwarded to port 80 of the container. Okay, any request coming on the EC2 instance on port 80 will be forwarded to port 80 of the container. Now let us understand how this will work for multiple containers. Yeah, so Sashi, we cannot do port mapping after Docker run, which means suppose if we have deployed a container and if we want to add a port in the existing container, so we cannot do that. So port mapping we can only do at the time of deployment of the container. After the container is deployed, we cannot do port mapping. Okay, after the container is deployed, we cannot do port mapping. Port mapping we can only do at the time of container deployment. Once the container is deployed, after that we cannot change any, we cannot do the port mapping. So Nathan Kumar, we don't have to get in that depth that how to change the CIDR of the Docker Zero network. Just to answer your question, yes, we can change the CIDR network. Actually, in Docker, we have a concept of networking. Docker networking, with which basically we can create our own custom networks as well, similar to Docker Zero network. Yeah. Okay, now let us understand how port mapping will work for multiple containers. Now, before going on that, let me make one more thing clear. So let's say inside the EC2 instance, I have a container running, which is listing on port 80. Okay, and I have deployed this container with this command. Okay, I have deployed the container with this command. So with this command, at the left side, we are telling the host port. Host port means the EC2 instance port. And here at the right side, we are telling the container port. Okay, at the left side, we are telling the host port, and the right side, we are telling the container port. Now, in order to access this application which is running inside the container, so I have to reach on the EC2 instance public IP on port 88. Okay, I have to reach to this EC2, to the application through the EC2 instance public IP and over port 80. So with this configuration, what we are telling is any request coming on the EC2 instance on port 8080. Any request coming on the EC2 instance on port 8080 should be forwarded to port 80 of the container. Okay, any request coming on the EC2 instance on port 8080 should be forwarded to port 80 of the container. Right? Now, let's say there are multiple containers. Let's say I have multiple containers and these containers are also listing on port 80. Okay, these containers, let's say, are hosting a service on port 8. Now let's say I want to expose these containers also. I want to also expose the application which is running inside these containers on port 80. Right. So to do that, I have to deploy these containers also with port mapping. So for example, this container name is app1. This container name is app2, and this container name is app3. Okay, this container name is app1, this container name is app2, and the third container name is app3. Okay, now at the time of deploying these containers, for the first container, let's say I want the first container to be exposed.
What is the primary purpose of Kubernetes in the context of continuous orchestration? Option A, version control management. Option B, container orchestration. Option C, code compilation. Or option D, database optimization. Comment down your answer below in the comment section. Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Over port 88. So I will specify this command. For the second container, I want the second container to run on port 80. So I will use this command. Now the third container, I want it to run on port 90. Okay, so we have to use this command. Okay, so when any request coming on port 8080 on the EC2 instance over the public IP, the request will be forwarded to app1 container. Based on this configuration, any request coming on the EC2 instance on port 8080 will be forwarded to app1 container on port 80. Port 80 is the container port. Similarly, any request coming on the EC2 instance on port 80. Any request coming on the EC2 instance on port 80 will be forwarded to app2 container and on port 80. Port 80 is the container port, which is this port. Now, based on this configuration, any request coming on the EC2 instance on port 90. Any request coming on the EC2 instance on port 90 will be forwarded to app3 container on port 80. Now, one thing to note here is no two containers can listen on the same port. Oh, sorry, no two containers can be exposed on the same host port. No two containers can be exposed on the same host port. Suppose I want container app1 and container app2 both to be exposed over port 80. Okay, I want container app1 and container app2 both to be exposed on port 80 of the host port. So that is not possible. Okay, that is not possible. Two containers cannot listen on the, two containers cannot use the same host port. But at the container level, they can use the same port number. Okay, at the container level, they can use the same port number. For example, app1 can listen on port 80, app2 can listen on port 80, app3 also can listen on port 80. But when we are doing port mapping or when we are exposing them, at that time, one container can only use one host port. We cannot run multiple containers with the same host port. Okay. For example, let's say I have this container, my web app, and this container currently is using port 80 of my host machine. Then at the time of deploying the container, we are also doing port mapping, that any request coming on the EC2 instance on port 80 should be forwarded to port 80 of the container. Then the image name, and then a command which we want to execute at the time of container deployment. Okay, actually Ubuntu image was not available in the EC2 instance. So first it has pulled the image, and after that it has deployed the container using that image. So right now we are inside the container. Okay, now we are not in the EC2 instance, we are inside the container. And if we log out from this container, and if we do docker ps, so you can see this container we have deployed with Ubuntu image, and this container is exposed on port 80 of the host machine. Sorry, this container is exposed internally exposed on port 80, and this is the host port. Which means any request coming on the EC2 instance on port 80 will be forwarded to port 80 of the container. Now let us log into the container and let us deploy the web application. Okay, so to log into the container, we will use this command, docker exec -it, then the container name and bash. Now we will be installing. So Sharnaya, here we have done the port mapping. Docker run -it -name, then the container name, -p, then the port mapping, then the image name and the command. So here we have done the port mapping. This is the command through which we have done the port. Okay. And when we ran the docker ps command, we are able to see here the port mapping. To container using different port of host. So right now we have only deployed one container. So please pay attention also. Initially, there were few containers running. So first I stopped all the container, and after that I deployed one container, which is this container. Right? Earlier there were 3 containers running in the EC2 instance. So first I stopped all the 3 containers, and after that I deployed this container. Okay. If the container is in stopped state, then it will not be using any port. Okay. If the container is in stopped state, for example, I stopped 2 containers. Okay. I stopped these containers. Right. So these containers are no longer using any ports because they are in stopped state. They are not running. So if they are not running, then the ports will not be in use by those containers. Port mapping will only work for running containers. It will not work for stopped containers. So right now in our case, we deployed one container with this port map. Two containers with port mapping. So that also we saw just before our break. So I will show that again, no issues. So we have one container running, which is using port 80. One container running, which is using port 80 of the host machine. Now I'm deploying one container let's say with the Nginx image. And I'm doing here mode mapping of this. Now, if we do Docker PS, we are able to see that any request coming on the EC2 instance on port 80 is forwarded to port 80 of the container, which is this one. Okay, so now these are two containers with port mapping. One container is using host port 80 and another container is using host port 8080. And we already saw one example where we saw that we were trying to deploy a container with a host port which was already in use. So we were getting permission denied. Yeah, so let us see that as well. So to see that, first we need to open port 8080 in the security group. Because the container is listing, the container is using port 8080 of the host port, right? Here if you see, it is using port 8080 of the host port. So we have to open port 8080 in the security group. And now when we will try to access it on port 8080, we are able to access it. Okay, we are able to access it on port 8080. Okay, so coming back on the application deployment. So I will stop the other container to avoid confusion. Okay, so we have deployed a container with Ubuntu as the image. And at the time of deploying this container, we have done port mapping. Okay, port mapping. We have done this port mapping that any request coming on the EC2 instance on port 80 should be forwarded to port 80 of the container. Now we will log into this container and we will deploy a web application. Right. So in this container, we will deploy Apache web server. So as we know, before installing any software in Linux, we first need to run apt update command. So this container is also a Linux container, right? This container is deployed with Ubuntu image, which is the operating system image. So inside this container, we have Ubuntu as the operating system. So when we are working with Ubuntu, in order to install any package, first we need to run apt update command. Then apt install, then the software. So for this demo, we are using Apache web server. Okay, so here you can see that a repository is now cloned. And inside this directory, we have the application files. Okay, so we have successfully deployed our application under var www HTML directory. Okay, now after deploying the application, we need to start the service of the web server. Okay, after deploying the web application, we need to start the service of the web server. So in our case, the web server is Apache. So we need to start the service of Apache. So in the last session, if you remember, to start the service of Apache, we discussed that we have to use this command. Right? In the last session, we discussed to start the service of Apache, we need to run this command. So this command is applicable in case if you are working with a Linux virtual machine, or in general with a Linux server. Okay, if you are inside a Linux server, in that case you have to use this command. Now when you are inside a container, in the container, instead of running systemctl, you have to use this command. Inside the container, we don't have systemctl. Okay, inside the container, we don't have systemctl. So inside the container, you have to run this command to start the service of Apache. This you have to do in case of container. You cannot use the systemctl start command inside a container. Okay, but this command you will be using when you will be working in a Linux server, for example, inside a EC2 instance. Suppose you are installing Apache web server. So in that case, you can use this command. Or in general, in any Linux server, whether it is an EC2 instance or whether it is an on-premises. So when you are installing Apache web server, so you can start the web server with this command. But just in case of containers, to start the, I would say, the service of Apache, we need to run this command. Or in general, to start any service inside the container, we need to run this command, etc init.d, then service name, start. Okay, etc init.d, service name, and start. Right now, in our case, we are working with Apache, so we have to start Apache service. Similarly, let's say instead of Apache, you are using Nginx. So to start the Nginx web server, you need to run this command, etc init.d nginx start. Okay, so in the container, in order to start the Apache web server, before starting the Apache web server, let us try to access it. Okay, so right now we are not able to access anything because the service of Apache web server is not running. Okay, the service of Apache web server is currently not running, and hence we are not able to access the application. Now, once we start the service of Apache, which is in etc init.d Apache to start. Okay. So to start the service of Apache, I am using this command. Now the service of Apache server is started. Now if we go on that IP, we are able to see the default page of Apache. And if you specify here demo app, which is basically the repository name, which we currently have inside the www.html directory inside the container. So we will be able to access this application. Okay, we will be able to access this application. Okay, so this is a web application which is currently running inside our container. No, enable command also we cannot use inside the container. Because see, enable command we use when we want to enable the service on reboot or on restart. And if you remember, we learned when we were talking about the difference between container and virtual machine, we learned that the containers don't boot up. Right? Containers don't boot up. So there is no sense of systemctl enable command. Right. So to access the application, you have to go to the instance public IP, then the repository name. Why repository name here we are specifying? Because currently the application is running, or I would say is placed in var www HTML directory, and under var www HTML directory we have a directory by the name demo app. So that's why in the after the public IP we are specifying the directory name demo app, and after that we are able to access the application. And this application code is in our GitHub repository. This is the application. Yeah, in container, we cannot use the systemctl command. That's what I have been explaining here, that inside the container, we cannot use the systemctl command. Okay, why we are not able to execute it? For that, you need to understand systemd. Okay, this is basically a Linux concept. Okay, systemd is basically a operating system daemon, which is loaded when the operating system boots. Okay, systemd is a daemon which loads when the operating system boots. So currently in case of containers, in containers, we don't have any booting, right? When we were learning the difference between container and virtual machine, so we learned that containers don't boot up. Okay, containers don't boot up. So as they don't boot up, we don't have any systemd service running, systemd daemon running. And as systemd daemon is not running, we will not be able to use the systemctl command. So inside the containers, in order to manage the services, we have to use this command, etc init.d, etc init.d, then the service name, and then the operation you want to perform, start, stop, restart. Yeah, so yes, Priya, here that only I explained before doing this stuff, which we are doing here. Before doing this, first we discussed that only, that in a Linux server, we can use this systemctl command. Inside the container, we cannot use this command. And why we cannot run it? Because because the containers don't boot up. And as containers don't boot up, this systemd daemon is not running inside the container. And systemctl basically interacts with this systemd daemon. And if the daemon is not running, then you will not be able to use this systemctl command. Even inside the container, systemctl command is not installed, is not available. If I run systemctl, command not found. Okay, so in the container, to manage services, we have to use etc init.d, service name, then the operation, start, stop, restart. Yeah, don't worry about the commands. I will share all the commands in the sheet. Okay, the GitHub URL I can share right away. No, auto scaling, load balancer are different concept. Here we are not talking about load balancer and auto scaling. We will be learning about auto scaling load balancer in Kubernetes. Okay, after learning Docker, the next tool which we are going to learn is Kubernetes. So when we will be learning, when we will be learning Kubernetes, at that time we will talk about how the containers will scale and how the load balancing will work. Okay, Nishant is asking why we have started the Apache 2 in container, though we have used a demo app. What is demo app, Nishant? Can you tell what is demo app? It is actually the path. It is not the command. It is actually the path to the file. Okay, Priya, it is basically the path to the file, not the command. Yes, inside the container, we can use bin. I mean, we can go inside bin directly. We can go to any directory. Okay, like in the container, we can go to bin directory as bin. Yeah. So we can go to the bin directory. In container, it is under USR bin. And inside this directory, you can see all the commands. You can access any directory. Under this root file system, you can access any directory. Okay, right now, if we visualize this, so right now inside our EC2 instance, we have one container running, and inside this container, we have the web application. And inside the container, the web application is exposed over port 80. Okay, while deploying this container, we ran this command. At the time of deployment of this container, we ran this command. Okay, at the time of deploying the container, we ran this command. So with this command, what we are telling? We are telling any request coming on the EC2 instance, any request coming on the EC2 instance on port 80. Why port 80? Because here we have specified at the left side port 80. Here, the left side port 80 represents the EC2 instance host port, and the right side port 80 represents the container. So we are telling here that any request coming on our EC2 instance on port 80 should be forwarded to the container on port 80. Why port 80? Because here we have specified the container port as 80. And inside the container, we have deployed Apache web server and we have deployed the web application. So this application which we are currently accessing is basically currently running inside our container. Yeah, so we can run docker starts command. Oops. Yeah. So after docker running docker starts command, we are able to see the current container currently is using almost 80 megabytes of RAM. Okay, and almost zero CPU utilization. Okay, docker starts command we learned in the last session. Docker start command is used to check the resource usage of the container. Right. So when we ran the docker stat command, we are able to see the CPU utilization of the container, memory utilization of the container, network utilization, and disk utilization of the container. Right. Okay, so the application which we are able to access here in the browser is currently running inside this container. Okay, the application is not running inside our EC2 instance, it is running inside our container. And we are able to access it because of the help of port mapping. So any request coming on our EC2 instance on port 80 is being served through this container. And that's how we are able to access this web application which is running inside our container. Okay, so this way you can host any application. Okay, you can host any web application inside the container. Now we are going to learn how to create a container image. so far we have been using container images from Docker Hub. Or I would say so far we have been, we have been using third-party images, right? So far all the images we were using from Docker Hub. Now we are going to learn how to create our own container image. So first we will learn how to create a container image, and then we will publish our container image to Docker Hub. Okay, we are going to create our own container image and we will publish that container image on Docker Hub. Okay, on this image registry, we will publish our own created container image. Okay, now before starting with container image creation, first let us understand, or first let us discuss about AMI creation. Can anyone tell me how to create an AMI? What are the steps to create an AMI? Suppose I have a EC2 instance, or let's say in AWS, I want to create my own, let's say I want to create an AMI in AWS. So to create an AMI in AWS, we need to follow these steps. First step is we need to launch an EC2 instance. Launch EC2 instance. After that, after launching the EC2 instance, you can deploy your application or whatever you want to do. Let's say connect to EC2 instance and deploy application. Okay. First step is you have to launch a EC2 instance. Second step is connect to the EC2 instance and deploy application. Then third step is create an image or create an AMI. Right. For example, I want to create an AMI of this EC2 instance, which is currently running. Right. So I can click here on actions, image, and create image. With this, I will be able to create an AMI. Okay. With this, I will be able to create an AMI. So these steps we need to follow in order to create an AMI. What is AMI? AMI is also an image only, right? Operating system image. Right? It's also a operating system image. Same way, let's say I want to create a container image. Okay, same way I want to create a container image. Now to create a container image, we have to follow the same procedure. Okay, we have to follow the same procedure. The same procedure is first launch a container. Second step is connect to container and deploy your application. Then third step is create an image. Create an image of the container. So the way we create a AMI in AWS, the same procedure we have to follow to create a container image. So first what we need to do, we need to launch a container, and inside that container, we need first, after launching the container, we need to connect to the container and deploy the application. And after that, we need to create an image of that container. Right? After that, we need to create an image of that container. Okay, so let's deploy a container. And in that container, we will quickly deploy one application. And after that, we will create an image of that container. Okay, so we are connected to the container. Now, in case of Nginx, we have to place the application files under USR share Nginx HTML. The document root of Nginx is USR share Nginx HTML. Okay, the document root of Nginx is usr share nginx html. In this directory, we have to place the application files. In case of Apache Web Server, we have to place the application files under YWWHTML. Now, when we are working with Nginx, we have to place the application files under usr share nginx html. Okay. So right now we are connected to the container and we are inside usr share nginx html directory. And here I'm going to deploy the same application. Okay, here also we will not be able to run the git clone command. So first we need to install Git. So first we have deployed a container. After that, we connected to the container. And after that, we have deployed our application. So right now we are working with Nginx. So in case of Nginx, we need to place our application files under usr share nginx html. Okay, so you can see we are able to see the demo app directory. And inside this demo app directory, we are able to see the application files. Okay, so we have deployed the container, and inside the container, we have also hosted the application. Now, if we try to access the application by the EC2 instance IP and the port number of the container, host port of the which is mapped to the container. So we are able to see the default page of Nginx. And if we go on this part, demo app, demo-app, so we are able to access the application as well, which is deployed inside our container. And why we are using port 8080? Because at the time of deployment of this container, we deployed the container with port 8080 as the port mapping. So 50.x.html is basically 500 page of Nginx. Okay, that is just an application file. For now, just understand it. It's just an application file. Okay, so now when we are accessing the application, by port 8080, we are able to access it. So based on the steps for creating an image, first we have launched a container. After that, we have deployed our application inside that container. Or understand it in this way, suppose my company has developed this application. Okay, suppose my company has developed this application. Now my company wants to create a Docker image and my company wants to publish that Docker image in Docker Hub, so that anyone on the internet can pull that Docker image and can deploy a container with my Docker image. And when they will be deploying a container with my Docker image, they will get this application running. Okay, they will get this application running. Right. So for that, I'm creating my own container image. Okay, the first step is we have to create our own container image. Yes, it is completely free. Okay, don't worry about that. We will come on that. First, let us understand the container image creation. Okay, then we will come on publishing Docker image on Docker Hub, and we will understand whether it is free or charged. Okay. So to create the container image for my application, which is, let's say, developed by my company. So first, what I have to do, I have to first deploy a container. then host, or I would say deploy the application inside the container. Then the third step is I have to create an image from that container. Now to create image from the container, we have to use this command, docker commit docker commit, then the container name, and then your image name. Okay, let's say I want to name this image as my image. So to create the image, we have to use this command, docker commit, then the container name, and then the image name. Now if we do docker image ls, so here you can see we have successfully created a docker image. Here you can see created just 15 seconds ago. This image we have created, and we have created this image from this container. Just like we create image of a EC2 instance, right? Suppose this is my EC2 instance running, and I want to create a AMI of this EC2 instance, right? So we click on actions, then we go on create image. The same thing we have done here with our container. So we had one container running, and with the help of this command, we have created an image of that container, right? So to create the image, we need to use this command, docker commit, then the container name, then your image name, whatever name you want to give. Okay, so I gave my image name as my image.
What does ELK stand for in the context of continuous monitoring? Option A, Elastic, Logstash, Kibana. Option B, Efficient, Logfile, Kafka. Option C, Enterprise, Logging, Kubernetes. Or Option D, Elasticsearch, Logstream, Kafka. Comment down your answer below in the comment section. Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world, and after going through hundreds of jobs descriptions for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
And after that, when we are running docker image ls, we are able to see here that image created. Okay, so creation of image is completely free. We are not charged for creating the image. Okay, so the same way you can create any container image. So you just need to follow these steps. First, you need to launch a container, then deploy your application inside the container, and then create an image of that container. To create the image, you need to use this command, docker commit, container name, and then the image. Okay, the image name which you want to give. The image currently is residing in our Docker host. Okay, this Docker image which we have created, this container image which we have created, currently is in our EC2 instance or in our Docker host. Yes, it means our EC2 instance. Now let us publish this Docker image, container image, which we have created to Docker. So Nathan Kumar, the container image will have both operating system also and the application also. It will come with both. First of all, without operating system, tell me how you can run a web server. Without operating system, you cannot run a web server. See, without operating system, you cannot run any application. Okay, so when you are running Apache, Nginx, or any application, first of all, you need an operating system, right? So in our case, also in this image, we have the application and we also have the operating system. Without operating system, there is no application. You cannot run any software, any application without operating system. Just understand it in this way. Suppose you have a laptop and in that laptop, you don't have Windows 10 and you want to run Google Chrome. Google Chrome is a software, right? Or you can say a web browser application, desktop application basically. So if you want to run that application, you need the operating system. Without operating system, you cannot run the application. Okay. So the image will contain both the application also and the operating system also. Without operating system, there is no application. Okay. Now let us publish this Docker image to Docker. Okay. Now let us publish this Docker image to Docker. So to publish this image to Docker Hub, you need to create a Docker Hub account. Okay, to create a Docker Hub account, you need to go to this site, hub.docker.com. Okay, I will update the links and the information, everything in the sheet. Just give me a minute. Okay, check the sheet. I have updated it with all the commands and the link to Docker Hub as well. Okay, so to create a Docker Hub, to publish images on Docker Hub, first you need to create an account. So you need to go to this site, hub.docker.com. On your browser, open hub.docker.com. I've shared the link in the chat as well. Also, I have updated the sheet with all the commands which we have learned so far and as well as the link. Okay, so on this site, you will see here one button of register. Click on that. Then you need to provide a username, your email address, and password. Okay, then you need to agree to these terms and conditions and then sign up. Okay, the account creation is very straightforward. You just need to give a username, email address, and password. That's all. I have already created an account, so I'll not be doing the, I would say, sign up part. The sign up part is straightforward. Just provide your username. Username can be anything. Then your email address and your password. Once you do that, your Docker Hub account will be created. So to publish images on Docker Hub, first we need a Docker Hub account. Without Docker Hub account, we will not be able to publish images on Docker Hub. And publishing images on Docker Hub is completely free. We are not charged for hosting images or publishing images on Docker Hub. So once you have created the account, Just sign into your account. Okay, so to log into your Docker Hub account, you need to log in with your username, which you have provided at the time of creating your Docker Hub account, and your password, which you have set at the time of creating your Docker Hub account. Okay. Now, once you will log into your Docker Hub account, your account will be empty. In my case, I have some repositories already here. Okay. When you will be logging in, your account will be completely empty. In Docker Hub, to publish images, we need to create a repository. Okay, so we will be creating a repository here. Then we have to give a repository name. Repository name can be anything. Let's say my app image. And description again can be anything. Then you have to tell whether you want your Docker image or this repository to be publicly accessible, or whether you want it to be private. So right now we will make it as publicly accessible, which means anyone on the internet will be able to pull this image. Okay, pull image from our repository. Then create. Actually, I already have a repository by that name. That's why it didn't got created. Okay, so the repository is now successfully created. Now let us see how we can push this container image, which we have created in our EC2 instance, to Docker. And then we will see how people on the internet can pull our image and deploy a container with our image. Okay, so to push the image to Docker Hub, first we need to tag the image. Okay, tagging is just like renaming the image. Okay, we need to rename the image in a specific format in order to publish it to Docker Hub. So to rename the image, you need to use this command docker tag and then your current image name. Then you have to give your Docker Hub username. You have to specify this format in which you have to first give your Docker Hub username, then your repository name. First is your Docker Hub username. The second part is your repository name, which you have created in your Docker Hub account. So the command is docker tag and your current or your existing image name, which is currently sitting in your EC2 instance. Then you have to rename it to your Docker Hub account username and the repository name, which you have created in your account. Plus, you also need to specify a tag. Okay, tag can be anything. Right now, I'm giving here latest tag. Now, if you run Docker image ls, so you will be able to see a new image. Okay, starting with your Docker Hub username and your repository name, which you have created in Docker. Now we will push this Docker image to Docker Hub. In order to push it, first we need to authenticate with our Docker Hub account. Okay, after renaming the image, we have to authenticate with our Docker Hub account. So to authenticate with the Docker Hub account, we need to run this command docker login. Now, when you will run docker login command, it will ask you username and password. So username will be your Docker Hub username and password will be your Docker Hub password. So if your credentials are correct, you will see here message login succeeded. Yeah, because here this image is actually the replica of this image. That's why the creation time is same. Here, no new image is created. Even if you see the image ID is also the same. Image ID is same, size is also same, just the name is different. That's why the creation time is same. Okay, and we have not created a new image. Okay, here we have not created a new image, we have just renamed an existing image. Okay, so yeah, after that you have to run docker login, and when you will run this docker login command, it will prompt you for your username and password. And after that, you will be able to see this message, login succeeded. After that, you need to run this command docker push, then the image name, which is currently sitting in your EC2 instance, docker push, then your Docker Hub username, and then the repository name. And then you also need to specify a tag. Yeah, you can see now it is preparing and it is going to push the image to Docker Hub. Here you can see pushing. Pushed. Once this is completed, yeah, here you can see this is completed. And now we will be able to see the image here in Docker Hub. Okay, now here you can see we are able to see the image here. Here you can see it is pushed just a few seconds ago. Now anyone on the internet can run this command to download my image. And even you can search this image on Docker Hub. You can simply search for this name, this username, and let's say my app image. Yeah, my app image 001. So now anyone on the internet can search for my image by my username and my repository name. Here you can see right now when I'm searching by my username, I'm able to see all the images which are available in my repository. And this is the image which we just created. This is the repository which we just created. Now anyone on the internet can simply run docker pull command and this image and can download, can pull my image and deploy a container with that. Okay, so what currently we have done is, let us visualize this. First, what we have done in our EC2 instance, we have created a container image. Okay, in our EC2 instance or in our Docker host, we created a container image. Then we published this or we pushed this image to an image registry, which is in our case, which is Docker. Right? In our EC2 instance, we created a Docker image and then we pushed this Docker image to Docker. Okay. Now let's say I want this image to be accessible, or I would say I have a customer and I want that customer to access this image, or I would say to use this image to deploy my application. Right? So first of all, that customer will require a server, and in that server, the customer needs to install Docker. Right? Suppose let's say the customer is also using a EC2 instance. So in the EC2 instance, the customer need to install Docker. And after that, the customer need to run Docker pull command. Docker pull and the image name of my image, right? To download this image to his EC2 instance or to his Docker host. And then once the image is full, then the customer can deploy a container with that image. In the same EC2 instance, I will delete all the container images. Okay, I will delete all the container images. Before that, I will stop all the containers. To stop the container, we'll use this command, docker stop, then the container name. Okay, now in Docker, there is a command. Suppose, let's say you want to perform a cleanup of all the containers, all the stopped containers, and all the images which are running, which are in your Docker host, which are currently not in use by any container. Again, in my Docker host, I want to perform a cleanup of all the stopped containers. Cleanup in the sense I want to get rid of all the stopped containers, and I also want to get rid of all the images which are present in my Docker host, which are not currently in use by any container. So to do that, we can run this command, docker system prune. Docker system prune. Now, when you will be running this command, what it is going to do? It will delete all the stopped containers, all networks. Network we are not talking, we are not using. Then it will delete all the images and build cache. Build cache we'll talk later when we will be learning about Docker file. Okay, so it has deleted all the containers, but images, I think it has not deleted all. Yeah, so in order to get rid of images, or I would say you can use this command, docker system prune -fa. Okay, I will share this command on the sheet, docker system prune -fa. With this command, all your stopped containers will be removed, plus all the images which are present in your Docker host will also be removed. This is a very helpful command. Suppose you have 100 images and you want to delete those 100 images in order to free up some storage in your Linux server, right? So to do that, you can simply run this command. Else you have to use that docker rm command again and again. Suppose there are 100 images, so you have to run that docker rm command 100 times, right? But with docker system prune command, at one shot, you will be able to delete all these stopped containers and delete all the images which are currently not in use by any container. So right now my EC2 instance or my Docker host is completely clean, which means it doesn't have any images and it doesn't have any containers. So currently I have simulated this kind of environment where, let's say in my EC2 instance, I just have Docker installed. I don't have any container or I don't have any image. Now let's say I want to use this container image, which is created by, which we have published to deploy a container. So to do that, first we need to pull the image. To pull the image, we will use the docker pull command and then the image, which is this docker rm command if you want to delete only 20. But you can also automate that using shell script or Python script. But yes, you have to, if you are doing it manually, then you have to use the docker rm. Okay, so first we need to pull the docker image. So with the help of docker pull command, we have pulled the docker image. Now if we do docker image ls, so that image is now available in our EC2 instance or in our Docker host. Now let us deploy a container with this docker image. And then the image. Docker run -d to run the container in background. And I am specifying this as the container name. Then I have done a port mapping and then the image. Now if we do docker ps, so we have a container running. And now if we try to access the application, so we are also able to access the application. Now anyone on the internet can just run these two commands. One is docker pull and this command in order to deploy my application. Anyone on the internet can just run these two commands to deploy my application. Right? That's what we did right now. Right? First, we pulled the image from Docker Hub and then we deployed a container with that Docker image. And after that, we are able to access the application. So right now, what we have done, we have created our own application image. Suppose this application is developed by my company. So now we have right now created an application image. So when someone is going to use my application image to deploy a container, that container will have this application running. And the customer will be able to access this application. Right? So you can also try it at your end. You just need to run these two commands, docker pull. I'll share the commands on the sheet. Docker pull, and then run this command. And then try to access it by your EC2 instance IP. Sorry, your EC2 public IP. And then the port which we have opened, then type demo app. So you will also be able to access the application.
So let's start with what is DevOps. DevOps is a set of cultural concepts, practices, and tools that improves an organization's capacity to provide applications and services at high speed. If I talk about what exactly is DevOps, it is actually collaboration of development and operations team. It is more of a cultural shift, which is kind of related to the Agile methodology. And its priorities are resource management, communication, and teamwork. And an organization get benefited by the speed, functionality, stability, and innovation by following this methodology. I hope so it's clear to you what exactly is DevOps. Now, let's move forward and discuss the next question. The next question is, how does HTTP works? And the answer to the same question is, HTTP stands for Hypertext Transfer Protocol, which works in a client-server model like most other protocols. HTTP provides a way to interact with the web resources by transmitting hypertext messages between clients and servers. So, there is an HTTP request by the client, and in response, there is an HTTP response given by the server. This is how the HTTP works. Now let's move forward and discuss the next question. The next question is, what is CI and what is its purpose? Actually, CI stands for Continuous Integration, which is the process of compiling the entire code base every time a member of a software development team checks the code into the shared code repository. Suppose if a team member checks into the code file with a bug, the build gets broken. In this sort of scenario, the other developers can synchronize the shared source code repository without introducing the compilation errors into their own local workspaces. Thus, collaborative and shared software development cannot go forward. When a CI build breaks, it is crucial that a problem is corrected immediately. A CI process often includes a suite of unit and integration and regression tests that run every time the compilation succeeds. If any of these tests fail, the build will be considered unstable, not broken. I hope so it's clear to you what is CI and what is its purpose. Now let's move forward and discuss the next question. The next question is, name 3 important DevOps KPI. And the answer are, the 3 most common DevOps KPIs are, first, mean time to the failure recovery. Then there is a deployment frequency. And finally, we have percentage of failed deployments. I hope so it's clear to you what are the 3 important DevOps KPI. Now let's move forward and discuss the next question. The question is, what is the difference between continuous deployment and continuous delivery? Continuous deployment is fully automated and the deployment to production needs no manual intervention in continuous deployment. Whereas in continuous delivery, the deployment to production requires some manual intervention for change management in the organization, and it needs to be approved by the manager or higher authorities to be deployed in the production. According to your organization's application risk factor, continuous deployment or delivery approach will be chosen. I hope so it's clear to you what is exactly the difference between continuous deployment and continuous delivery. So basically, if I talk about the continuous delivery, your code is done first, then you go for unit test, then you integrate, then there is an acceptance test, and finally you deploy it to the production. And in the continuous deployment, we have first the code is done, then there is unit test, then there is integration, then there is acceptance, and from acceptance test to deployment production, the test is done automatically, where in the continuous delivery, it is done manually. I hope so it's clear to you what is the major difference. Now let's move forward and discuss the next question. The question is, what are the core operations of DevOps in terms of development and infrastructure? The core operations of DevOps are application development, version control, unit testing, deployment with infrastructure, monitoring, configuration, and orchestration. I hope so it's clear to you what are the core operations of DevOps. Now let's move forward and discuss the next question. The next question is, can one consider DevOps as an agile methodology? And the answer is, DevOps can be considered as an complementary to the agile methodology, but not completely similar. Now let's move forward and discuss the next question. Can you tell me what are the advantages of using Git? So if the interviewer asks you this question, you can answer the major advantages of using Git are data redundancy and replication. Then we have high availability. Then we can discuss of only one Git directory per repository. Moving ahead, you can say something like this. There is a superior disk utilization and network performance. It is collaboration friendly, and finally, it can be used for any sorts of projects. I hope so it's clear to you what are the advantages of using Git. Now let's move forward and discuss the next question. The question is, are Git fetch and Git pull the same? This is one of the most important questions which is asked in DevOps. So you can answer something like this. The command git pull pulls any new commits from a branch from the central repository and then updates the target branch in the local repository. But git fetch is slightly different from git pull. Unlike git pull, it pulls all new commits from the desired branch and then stores them in a
What is the primary purpose of Terraform modules? Option A, to define variables. Option B, to organize and reuse Terraform code. Option C, to configure provider settings. Or option D, to execute Terraform commands. Comment down your answer below in the comment section. Just a quick info guys, Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs descriptions for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
New branch in the local repository. In order to reflect these changes in your target branch, Git fetch must be followed with Git merge. The target branch will only be updated after merging with the fetch branch, where we performed the Git fetch. We can also interpret the whole thing with an equation something like this, where Git pull equals to Git fetch plus Git merge. I hope so it is clear to you what is the major difference between Git pull and Git merge. Now let's move forward and discuss the next question. The next question is, what are the benefits of using version control? And you can answer something like this. The major benefits of using version control are that it helps to improve the collaborative work culture, which means that the team members are allowed to work freely on any file at any time. The version control system allows us to merge all changes into common version. The next advantage is that it keeps different versions of code files securely, where all the previous versions and variants of code files are neatly packed up inside the version control system. Then it understands what happened. Every time we save a new version of our project, the version control system asks us to provide a short description of what was changed. More than it allows us to see what changes were made in the file content, as well as who has made those changes. The next advantage is it keeps the backup. It is a distributed version control system like Git, which allows all team members to have complete history of the project file, so that in case there is a breakdown in the central server, they can use of their any teammates' local Git repository. The next question is, how do you handle the merge conflicts in Git? The answer to the same question is, in order to resolve the merge conflicts in Git, we need to follow these three fundamental steps, and these are: understand first what has happened. It could be because of the same line edit on the same file, or also it could be because of deleting some files, or it could be because of files with the same file names. You can check everything by using the Git status. Then mark and clean up the conflict. When we open the files using the merge tool, Git marks conflicts the area like this. Then it performs the commit again and then merge the current branch with the master branch. I hope so it's clear to you how you can handle merge conflicts in Git. The next question is, can you tell me some advantages of forking workflow over the other Git flows? And the answer to the same question is, forking workflow is fundamentally different from the other Git workflows. Instead of using a single server-side repository to act as a central code base, forking workflow gives every developer their own server-side repositories. This workflow is most often seen in the public open source projects. The main advantage is that contributions can be integrated without the need for everyone to push a single central repository to maintain a clean project history. Developers can push their own server-side repositories, and only the project maintainer will push to the official repository. As soon as developers are ready to publish their local commits, they will push their commits to their own public repositories. Then they will perform a pull request from the main repository, which notifies the project maintainer that an update is ready to be integrated. I hope so it's clear to you what are the advantages of forking workflow with other Git workflows. Now let's move forward and discuss the next question. The next question is, when do you use Git Rebase instead of git merge? The answer to the same question is both git rebase and git merge commands are designed to integrate changes from one branch to the another branch, just that they just do it in different ways. When we perform the rebase a feature of branch onto the master branch, we move the base branch of a feature branch to the master's branch endpoint. By performing a merge, we take the contents of the feature branch and integrate them with the master branch. As a result, only a master branch is changed, but the feature branch history remains the same. Merging adds new commit to your history. Rebasing will create inconsistent repositories. For individuals, rebasing makes a lot of sense. Now, in order to see the history completely, the same way as it happened, we should use merge. Merge preserves history, whereas rebase rewrites it. I hope so it's clear to you when do you use git rebase instead of git merge. The next question is kind of interesting, and interviewers can also give you scenario type questions. Suppose he says, if I want to move or copy Jenkins from one server to the another, is it possible or not? You can answer something like this. Firstly, I would suggest copying the Jenkins jobs directory from old server to the new one. Then we can move a job from one installation of Jenkins to the another just by copying the corresponding job directory. Or also we can make a copy of an existing Jenkins job by making a clone of that job directory in a different name. Another way is that we can rename an existing job by renaming the directory. But if you change the name of a job, you will need to change any other job that tries to call the renamed job. In this way, you can move or copy the Jenkins from one server to the another, and which forms the perfect answer to this question. Now let's move forward and discuss the next question. Now let's discuss the next question. An interviewer can ask you something like this. Can you tell me what continuous testing and automation testing are? And you can answer something like this. Automation testing, as the name suggests, is a process of automating the manual process of testing. It involves the use of separate testing tools that lets developers to create test scripts that can be executed repeatedly without any manual intervention. Whereas the continuous testing is nothing but the process of executing the automated tests as a part of the software delivery pipeline in DevOps. In this process, each build is tested continuously, allowing the development team to get fast business feedback so that it can prevent the problems from progressing to the next stage of software delivery lifecycle. This will dramatically speed up a developer's workflow. He or she no longer needs to manually rebuild the project and rerun all the tests after making the changes. I hope so it's clear to you what is continuous testing and automation testing. You can answer something like this. An interviewer will definitely get impressed. Now, let's move forward and discuss the next question. The next question is, are there any technical challenges with Selenium? So, you can answer something like this, that there are certain challenges with the Selenium, such as it supports only web-based application, it does not support the bitmap comparison, no vendor support is available for Selenium as compared to the commercial tools like HPUFT, and finally, there is no object repository concept. Maintainability of objects becomes very complex. So these are kind of technical challenges with the Selenium. I hope so it's clear to you. Now let's move forward and discuss the next question. The next question is, when should you use Selenium Grid? And the answer to the same question is, it can be used to execute the same or different test scripts on multiple platforms and browsers concurrently in order to achieve distributed test execution. It allows testing under different environments, remarkably saving the execution time. I hope so it's clear to you. In this scenario, you can use the Selenium Grid. Now let's move forward and discuss the next question. The next question is, how will you secure Jenkins? If the interviewer asks you this question, you can answer something like this. The way to secure Jenkins is as follows. First, ensure that the global security is on. Then, check whether Jenkins is integrated with the company's user directory with an appropriate plugin. Then you can say something like this. It also makes sure that the project matrix is enabled to fine-tune the access. Then you can automate the process of setting rights or privileges in Jenkins with custom version control script. Then you can limit the physical access to the Jenkins data or folder. And finally, you can also periodically run the security audits. I hope so it's clear to you how you can secure the Jenkins. Now let's move forward and discuss the next question. The next question is how to create backup and copy in Jenkins. So if the interviewer asks you this question, you can answer something like this. To create a backup, all we need to do is periodically back up your Jenkins home directory. This contains all of the build configurations of our job, our slave node configuration, and our build history. To create backup of our Jenkins setup, just copy this directory. We can also copy a job directory to clone or replicate job or rename the directory. I hope so it's clear to you how you can create backup and copy in Jenkins. Now let's move forward and discuss the next question. The next question is, what is Jenkins pipeline and CI/CD? The answer to the same question is, Jenkins pipeline can be defined as a suite of plugins supporting both implementation and integration of Jenkins continuous delivery pipeline, whereas CI/CD or continuous integration or continuous delivery pipeline consists of build, deploy, test and release. The pipeline feature is very time saving. In other words, pipeline is a group of build jobs that are chained and integrated in a sequence. I hope so it's clear to you what is Jenkins pipeline and CI/CD. Now let's move forward and discuss the next question. The next question is, what are Puppet manifests? So this is one of the most important interview questions which can be asked by the interviewer, and you can answer something like this. Every Puppet node or Puppet agent has got its configuration details in Puppet master, which is written in native Puppet language. These details are written in a language that Puppet can understand and termed as Puppet manifests. These manifests are composed of Puppet codes and their file name uses the .ppp extension. For instance, we can write a manifest file in Puppet master that creates a file and installs Apache on the Puppet agents or slaves that are connected to the Puppet master, which forms the Puppet manifest. I hope so it's clear to you what exactly is Puppet manifest. Now let's move forward and discuss the next question. The next question is, how can I configure systems with Puppet? This is also one of the most important interview questions, and you can answer something like this. In order to configure systems with Puppet in a client or server architecture, we have to use the Puppet agent and the Puppet master application. In a standalone architecture, we have to use Puppet apply application. I hope so it's clear to you how you can configure systems with Puppet. Now let's move forward and discuss the next question. Now let's discuss the next question. It is also an interesting question, and the question is, what is Puppet code dir is? So if the interviewer asks you this question, you can answer something like this. It is a main directory for code and data in the Puppet. It consists of environments containing manifests and modules, a global modules directory for all environments and your hero data. The next question is, name some of the most important DevOps tools. So the answer to the same question is, the list of important DevOps tools are Git, Maven, Selenium, Jenkins, Docker and Puppet. This is one of the most important questions. An interviewer is definitely going to ask you this one. So be aware of it about some of the most important DevOps tools. Now let's move forward and discuss the next question. Now let's discuss the next question. And the question is, how does Ansible works? This is also one of the most important questions which can be asked by the interviewer, and it can be on any tool which you are comfortable with. So here I have chosen Ansible, and you can answer something like this. Ansible is an open source automation tool which is categorized basically into two types of servers. The first is controlling machines and second is nodes. Ansible will be installed on the controlling machine, and using that machine nodes are managed with the help of SSH nodes. Locations are specified by inventories in that controlling machine. Since Ansible is an agentless tool, it doesn't require any mandatory installations on the remote nodes. So there is no need of background programs to be executed while it is managing any nodes. Ansible can also handle a lot of nodes from single system over an SSH connection with the help of Ansible playbooks. Playbooks are capable of performing multiple tasks and they are in YML file format. So this forms a perfect answer to this question. Now let's move forward and discuss the next question. The next question is, why should I use Ansible? If the interviewer asks you this question, you can answer that Ansible can help in configuration management, application deployment, and task automation. That's why I'll prefer to choose Ansible. This forms the perfect answer to this question. Now let's move forward and discuss the next question. The next question is, what are handlers in Ansible? This is one of the most important questions, and you can answer something like this, that handlers in Ansible are just like regular tasks inside an Ansible playbook, but they are only run if the task contains a notify directive. Handlers are triggered when it is called by the another task. I hope so it's clear to you what is handlers in Ansible. Now let's move forward and discuss the next question. The next question is, can you tell me the purpose of SSH? So if the interviewer asks you this question, you can answer something like this. SSH is nothing but a secure shell that allows users to log in with secure and encrypted mechanism into remote computers. It is used for encrypted communications between two hosts on unsafe network. It supports tunneling, forwarding TCP, and also transferring files. I hope so it's clear to you. It is one of the most important questions which can be asked by the interviewer. Now let's move forward and discuss the next question. The next question is, what is an RPE in Nagios? So if the interviewer asks you this question, you can answer something like this. An RPE stands for Nagios Remote Plugin Executor. As the name suggests, it allows you to execute Nagios plugins remotely on any other Linux or Unix machines. If I talk about Nagios, it can be helpful in monitoring remote machine performances metrics such as disk usage, CPU load, etc. It can communicate with some of the Windows agents add-ons. We can execute scripts and check metrics on remote Windows machines as well. I hope so it's clear to you what is an RPE in Nagios. Now let's move forward and discuss the next question. Now let's discuss our final question, and this is, what is Nagios log server? So if the interviewer asks you this question, you can answer something like this. Nagios log server simplifies the process of searching the log data. Nagios log server is the best choice to perform tasks such as setting up alerts, notifying when potential threats arise, simply querying the log data, and quickly auditing any system. With Nagios log server, we can get all of our log data in one location with high availability. So this defines the Nagios log server. I hope so it's clear to you what's the answer of this question.
Just a quick info guys, Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.